En, to, en, to, en, to.
Well, hello. Thanks for coming to my talk. Uh, this is an exciting fisheye view of a large hall, which will be thrilling. Well, as my talk says, I'm going to go over platform engineering for private cloud, one of the more thrilling titles I've ever used in that presentation. And what I want to cover, as it would, say, is not only looking at platform engineering itself, but some of the things that's different when you apply it on your dedicated environment, your own infrastructure. Now, what exactly private cloud is fluid, but I generally think of it as primarily if you're running it, you could say on premises, your own infrastructure. And to some extent, it could also be if you're treating, let's say, cloud infrastructure as just kind of, and this sounds pejorative, but let's call it dumb infrastructure, something that you build your own stack on top of and run your own thing instead of using something that is very close to developers. And I think, it's very popular nowadays. And there's an evolution from all of these things. And what's interesting about it, what's great about it being in the line of work that I'm in, is there really is this continuous evolution we have of trying to finally crack making infrastructure easier for developers to use, thinking about how we make it not only easier for them to deal with infrastructure directly, or as we like to say, you know, write more code and think about their application more. And hopefully this time it'll stick. This is definitely the most characters we've used since IT service management in the 2000s to describe this endeavor. So maybe instead of shortening it like we've done in past ones, once we finally have a long descriptive word, it'll hold. But we'll see. We like to go in cycles for things. So why private cloud? Well, I think when I've been interested over my career in where workloads are, kind of what the movement towards various types of infrastructure, whether it's private cloud or public cloud are. And so it's good to check in every now and then, maybe, I don't know, depending on how feisty you're feeling, every year or every 2 years, and ask the question, not so much what kind of excitement and revenue is around the various places, mostly public cloud, that you could move, but where are the workloads? Where are the applications? And this is pretty important for platform engineering because probably, unless you figured out some strange exotic use case, if you don't have applications, all the platform engineering you're going to do is not really important or worth anything, right? The point of platform engineering is to support applications that you're running. Sure, you want to have things that are secure. It should be performant. You probably want some database services. I always think it's important to remind ourselves of the number one requirement: it should work. But those are things that any sort of engineering or approach could give you or would purport to. But starting off with understanding where these applications are running that you'll be supporting, or if you prefer a very old term, workloads, which I might slip into doing, I think is important. So I'm going to spend the first time talking about that location of workloads because I don't think it's really discussed very much. And the implications, what you need to do for platform engineering to be successful and useful, aren't always based on or directly tied to this place that they're running. It's kind of if you remember, it's kind of a medium is the message or the medium is the infrastructure. I'm going to work on that phrase a little bit more because that didn't work out so well. So this is just a brief introduction to myself. I've been lucky to work at Pivotal, and then that was VMware, and now it's the Tanzu division by Broadcom, as I recall, for 10 years. And in that role, I've spent most of my time talking with large organizations about how they get better at software, their custom-written software. And I've gotten to write several little books. Before that, I was a software developer. I worked on cloud M&A at Dell. You remember when OpenStack was a big deal and everyone was going to build a public cloud out of OpenStack? There's fun stories there. And I've been an analyst at a place like called RedMonk for a while, and then 451 Research. Anyhow, and I was a programmer way before that, long, long ago. I host a couple of podcasts, including one that I forgot to put one up here. But as my friend Andrew Schaefer used to say, engage with my brand. There it is. Now moving on. So let's get into that thing, where are the applications, right? And again, to emphasize this, knowing where these applications are is going to drive some significant ways to how you think about doing platform engineering, what it is. So finding this is surprisingly hard. And there are estimates kind of locked up behind analyst paywalls, one of which I'll show you here. But if you spend a little bit of time looking at the experts on where they say the applications are, you can start to get some idea and get to that number that I had up there, that it's about 50%, maybe it's 40, 60, I don't know. We'll see. So first of all, back in January, I guess we could go to some people who are the best experts at this, the people at Amazon. This is a quote from their, the AWS CEO, and it is scoped, as you can read it, down to large organizations, which is the ones I'm most interested in. And I think the ones where probably platform engineering has probably the widest relevance, and this idea of platform engineering in private cloud certainly has the most relevance. And you can see, I try not to do math in public, but if you do this math here, I think that amounts to 90 to 60% of workloads in large organizations have most of their workloads or a lot of their workloads on private cloud, right? Or whatever you want to call it, dedicated infrastructure on premises. They're running it with outsourced to managed service providers, but it's not cloudy infrastructure. And so that starts to give you an idea with a crazy big range. Of course, this is across, it's not an average, it's just various customers, of the amount of applications that are there. Now, here's another, this is something that if you read IDC, like I do, being a former analyst, I have maybe a different relationship with analysts. I think their work is pretty good. And if you read them year over year, you get a sense of the momentum and the way they're doing things, and who you can trust, like who's making up surveys and who not. And I think IDC is quite reliable here. And this is some recent findings from their Cloud Pulse report, a survey that they do about every year, with survey and estimates, a report, if you will. Unfortunately, they get very upset if you use their data from 18 months or older. I'm not sure what that says about its validity 18 months ago, but if you can trust me, remember I wrote all those books and I have a smiling face, do podcasts, so I'm trustworthy. What you would see is that these numbers more or less have been creeping around the same level for about 10 years or so. I don't know, maybe 8 years. I lose track of time as I get older. But here, and this is why I keep saying dedicated environment, they're very prickly about not saying private cloud, it's dedicated environment, which, sure, sounds great. But if you add these up, you see that it's just under 15% of dedicated environment, although they slip into dedicated cloud down there, so maybe we should send them a note about things. But you get this sense that it's around half and half, around 40-60, something like that. Now, there's all sorts of other figures, depending on what kind of charts you like. There's some from Barclays and Goldman Sachs that are particularly good if you really want to get deep into looking at where these applications are. But when you look over all of them, as I keep saying, you kind of arrive, or at least I arrive, at this conclusion. And especially, as the AWS Matt was saying, when you look at larger organizations, this holds a whole lot more. Now, thankfully, I have a philosophy degree, so I'm very comfortable with ambiguity and just kind of like approximations. So these numbers make me happy. I don't really need much more precision than that to figure out that that's kind of the area that we're working in there, right? So the point being, there is a significant amount of applications running on premises, running on private cloud, running in a dedicated environment, right? And what this starts to mean is that there is, let's say, organizational ownership and responsibility of the stack in both good and bad ways. And so when you come in and you want to build a platform, again, a platform being to support applications, to support developers, we'll get into what that entails as far as different things that team or those teams need to do than if they were just kind of supporting a full stack that they didn't necessarily own and have responsibility for. So with that, let's define what a platform is. It's always good when you're talking about something to define it yourself so you can say, well, that's not my definition of something when you're objecting to it. So here, I will do that. So first of all, if you haven't been following platforms and platform as a product for a while, there's a great talk that was just was given and then published by Paula Kennedy here, who I used to work with. And you can see that the timeline of platforms is quite long, right? If you want to do something like throw in platform as a service, if you remember that term, with places like Heroku and others, like way back when, it kind of goes back further. But this is actually a really delightful overview of the idea of what a platform is. And you can see the long timeline that it's gone through. And a lot of funny, subtle jokes about how we keep repeating ourselves over and over again from Paula there. So I realize you can't click on that now, but perhaps later. Maybe there's some talks you're not interested in. You get worn out. You want to enjoy a croissant or a hearty sandwich. It's a good 25 minutes to spend if you're really into platforms. So any talk on platform engineering is required to begin by quoting Evan's 2018 definition of a platform, which I have here, so I'll move on. Now, recently, in the past 3 or so years, I think there was a resurgence in and kind of a creation of the category of platform engineering. Arguably, the good folks at Humanitech kind of kicked this off when they were taking their internal developer portal and they wanted to do some market category creation, which is great. You want to create a market category that perfectly fits the thing that you have to sell. And if you remember, they declared that DevOps was dead, and that kicked off 2 years of fantastic conversation. But I think we've kind of arrived at this notion, as I was joking with that Dune picture at the beginning, that platform engineering is what we call all of this stuff, how infrastructure people, operations people are trying to support developers as much as possible. Now, There was, like I said, I lose track of time. So let's say about 2.5 years ago, the first thing that emerged was that the P in internal developer platform actually stood for portal, if you remember that. And this was when Spotify open source Backstage. It was like this great portal, if you will, internal for developers, hence an IDP. And there was a lot of interest in it, there still is, and a lot of kind of thinking about it as the kind of, this is going to be not quite accurate, but the UI for Kubernetes, if you will. The UI for a stack that you have mixed in with the project management that goes with team, making, to use a fancy term people like, making what various teams are doing inside a company legible, kind of knowable, making it a lot more standardized. And that was kind of dragged in, and that's also what Humanitech did. It dragged in this notion of a platform. Now, very quickly, as happens often, the analysts swooped in, did some great diagrams, and you can see that what happened is the notion of a platform expanded to be more of the infrastructure, going further down than just that portal on top. And then a memo was sent out to all of us in the platform world that the P now changed to platform from portal. Portal is just a part of what a platform is, right? Now, here are two diagrams of what a platform is. The one on your right, of course, is the best platform you'll ever encounter. You should definitely be using it and insisting that you have it because I work there and I like to pay my bills and profit from that. Thank you for sending me here, Tanzu Division by Broadcom. Now, if you're not into vendor pitches and you want a vendor-neutral way of thinking about the world, which is always great, the CNCF, the Cloud Native Computing Foundation, has a great reference architecture that they came out with a number of years now. And what you see in that architecture, there's two important things. I mean, I guess bridging to the portal part, you can see that the portal is just one part of what that big old, whether you think of it as a cake or a very complex, tasty burger, depending on how hungry you are and what you like to eat, you can see that the portal is just part of it. But as you look through all of those things, maybe it's not too insightful or revelatory, but what you see is the components in there are all oriented around what people who have hair color getting slightly lighter and whiter as me would call middleware. Maybe that's a terrible word. You could call it services, if you like, components, frameworks, whatever word you enjoy using that makes you feel younger and more zesty instead of something like middleware. But you can see you've got databases, event queues. There's some things that are a little subtle to see in there, how you package and deploy your applications. We used to call it a release train, I think. Then it was a secure software supply chain. All sorts of phrases and words if you like these things. But there's also a little chunk of infrastructure-y stuff, right, that's included in there as well. And I think the theory of this, well, I guess it's the practice of this, is the more sort of embedded you have all of these things, the more you can integrate all these things, the easier it becomes for developers because the more automated and standardized you can make them, and therefore the more self-service that you have. And hopefully, the less your application developers have to spend time thinking about, how do I package up this application? How do I express the dependencies and a multi-regional deployment of things like that? And especially not having, not wanting them to invent those things. I think the third interesting thing about this to kind of have in your head is that even coming from the home of everyone's favorite Kubernetes, the CNCF Foundation, Kubernetes doesn't really show up here. And that's, at least in this diagram, nothing against Kubernetes, but it's more to say the infrastructure is not really part of the platform, right? That's not the important part of it. Infrastructure is some other thing of it, down there in the purple layer. I always think, I don't like to criticize people's work, but I'm not really into those Easter color pastel things, kind of darker colors. But that kind of purple Easter egg there that you have down there, that's where the infrastructure lives. So that's another thing that you want with the platform is more or less infrastructure agnosticism. Now, is that perfectly possible all the time? We sure would like it to be every 5 or 10 years. To bring back another phrase from the history's past, we want multi-cloud and portability. We want to avoid lock-in. And it'd be great to hear anyone who's been consistently successful with that. over the past few years. That would be a breakthrough paper. Maybe we can go to IT Revolution Press, put together a working group, and have like a 5-10 page PDF about like, we did it! Multi-cloud, application portability. It only took us 2 days to move to a completely different stack of infrastructure. So what does a platform team do? Well, here is a good, I think, roles and responsibilities division of things. There's a lot more things, but this is a nice summary. And you can see, you've got your application teams, developers, as people would say. You've got your platform teams. And then you also have more that your platform teams do along this spectrum, right? So your developers are there, writing their code, doing the things they're responsible for. They're hooked up to the tools that you have, the pipelines, all of those things. And the sense you should get from what the platform team is doing is they are, to put it one way, they're curating and developing the services that are in a platform. They're making sure that it's integrated together. They're taking care of all those thrilling meetings with networking and security people and auditors, right? They're doing a lot of the work to say this platform not only makes the application developers work easier. I don't know about their lives, because you might, every time you're more efficient. This is the fun thing about AI, is you should be asking, I'd love to use AI, and if I'm like 25% more productive, does that mean I can go home early and maybe work 4 days a week? Because really, if you're more productive and you don't get anything from it, you're getting kind of a raw deal. So make sure that you pay attention to what your productivity increase is and be like, now I'd like to not do more work, or get compensated for it somehow. Anyhow, where was I? Yes, so what you see these platform teams doing is kind of upward doing that, kind of making it easier for developers. But a lot of the hidden work that they do is making sure that all of the downward-facing things, and there's nothing pejorative about the directions, you could reorient it to, 45-degree angles, or if I knew my nautical terms, port and starboard or something. But you can see that they're doing a lot of the work to fix it into the rest of the organization, right? And there is, I think it's a little unknown. I haven't heard a lot of discussion of this. I think it's a little unknown about who actually does what I would call the management, the monitoring, the troubleshooting, the root cause analysis for things up and down the stack. I think the platform engineering team does a fair amount of that, but at some point, you probably need to open up, some phone call, or maybe create some channel, depending on if you're like a Slack, Matter, Google Chats, Teams, whatever person, and talk to your friends, the network engineers and the storage people, to kind of troubleshoot what's actually happening. Maybe even the developers, if they care to show up at that time. This might be one of those free times they have because they're 25% more productive, enabling you to be 120% productive when they don't show up. So a logical question, is it how do you say that guy's name? Bettiger's Law or something? Whenever there's a headline with a question, the answer is no. But let me explain why, kind of go into that. Because I think there has been a lot of positioning, if you will, which is to say thinking of Kubernetes as a developer platform. And I know that because I've paid attention over the past 10 years, and I've also talked to numerous operations and infrastructure teams at large organizations, and we have the same conversation. Just to give you the brief version, they say, these application developers, and then we talk about how great they are, and special snowflakes for a while. Little gun shooting, having fun there. They asked us to stand up Kubernetes, and we did, and they're not using it, right? And they don't really, we don't see them going to it, and so what are we doing wrong? And I think that is because there's this perception that that's what you would do, right? That it's this complete developer platform that's fully ready to use. But you see this. This is a survey that we did, we used to do annually. And you see that as Kubernetes has spread more and more, right? That's what you see. That's why there's if I can count, 5 years of questions here. As there have been more people using it, you see the benefits of Kubernetes kind of dropping in the survey base, right? And that's what you would expect as a new technology rolls out, right? New people are using it, they're figuring out how to use it in their organization. But the one highlighted here, and to give you a quick little summary, the top green one is the most recent year, which is 2024, and the bottom blue one is the first year. But you see one of the developer-facing metrics, the ability to deliver code faster or shorten software development cycles. has been dropping over those past 5 years. Now, it'd be fun to do a survey this year and see what the result is. But also a little weird is you see that similar kind of movement for a lot of the areas there. Now, again, I think that is largely due to an effect of you have a new technology, you got to figure it out. But I think it's particularly, distressing, disheartening, unfortunate for people who think about Kubernetes as the full application developer solution, if you will, the thing you would put in place for a platform. And indeed, despite some weirdness in the kind of Kubernetes world over the years, I think the sort of like original Kubernetes people have been telling us this for a long time. And here's kind of a summary of the quotes from several years ago. Craig here used to work in my organization, or I guess technically I used to work in his organization at VMware when Heptio purchased them. And you can see this almost like, hey, sorry about all that Kubernetes stuff. Like, it really wasn't our intention that you, the developers, and kind of not Google people, not public cloud provider people would actually be exposed to that. And there's a great 2-part documentary on Kubernetes. And if you go back and watch it, which you should do after that Paula one, I'm going to assign some more homework later, so you might need a new sheet of paper. It's really a phenomenal look into strategy, right? Because you realize that the whole strategy of Kubernetes was basically to slow down Amazon. And I'll let you look into that, but one thing you should notice if you pay attention to these things that's great is they interview everyone in the industry except Amazon. And Amazon is portrayed as a continuous, looming, kind of Darth Vader-y drone shot of one of their buildings, which is the only way they show up, which should tell you a lot about the relationship of Kubernetes originally, the strategy that they were going after. All right, so we know that Kubernetes, or at least I believe, and therefore know, going back to my liberal arts degree, what's the difference between believing and knowing? Effectively, they're more or less the same thing until you stop believing something, I guess, but that's a talk for another time. So how do you run a platform? Like, we know a platform is all that exciting goop on top of the infrastructure, including services that developers might want to use, ways of supporting it, that sort of thing. So what does it look like in private cloud? Well, the first important thing, and why I want that talk by Paula is a great reminder, is this product part of it. Maybe one day we'll change the P to product, internal developer product, which would be fun. But at this point, you've probably heard a zillion times if you've ever been to a platform engineering thing. But it needs to be emphasized over and over again because I don't think it's actually practiced that much. I mean, this saying that you should treat your platform as a product is kind of like the idea of stand-up in a stand-up meeting where everyone obviously sits down the whole time, right? Like, it's kind of like subverting the spirit that's right there in the wording of it. So why is it important to have product management, to have at least one role that is actually a product manager? They can go get their pragmatic product management certification. Maybe they can just read a stack of books to figure out what it is. But a product manager is what you have when you have a product. And of course, it means something different when you're selling toothpaste and cereal, more or less. But in the IT world, this is something where, having worked mostly in the vendor world for lots of my career, you get very familiar with the product manager, and application developers generally know this idea. But the important thing, other than selecting the features that you have, kind of guiding what this product looks like, is something even further up the concept chain of a product manager, is in order to have a product, it's great to have customers, right? If you don't have customers as a product, this is kind of the equivalent of having a platform without applications. And so then it's good to ask, who are our customers, right? And as you can imagine, as Thomas here said a couple of years ago, if you are running a platform, you're the product manager for the platform, you think about the developers as your customers, right? These are the first people in line, hopefully they're people, who are getting your thinking, who you're doing things for. Sure, the platform needs to run, that would be cool. It needs to be secure, you gotta have all that stuff, but that's like, saying that it would be cool if Earth was hospitable, right? Like, those are basics that you need to have. But the product manager is constantly going through and understanding what the developers are doing, what they do great, what they like, what they dislike, and thinking about how can we change this feature, how can we make it better, how can we add new services to it. that would make our customers happier, that would keep them using our product, right? So now, I think probably, and if you're kind of more of a developer, you obviously have a notion of how your day-to-day work could be happier. I remember when I was an application developer, we could up our productivity by stopping complaining all the time because it was a huge amount of the work, so to speak, that we did. But what I advise to people who have more of an infrastructure background, and then maybe even if you're kind of from a developer standpoint going down the stack, is it's good to start asking the developers what they need. And the way that you do that is either you talk with them directly, which is fantastic if you can do that. A lot of these product managers, especially at large organizations, will travel around. You can imagine at large organizations, they have a campus, a hub, whatever you want to call it, various geographic locations, and going around and talking with them, even sitting with them as they do their work, is very valuable. But you can also do things like, to use a word everyone loves, survey them, ask them questions. So what questions should you be asking them? Well, here's a set that you can use. There's a white paper I worked on with a couple of people who do this kind of platform stuff that, again, you can't click on now, but it kind of goes over the theory behind this and some of these questions. And, it's something you can start with. You can use whatever survey thing you have, put it on a 1 to 5 Likert scale, and then the first time you do it, you can crudely, not crudely as in impolitely, but just basics of it, stick it in an Excel spreadsheet, and if you know the magic of sort by ascending, you can start to get an idea of what the most important problems are. Now, that initial thing of going through it to give you some product management thinking is great, but what's even better is when you survey them again in 3 months or 6 months, you want to see if things have improved, right? Have some of those high priority things moved down? Are people happier about things? And if not, that's feedback that you need to improve the things that you already shipped, right? That things could be better. Again, thinking about developers as customers, you're interested in them being happier, I guess. And there's some other metrics that you can be interested in about like shipping time and stuff like that. But you're constantly is the wrong word because people don't like to take a lot of surveys. Although I often say, again, going back to the 80% true joke, like if you were to offer developers, would you like to take a survey? Or if you said, hey, would you like to tell me everything that I'm doing that you think is wrong? They probably would be happy to talk about the second thing. I don't know, maybe developers have gotten to be more optimistic and happy since I did it way back when, but probably not. Anyhow, figure out some way of getting feedback from your customers, not just initially, but ongoing, and thinking about how do we use that to guide what's in the platform to product management, just like any product manager would, just like anyone who has a product that they want to, if you will, sell or drive usage amongst their customer base. Now, this next one, I think, is something that's especially important in private cloud, in large organizations, and that is marketing. A term that I'm very comfortable with because I've, in my sort of developer relations and whatever role, I've worked in marketing over the years. But if that phrase makes you want to, not be happy, just kind of ease into it. You can also call it community management, if you like that better. But what you're doing with this internal marketing, so think about you stand up a platform in a large organization, or you already have one. You're already probably competing with, 3, 4, depending on how big you are, 10 different platforms, plus any developer teams you have who are just like, I don't know why I need a platform. That sounds like a weekend's worth of work. Also, that DHH guy said that you can just do it. So no problem, right? Building your own platform. Now, why they're going to work on the weekends, maybe that's what they do with the 25% improvement. I'm not sure, but it seems like you should not do that. Maybe you should say I could spend a week doing it instead of a weekend. Anyhow, you're competing with a lot of other platforms. Again, thinking about your platform as a product, you're in a market, if you will. A ecosystem, if you don't like that word. And what that means is you need to talk about why your platform is good. You can go through, there's some standard marketing stuff. You want to get your positioning, your messaging, your value propositions, or as us marketing people like to say, value props. Who can be bothered to say 2 words? But part of that is not only narrowing down what your pitch is, or if you prefer, having really good documentation, going over what it is, but also thinking about core community management or marketing things like branding, right? And I see this over and over again in all sorts of large organizations, is one of the first things they do is they come up with a t-shirt, as my friend Deshaun would joke, right? And when you come up with a t-shirt, one, you've proven that you can get budget, which is thrilling, but two, you come up with a snappy phrase, a logo, a color scheme, an identity, right? And think about, as developers, we're like, I'm immune to marketing, doesn't work on me, and I love using my Apple Mac. I will defend to the death the type of code editor that I use. I can tell you why the shell I use is extremely important and you're wrong, so forth and so on. Obviously, we're affected by identity and marketing and brand, and sure, it's more about the functionality, not the actual identity that you have. But the same is true for any technology and any platform. So you're trying to define the type of person that someone is or becomes or can be, the identity, by thinking about what your marketing is. And again, you see this across the board with companies, right? Like, I think a great example of that is, I think they still do this, but the U.S. Air Force there, they launched this platform and this whole initiative to get better at software, and they called it Kessel Run, because of course they're going to make a reference to like Han Solo and Star Wars, things like that. And that idea of like, we're kind of like, renegade's not a word you would like your military to use, but we're doing things differently. We're a little more savvy, and we're going to identify to this thing that probably a lot of people involved really like as well. And then we can also make this t-shirt that has a kind of like a double meaning. There's other things that AF could stand for instead of Air Force, if you remember those days, right? But this kind of brand, this kind of internal marketing helps bring that in a great degree. And now, I joked about calling marketing community management, but not that I was being totally ingenuine, but genuine community management is also a huge part of what the platform engineering team does, right? So setting up internal chat channels, having quarterly internal conferences where you bring application teams that have used your platform to talk with other developers, which, by the way, it's a great marketing technique called customer references or word of marketing, having people tell you they were successful with your product, your platform, in more of a peer-to-peer basis than having someone that has no idea what they're talking about saying that it's great, the platform engineers being those people versus the application developers. I have this really distressing, rivalrous idea about application developers. I should probably go revisit that at some point. But you can see that having this, what I would call developer relations effort, starts to become important for a platform team in a large organization in a private cloud environment. And indeed, if you look at large organizations like JP Morgan Chase, big, gigantic global bank, last I checked, they have a team of about 7 or 8 people internally that are developer advocates for the kind of handful of platforms that they have. And they do all of these activities. They go around, it's not only training, it's not only awareness building, but it also becomes a channel. This is the part about developer relations that all DevRel people aspire to. Very few of them get the chance to do it, but it's also a feedback channel going back to that product management, right? So if your internal community people are out there talking with your customers, your developers, they can bring that feedback back to what the product manager of the platform is doing, right? They can start to give some advice on how to prioritize features. So now, I think maybe this is perhaps the most important thing that is different about platform engineering in private cloud in large organizations, and that is, let's call it continuous financial metrics. And so the way that finance, which is to say oxygen, works in an organization, and particularly large organizations, is you're on, let's say, a 12 or 18-month budgeting cycle, right? It's supposed to be 12 months annual, but essentially every year you have to go through an excruciatingly delightful process of saying, this is the budget that we need, proven by the return on investment that we had last year and our projected return on investment in years forward, right? You're basically saying like, well, the reason we need $5 to $10 million is because we're awesome. And they're like, yes, I'm sure you're awesome, but I'm going to need some spreadsheets. And so what this can amount to is metrics, essentially, right? And these metrics are associated with some aspect of helping the business out, right? Like, unless you're working at a tech company, which is great if you are, that metric is usually not oriented around like raw growth, because we're looking for a large startup valuation and then an exit, and then actually making money is someone else's problem, right? Like, that's not necessarily how you kind of budget out these metrics. So you need to start thinking about how are we from day one not only tracking what these metrics are, but very, I think, tactically wisely saying what the metrics are, framing them. Because in my experience, knowing the value of IT, if you will, is extremely difficult unless you're in something that's very close to the business's business, transactions like retail or other things, where you can directly connect, you know, a line of code changing to like people booking more airplane flights or something like that, right? But things get a little more obscure. I like to go back to banking. Like, what's the return on investment of me being able to see the balance in my bank account? It's theoretically infinite, because if I couldn't, I wouldn't bank there, but you can't really put infinity in a spreadsheet, right? Like, that doesn't really work necessarily. So you need to start coming up with metrics that map to why the platform is valuable, right? That allow you to talk upward to your organization. Again, I don't mean to be pejorative, but to talk in terms of finance and business and that planning. And there's all sorts of metrics you can come up with. Again, here's a, kind of like with those survey questions, here's a default set that's been evolved over, I don't know, the past 5-8 years or so. And, you know, it's even formatted in a dense way that I think people in large organizations can do. Have you ever noticed that very good at reading documents in landscape, right? Like, that's kind of the mindset you have with the rest of the organization. Is just like, you want to print something, go up to that little thing. You really want to print it in portrait because you've read about the Amazon memos, all the people complaining about how documenting something is better. Just select landscape, you're good to go, right? And things will be fine. So you can see a lot of these things, they are capturing what a platform is trying to do, right? Everyone wants to speed up. Now, speed can be gratuitous, but the point is that the faster your organization, I'll just say business, but you can imagine how this maps to a nonprofit-oriented organization, whether you're helping citizens or otherwise, you can see that the faster you can change your software and get that software in front of users, the faster, if you will, the more that business can evolve, right? So speed is an interesting indication of something. And I don't know, I guess I could reference DORA reports, the DevOps one, not the European banking one, to show that that was important as well. And then, you know, a lot of the rest of these are based on that kind of table stakes that I was going over. But it's also important to emphasize and track to the rest of the organization why the table stakes are good and why the investment in your platform is paying off and representing that in some way, right? Like, again, a lot of these middle ones are kind of like, I think of them as indoor plumbing, right? Like, the value that we put on indoor plumbing is basically zero until it stops working. And then it has infinite value, right? Like, we really enjoy it when it turns back on after not being on for a while. And thinking how you represent that so that you don't have to remind people with a catastrophic event is a good number to start tracking. Now, of course, savings is good, and that gets into some weird, like, depending on how you think about things, what the situation is. You got to be careful if you're trying to get money. You know, it's good to track savings of how much you could have spent versus how much you are spending, because you don't really want to be in a situation where you're like, and guess what? We need less budget than we had last year. We're saving you money, right? So, but think about how it's more of a good investment. You know, savings is kind of up there because the other ones are S's. Then you can call those 5 S's. You don't want to be the 4 S's and the I, which would be actually kind of fun. But think about how you represent the money made, the money you're attached to, the kind of savings you have versus theoretic alternatives, and start tracking those things. Now, for developers, kind of inward-facing, there's all sorts of other metrics you can track. Here's kind of like a default set as well. And this is good, again, for people who aren't so concerned about your budgeting, but they're good things to start measuring and tracking. And I think the point with both of these metric things is, again, thinking as your platform as a product needs to have measurements, needs to have metrics. And I know once you start measuring something, that becomes the goal of doing stuff. Hopefully now that you know that, you won't fall into that mistake. I always think that's a weird paradox that people should know that's the issue, and so you need to constantly be thinking about, are we just doing the metrics or not? Good luck. But it's good to have some indicators, some dashboards, if you will, of how things are going and how you can talk to other people through spreadsheets, metaphorically and literally speaking. All right, so just a couple of more things. Thinking about how you spread platform usage through your organization. And again, this is particularly relevant to large organizations, and large organizations use a lot of on-premises or private cloud, so it's particularly relevant to that sphere of things. And this is what I've observed, and many organizations have gone through over the years, is this kind of slow at first spread of a platform, and then having more of a very rapid spread of it. I'm sure there's some math terms I could use there, but see my credentials earlier when it comes to mathematics, or maths, as people like to say. And so what you see is at the beginning of the platform, you see selecting an initial development team, maybe even 2 development teams, and working extremely closely with them, right? They're your first initial customers. And as you're even planning and developing the platform, you want to talk with them to figure out what their needs are and build it around them. Now, you're getting good feedback about stuff. You're also starting small so that your, let's say, your learning function, which is to say, when you fail, that your learning function is as risk managed as possible, right? You don't want to do everything at once. Like if you're thinking of like in the first year, we're going to move 120 to 500 application teams to the new platform because that's the only way we can make the business case, then you should look around the rest of your organization for alternate jobs that you could have after that doesn't work out. But you see more this slight going sort of rise in development teams on the platform. Now, another side effect that's interesting that goes back to the community management of what you want to do is as you build up these initial teams and as they're successful, they become advocates or customer references for you that you can then use in your efforts to spread the goodness, the great cheer of your platform, right? So you're building up the case in these peers that other developers will probably listen to more than weird infrastructure people who have a strange title. Aren't they basically just DevOps people? People may be thinking, that are more of a trusted source for spreading the idea that a platform is good. And if you're very lucky, you can even take some of those initial people who are interested in helping others. They kind of have that more senior, even kind of like principal engineering mindset of my job is to help the rest of the organization, and start to seed them in other teams, right? So you're taking direct knowledge to new teams of how to use the platform, and so on and so forth, right? But planning out that gradual and then sudden ascent in things becomes very important. And then getting into more of, let's say, planning, right? Planning out the activities that you'll do, what it's going to look like, even getting into budget, what you might even call strategy, if you're not too pedantic about the definition of strategy in a corporate context. There's another great CNCF working group called I think it's the Platform Maturity Model Crew. That's not their name. But they've been working on a platform maturity model, which I think is great. They're one of the few people who've managed to cram a maturity model down into, I think, less than 50 pages. I think it's maybe about 25 or 30, and I hear there's a new revision of this coming out. But this is well worth your time reading if you're doing platform engineering or especially planning it in a larger organization, because it's the best version of what a maturity model is. Another word you may not like, but a maturity model is sort of like, here's a bunch of mistakes people in the past have made and how you can avoid them, and what you can expect to happen over the course of things, how you can organize the activities and the stages of what you're doing. It's a lot longer title than maturity model, but maybe it makes you more comfortable. But if you read through this, some of the key things that you'll see are that you can expect it, to have, like, let's say, undeniable success with your platform, which means, let's use the technical term, a lot of applications running on it, right? If you've got like a big platform and there's only a few applications running on it, it's kind of questionable what the overall value of that is. But you can expect it to take more or less 3 or 5 years to go through this entire cycle, to go through these things. Now, there's an important point that all maturity models make, which is maybe you don't need to go through all 5 steps. You might reach step 2 and that's sufficient. But there's all sorts of interesting results from the maturity model. And it kind of, in a good way, is self-enforcing about a lot of the notions that I went over and didn't go over about what a platform engineering team does, right? So in particular, it's paying attention to the developers, right? So one of the steps in the maturity model is, do you have a product manager, right? Like, are you getting feedback from the developers? And you'll get an idea of what those are there, and be able to plan this out a lot better. So finally, no talk nowadays is complete without talking about AI. So how am I going to fit that in there? That's a great idea. Great question. I'll tell you. So here we are talking about large organizations and private cloud. And I think what's interesting, it's interesting, but what is relevant to platform engineering with AI is a couple of things. One, to the notion of large organizations where, as we saw the CEO of AWS say, a lot of it is private cloud, somewhere between 90 and 60%, depending on which organization you talk with at some of our larger customers, et cetera. You also survey those organizations, and you see that their intention, at least, we'll see how it pans out, is to run a lot of their AI stack on premises, right? Which I guess makes sense, because of data and wanting to control things. I think it's a little early to get too settled on where the workloads will be, but that's the early feedback that you get, that the intentions at the moment are to have a lot of it in a dedicated environment, right? And about 50% of it. Now, what that means is that the platform engineers, the way that I think I and some of my coworkers and other people in the community are seeing, the way they start to think about how to support AI in their platforms. And by this, I don't mean all the kind of assistants or co-pilots, like coding in your IDE. That's a whole other sort of thing. But here I mean adding actual AI functionality, actual features to your applications, to how your business is running. So what I think is emerging is that the platform engineers, they get all enamored of AI, they start freaking out if it's going to replace their job, as we all do. And then they actually start using it day to day, and they're like, oh, this is fine. It'll be great. And they start to think about that AI functionality as services that they're providing, as middleware, right? So once you kind of appreciate the magic of what all these AI things do and the mind-blowing awesomeness, and then you come back down to reality, maybe you've had a huge lunch, and so you can think more clearly. What you start to think about is I'm just providing another piece of middleware, a service to developers. How does this fit into the workflow that they have, which I know because I've talked with them, because I'm a great platform engineer, product manager type. What can I do when they need to use this and fold it into the way they're doing application development? It's probably similar to when they use a database, or they need to do some sort of messaging thing. And that's where having a platform is going to be a huge advantage, because you'll have so much of that scaffolding, so much of that stuff built in already. You're already providing access to services, and you can start to think about how you add this new type of service, how you add access to all sorts of models, all sorts of supporting frameworks, whether you want to run those models on your own, whether you want to broker access to your own models, to publicly hosted ones, whatever it may be. If you've been doing platform engineering for even a short amount of time, you're used to dealing with that kind of thing with the other services that you have. And it's not like it's not going to be a problem. Every service has its own unique, cool things that you get to experience. But at least you're going to have done a lot of the conceptual work around it. So thanks for coming to my talk. It's always a pleasure to talk with people and go over this. If you're interested in clicking on the links in the slides, there they are. And it's always fun to hear people's experience with platform engineering or other things. It's not like I get super happy to talk about platform engineering. There's other things that are fun as well. But, it's always good to hear from people, and enjoy the rest of the conference. Thank you.
Oh, it's on. Okay. Should I start? What do you say? Or should we wait? Start. Okay, let's do that. Um, okay, hi everyone. Thank you so much for being here. For those of you who didn't get the chance to see my amazing R2D2 heels, now is the time. And I'm gonna walk over there so everyone will be able to enjoy this beauty. Look at that. Come on. Give it up. Come on, you sitting quiet. R2D2 heels. Thank you. Thank you. I deserve it. They're painful. Okay, now we can start. Okay, so hi again. I am so happy to see you all here. I am so excited and honored to be standing on this stage and to get the opportunity to share a little bit of my journey with Helm charts. And yeah, so let's do this talk. How a unicorn migrated from an in-house solution to Helm. Before I do that, let me tell you a little bit about where I work. I work at Forder, which is Forder ensures that good customers can complete their transactions while fraudsters are blocked. That's a good thing to do. But now you're probably wondering, why a unicorn? Well, first of all, it's a cool name for a presentation. And also, Forder is a unicorn company. So that's why I thought it's a very good name for this talk. And so now, before we dive into the details, I want to give you a little bit of background about Forder so you'll get the idea of what we need to handle. So we need to do 50 million decisions every day in real time. And this is the production environment that I have to support as a platform engineer. And let's talk a little bit about Forder's compute environment. So we have AWS with EC2 instances. There are some things that we might not migrate to Kubernetes, but this is a Kubernetes talk. So of course, we also use EKS. Why don't we migrate everything to Kubernetes? Well, that's a talk that I'm not going to do now, but you can join that other talk of mine. Okay, so now let's talk about the CI/CD pipeline that we have at Forder. Obviously, that's a little simplified overview of what we have. You can see over here that right now, if a developer, they write their code, they write a little bit, they change their Helm chart, then it goes through a webhook to Jenkins, and then we use both AWS ECR and JFrog Artifactory. And as far as the CD, we also have Jenkins for different deployments, but for Kubernetes deployments, we use Argo. And that's it. That's a simplified overview of our CI/CD pipeline. And now I'm going to go back a little bit and talk about what happened about a little over a year ago. So a little over a year ago, we decided to migrate to Kubernetes. It was the second iteration of us trying to do migrations to Kubernetes. And the first time that we tried to do those migrations, it wasn't so successful. And I'm being honest here, and that's okay that it's recorded and live. It's something that I'm allowed to talk about. And the reason for that we weren't so successful, it's because I think that when you start to do such a huge journey, when you start to go on such a big journey, you need to take into account that the migration phase is not going to be a very short phase. You need to prepare for that because it's going to take some time. And so you need to be able to support both the existing environments and then also the new environments and then have them play together nicely. But the other thing that you need to remember is that your users, they have free will. Unfortunately. No, just kidding. That's a horrible thing to say. But seriously, though, when you decide to do a big change of infrastructure, you need to get buy-in not only from management, but also from the users, from the developers who are actually going to use that new infrastructure that you offer. So you better think about that before you come up with some offering that looks really good, that is very performant. But what about the usability of that? So that's what I'm going to focus on. I'm going to focus on Helm. I will present the technical solution, but what I'm definitely what I definitely hope that you will take from this talk is not just the technical parts. I would like you to open your mind and think about how, when you define the requirements for your new architecture or for your new system, think about who's going to use that and what's important for them, because that's what's going to make your system or your new infrastructure so successful. Because if you have an amazing system, but nobody uses that, is it actually amazing? So that's what we'll have today. We'll talk about these three things. I'm going to start by talking about the Helm charts structure requirements, and then I will talk about our Helm charts structure, what we ended up doing, and then I will talk about how we integrated Helm with our existing infrastructure as code. But before I do all of that, why don't I tell you a little bit about myself? So my name is May Baseron. I've been a backend engineer for over 5 years, and then I decided to join the dark side and become a senior platform engineer, which is what I am today for the past 3 years. I'm an international public speaker, which means I love to talk a lot in different places, but I'm also a mentor, which means I love helping other people become the tech speakers that they want to be. So if you want help, talk to me. I'm a party girl, not the kind of parties that you might think. I love to join Diablo 4 parties. Woo. Okay. And I'm a sworn Star Wars fan. We covered the R2-D2 heels right at the beginning. So for those of you who just joined the talk, I have R2-D2 heels. They're shiny, they're beautiful, and painful. Give it up for that. Just one more time. What do you care? Thank you. I love this audience. It's so nice. Okay, so let's start with the Helm charts structure requirements. Let's see that. So I started to talk a little bit about that. The fact that developer experience is important. And it's something that it's not always easy to measure. It's not so easy to make it a measurable something to go by and to prove to management that what you're doing is very good because the developer experience has improved. There are ways, obviously, to measure it. So one thing that we did when we embarked on this journey is we handed out a survey to our developers. We made sure that the survey wasn't too long, no more than 6 or 7 questions, and everything was just a selection questions, not open questions, so it won't take too long for them to fill, because who likes surveys? I don't think a lot of people. But this was our way to be sure of what they want. What are they looking for? What's missing in our current offering in terms of deployment or the way that they can define their resources? So we started with a survey, and we kept that survey aside, and then later, after we went through the whole change in Kubernetes migrations, we handed out the same survey. And that was a measurable way for us to show management that what we achieved. Are they happier now? Or do the developers believe that it's easier for them to do deployments now? So it's not just about Kubernetes, saving cost or having faster deployments. It is the most important thing. We are a business after all, right? But if a developer say that now they believe that they can create a service much faster, that their deployments are faster, that they can debug their problems in a more efficient way, that's a big achievement. And that's what we were able to achieve with that survey that we handed out. So that was about the survey. I told you about the beginning and the end of it and how we used it. But now let's talk about how we defined the requirements for the new Helm chart structure. Now here's the thing. Before we migrated to Kubernetes, what we had was a Python solution, an internal Python solution for defining all of the cloud resources. It means that you can write code in Python, and this Python code will generate CloudFormation templates, and with that, you will get the resources defined in AWS after deployment. Does it make sense? Okay, cool. So now it means that the developers are used to defining their own resources. they're used to managing their own resources, selecting the type of instance, selecting their type of queues, even defining the security groups. So they are aware of how to do that. They know, they're used to that. But still, I wanted to ask them if they like it. So some developers, yes, they loved it because they felt that they have so much power. So they wanted this autonomy to keep on going even more, even when we moved to Kubernetes. But some developers just found it too complex. They felt that all they want to do is focus on their code, and they want me or somebody else from the platform team to get it up and running. Just do something, make it run. I don't want to define security groups. It's not that important for me. I can understand that. And as the company grew more and more, we had more and more developers thinking like the second option, more and more developers looking for the golden path, saying, I don't know, I'm not so excited about defining the cloud resources myself. Okay, so this is why we understood that now we have to find a way to support both approaches. We need to find a way to allow developers to have enough flexibility to change things on their own, but also, on the other hand, I want to have enough abstraction of the infrastructure, of some infrastructure parts, to prevent cognitive overload. So here are the three requirements that we had we decided to go by when we started to think about what's the Helm structure is going to look like. The first one was to say, okay, we want this to be self-serve. We are a team of 5 platform engineers on the deployment pipeline, and then we have 4 more engineers on the CI pipeline, and we need to serve about 120 developers. So we want our solution to be self-serve. We don't want to be a bottleneck. So we want them to be able to change things on their own. Next, we have the composable. We want to allow deployments to be assembled from smaller independent components, because it means that we can abstract away some of the underlying infrastructure, and then we can start building on top of that. And then we can decide if we want to change one part or not. So composable, that is very, very important. Even more so, that was important for us because we came from that Python solution, which was a big repository with everything defined inside it, which has its own strengths. We can talk about that later if you want, but believe me, it's not like just 100% bad to have everything in one repository. That's not definitive, but it's something that we decided that we kind of want to find a way around and to have the next solution be composable of many different parts. Extensible. We wanted to make it easy for everyone, not just us, the infrastructure team, to add new abilities to that Helm solution. And why is that? It's because today, as I mentioned, developers are used to be able to add new features to that Python code. If there is something new that AWS now came up with. So a developer can now just use the AWS CDK API and go ahead and add this to the Python code. And now this new resource will be generated during deployment, and it's part of our ecosystem. So we wanted to take that ability onto the new Helm chart architecture. So when developers define resources for Kubernetes, if there is something new that came up, they don't need to wait for us to add it to the new offering. So these are the 3 requirements. And we wanted to have Helm charts that make it simple to add new abilities, to make it composable, so we have different parts, and we wanted it to be self-serve, so people can use that on their own without waiting for us for anything, basically. So I created this very simplified graph because graphs are nice. But also, I wanted for me to have a way to communicate with you about how I felt about each solution. And when I say felt, I mean it because I am an emotional developer. So let's go over to the second part. Now we will talk about the evolution of Helm chart structure from conception to our solution. Just so I'll know, how many of you here are familiar with Helm? Just by show of hands. Okay, cool. So I'll skip a bunch of stuff. So when we started to think about Helm, we went through we went through the Helm features. I'll go through that pretty quick because I see that most of you are familiar with Helm. So for those of you who don't know anything about Helm, let's say that you have some front-end service that you want that to be deployed to Kubernetes, then you need to have your chart, and this is your way to define some resources for this application in Kubernetes. So in that Helm chart, you will have a chart YAML. You're going to have templates, which is like a fundamental concept that allows you to define the structure and configuration of a Kubernetes resources in a flexible and reusable way. I think about it as just functions, but it's templates, really. So then you also have the values YAML. This is where you manage all of the actual values of what's going to be deployed. We use the values YAML in order to simplify our Kubernetes offering. So that's, general. For those of you who already know Helm, you're probably familiar with it. And now I'll go over one more thing that is, I think, important just to be sure that everyone's aware of it. So in Helm, you have the chart YAML, which is a metadata file. And that provides essential information about a Helm chart, like the chart name, the version, the dependencies. If you take a look at line 7 to 9, you can see the dependencies over there. What it means is that now we can use that chart that is defined elsewhere, for example, where it says repository and then charts, bitnami, we can use that chart and in our chart. This is actually called a subchart. The dependency is called a subchart, and while there are many things to talk about when it comes to Helm subchart, I think it's a wonderful concept. I want to focus on the two characteristics that we leveraged in order to get the solution that we have today. But another thing that I want to say is that the main chart, the one that I work with on my service, this is called the parent chart. So remember that when I tell you the next thing. So a parent chart can have multiple dependencies. I can decide how many dependencies I want. It doesn't have to be databases charts. Obviously, it was just for the examples. And then another thing is that you can enable those dependencies by condition by a simple flag. And another important thing is that a parent chart can override values of their dependency chart. Now, why that is important, it's because now we can use ready-made charts from third parties or open source charts, and we don't have to write these from scratch. Okay, so now let's go over some common Helm chart solutions. But before I do that, let me tell you how I got to that. So when I got this challenge, as I told you, one of the things that I'm most passionate about is developer experience. But I'm also passionate about finding out the things that I don't know, right? Like, what are the unknowns? That's a big passion of mine because nobody likes to be surprised when it comes to production. Some other places in life, surprises are great, not in production. So what I did was I decided to go and ask around people, friends from other companies that migrated to Kubernetes. Because what I believe that is special about being a platform engineer is that different companies, they have problems kind of in the same area, right? Like, companies need to deploy their apps, and they have a CI pipeline, I think, and they need to build, they need to do testing. And if they use Kubernetes, there's a set of tools out there that you can decide which one is best and which one to use. And so what I did was I went to those other companies, not just to ask, is Helm good? Because what does it even mean? Good. Good to who? Good to what use case? What I wanted to learn about was the migration phase. I wanted to learn about the user experience. What did their users think about Helm? Did they like it? Did they feel that it was too complicated? Because I knew that the problem I was trying to solve was to help the developers who feel that the Python solution is too complex, make them feel that we're working for them, and they're now going to get something that is easier and simpler. We have to remember that not all developers are familiar with Kubernetes. For some of them, it was the first time that they did anything on Kubernetes. So I needed to take that into consideration. Obviously, I would like to think that the developers will, explore and read about Kubernetes on their own, but I can't think that this would be the thing for all of the 120 developers. I can't believe that it's going to be right for every single one of them. And so this is why I took the time time from the time that I dedicated for research to ask other companies how was their developers' experience when it came to Helm and other solutions that we checked. So this is what they told me. These are the solutions that I found out that other companies use, and then I'll show you what we decided to do. So some companies decided to manage each service as a single chart, which means that we have a chart per service. And that was actually useful I saw that happening for the smaller companies. For startups where the DevOps or infrastructure team, they manage it all. So they were the ones who actually defined the Helm charts for each team. And I found, in my opinion, it wasn't so scalable but I can say that for smaller startups where their developers really need to be dedicated to developing the services, and they don't have time to mess around with complex infrastructure, this worked for them. So it was an interesting solution. The thing about that is that now those Helm charts are in the repository. The entire Helm chart is in the repository of the service, which means that the developers can now change and edit the chart as much as they want. Sometimes it's a good thing. Sometimes it's not such a good thing, because what if there's a developer who doesn't want to wait for the DevOps team to create a Helm chart? Now you have a copy-paste situation. Does it sound very good? Does it sound very secure and safe for production? No. So that's why I believe that it's far too, it's too much on the developer autonomy. It enables the developer to do those changes and create their own charts. But then if I want to make a big change for all of the charts, or if I want to add some security measures, that's going to be pretty tough if every chart is separated in different repositories. So if I want to sum it up, with individual charts, we don't have standardization. It creates cognitive overhead because, as I said, I can't ask 120 developers to go and read about Kubernetes and get into all of the details so they are able to write Helm charts from scratch. And yeah, compliance, security, that's not a good idea, at least not for further where we're at today. This thing has worked for smaller startups. Next, we have the umbrella charts, which mean that we manage all services subcharts in one big single parent chart. So let's see, what does it look like? So let's say that this is my directory, right? So if I want to deploy anything, it means that now I will have service chart 1. When I say service chart 1 and service chart 2, this means that these are charts for each service. And then this whole thing is one big chart on its own. So we have the templates, the values YAML, and the chart YAML. If I want to make it more visual, this is what it would look like. So it means that the big chart is dependent on those. So if you remember, we have dependencies for charts, which means that each of those charts will be written as a dependency in the big chart. And the fact that the big chart has all of the other chart as dependencies, if you remember, it means that now the parent chart can override values. So this can actually be good if I want to have very strong, strict standardization, if I don't want to allow something that's actually a good thing to do. And another thing that I saw was that the companies who used the umbrella chart were companies who needed a single deployment. There are a lot of companies who needed to be able to deploy their entire environment, their entire services together on one go. And this is a great solution for that. Yeah, so one command, deploy everything. So this is what the umbrella chart was very, very strong for. And it's actually wasn't just in smaller companies. I've seen a few big companies, I won't name names, but believe me, very well-known companies who use the umbrella chart, and it works great for them. Because as the company grows, like I said, you do want to have a way to enforce some standardization. You want to be able to make sure that some values will not be deployed to production. And sometimes if the company is that big, you don't even want to show it as an error. You just want to prevent it, and then, okay, it will fail during deployment. Okay. So as you can imagine, the umbrella chart is very up high on the standardization. It's a very, it's a very strict manner to use that. And the problem with that, in my opinion, again, I think it's a problem for them. It's not, because it works for those companies. So in my opinion, the problem with that, at least for Forder, is that this repository was managed mainly or solely by the DevOps team. And if you remember, this was one of my requirements. I don't want us, five platform engineers, to write Helm charts for 400 services or for 120 developers. That's a bit too much. And honestly, because we have that culture at Forder where developers are already used to being responsible for their own resources, I knew that we don't need this much of strict standardization in our new tool. So we decided not to go with that. I wrote here that it's difficult to maintain for big systems. Even though I wrote that, I can't say that it's 100% true. But that's what I felt when I meant big systems. Maybe it was more correct to say that it's more difficult to maintain for the amount of developers versus the amount of platforms engineers. Because let's say, okay, I know one of the companies I talked with, they had such a big platform team that it makes sense, right? If there's like 50 people in the platform team, then that's okay. If there is a DevOps dedicated to each team, makes sense. I don't need the developers to do anything when it comes to the infrastructure. Not self-serve, that's already kind of understandable. Okay. So another thing that I saw was multiple umbrella charts. It means that we have many services and they're all inside one big chart. And it means that some places divided it either by team or by a product, which means that I can have some apps deployed together. The same idea as I talked lengthily about the umbrella chart, but now we're talking about separate, maybe individual products or teams. And the problem is that if you decide that you want to have something that is spread across all of those charts, you can't do that. You need to go ahead and change it in all of them. Again, this makes standardization very difficult, because when I say Team 1 umbrella chart or Team 2 umbrella chart, it means that those charts might be sitting in the repositories of those teams. Maybe there is a dedicated repository, something that is managed across multiple repositories, which means that if I want to make a wide change, it's going to be annoying, if I put it in simple words. So this is when after I explored all of these options, I knew that there must be something in the middle. There must be a way where I can take some of the good of each of those solutions. And the thing was that I got inspiration from Jenkins, which is weird, because the developer experience of Jenkins is debatable. Although I personally like it, I heard different opinions. Don't tell me what you think. But I took inspiration from Jenkins when I came to the team and discussed the solution that I'm going to show you in a bit. The thing was this. What I liked is that in every repository, there is a Jenkins file where you can define custom steps for your CI pipeline. But we also have one big Jenkins file that runs and manages all of the pipeline itself for the CI. So the main Jenkins file, it always runs. This is what's managing the CI. But then if you in your repository want to add custom steps or to change some values or to do something a little different that is custom made for your own app, you can do that. So this way I can have both things. I can have the standardization, and I can I can allow the developers to add more things or to change more things and adapt it to their own needs. Or if they want to go with the golden path, all they need to do is just to have the general Jenkins file in their repository without any changes. And I wanted exactly that. I wanted something like this, that I'll have something that is central, but then also something that the developers can change and adapt to their needs. And this is our base chart solution. Each service that migrates to Kubernetes will have a Helm chart that contains the configuration of the service, containers, environment variables, all of that in the service repo. What did we do with the existing infrastructure? I'll talk about it in a little bit. So the base chart will serve as a dependency in each service chart, and then we will have an individual chart for each service. So if we look at that in a more visual way, we will have the base chart over here, and this is where we define the templates, the values YAML, and the chart YAML. And then every service is dependent on that chart, which means that if they want, as a golden path, all they need to do is define chart YAML and values YAML, where they can define, the name of their service. They can define how many, the pod count or the replica count or any other value that they want. Metrics, all of that can be defined in the values YAML. But if they want to add more complexity or more features, they can by just adding more templates and more configurations, that are better fit for their own application. I think the thing that I love about the base chart is that we called it Chartmander, like the Pokemon. Nobody laughed. What? I thought it's funny. It's cute. Okay. All right. Maybe next time you'll laugh at my jokes. Anyway, let's go back to that. So this is what it will look like. This is what our base chart looks like. These are the things that we currently define in it. And now let's see what it would look like for a service. So a service will have the chart itself, and as you can see, each service will have the base chart as a dependency. What it means is that we can now release new versions of the base chart each time, and we can add more and more things, and all the developers needs to do is just to mention the base chart as a dependency in their chart YAML, because we have auto advance, which is our way of advancing dependency throughout the repositories, they don't even need to care about versioning, unless we have break-in changes. But that's yeah, that's something that I guess we should discuss in a different time because it's a whole complexity issue. Not for now. Okay. So one important thing that we loved was that the service can override values of the dependency chart. Let's say if I define that a replica count is 1, they can change it to whatever number that they want. Another cool thing that we did is with the metrics, we decided to put the metrics enabled false for everyone, and if somebody wants it, they can enable it to, they can change it into true. And that's it. So the thing is that important to say is that the base chart values file will contain all of the default values, and these can be overwritten. So again, if the developer want to stay on just defining the chart name, they can, and then that's it. And that's the dependency services chart. Okay, so see the little chart? Okay. So, so the base chart, for us, it meant that we found the balance between the developer autonomy and standardization, because now the developers can have all of these things. It is self-serve because the developers can write their own chart YAML and values YAML, and then that's it, and they don't need us in order to deploy it, to create a new service and deploy it to Kubernetes. Also, it's composable. I will talk about it in a little bit, about the additions and changes that we made to the base chart, but it's very easy to add more things to it or to take apart things from the base chart. And then also, it's extensible. We saw a lot of developers adding their own templates or getting charts from third-party Helm charts, and we did it was the responsibility of the security team to make sure that those third-party Helm charts are valid, but it was possible. And this is my responsibility, to make sure that they can add it, and then the security team should make sure that it's actually safe. So now let's talk about what we did with the existing infrastructure as code. If you remember, we had that Python solution using CDK and also CDK test. What I didn't mention, I think, is in the first iteration of our Kubernetes, we actually used Python to generate the Kubernetes YAMLs. We used CDK test. And it meant that, we thought at that time that the developers are already used to that Python solution, so why not continue using that API? And it was too complex for them. It was too complex. It was maybe it's not complex and they just didn't have the time, which is also okay, because some developers feel that it's not their responsibility to generate their own resources. So we knew that, okay, now that Helm is defining resources for Kubernetes and it's not part of that Python solution, we still need to find a way to connect the two, because there are things that are defined in that Python solution that we're going to need in order to deploy the service to Kubernetes. So things like IAM role or the URL of some queue or the ECR URL, those are things that are used and they are needed, for example, for the defining a service account for Kubernetes. So we knew that we still need to find a way to get those values from that Python solution. So what we did is we added a little part to the Python solution, Python service, that generates a values YAML. So some of the resources, everything cloud related, is still defined in the Python repository. So for example, if I want to define a new S3 bucket, if I want to define an SQS, when I create a role for my service, so that's the way that I am getting all of the permissions, the IAM role, that all of that is being created in the Python solution. And then we extract from that values YAML, and then during deployment, Argo CD takes both the values YAML from the Python solution and the values YAML from the Helm chart of the service, and then it deploys those together. And now, okay, what I wanted to say now is that what you can see over here, that each chart can be deployed separately, but it got to the point that the base chart got pretty big. It was a bit too much. So now what we started doing, and that's something pretty recent, is that we took apart the base chart, and we now have base charts for security things. We have a base chart for monitoring. We have base chart for networking. And we also start to work on taking apart that Python repository. So we extract things from there and we add it to the base chart. We still call it base chart. There is still one chart mender. I can't give up on that name. But to be honest, we now have several base charts because having one just meant that we ended up again with a very big repository, which we didn't want to have. So now we have several base charts defined by different purpose. And yeah, so this is what, okay. So what have we talked about today? We're getting closer to the finish line of this talk. And I believe that I mentioned, I believe that I mentioned at the beginning how I'm going to show you a bunch of technical things that you might already be aware of, you might already know. But the thing that I want you to really think about when you leave this room or you leave this live stream is that you can't decide for your developers what they want. And you can't expect 120 developers or 10 developers to go and learn something that maybe is not in their main path. It's nice if the developers, can open their mind and do extra, but you can't expect that from them. You can ask them if they want to, if they're interested in it, but it's not something that you can rely on. And if you have that thought in mind, that I can't rely on the fact that they know Kubernetes to the core, they understand the implications of defining different resources in different ways. If I know that, it means that now I will develop solutions that will work with it. And if there are power users that know a lot about Kubernetes, great. I love it. But for the rest of those developers who are power users in their own thing and whatever it is that they work on at that moment, I don't have to be worried. If it's worried about security, worried about cost, worried about production issues because somebody didn't define a pod destruction budget, So that's what I want you to take away from this talk. Remember that you're working with developers who, at the end of the day, want to do a good job as much as you do, but they have a different job definition than you. And this is how we defined the requirements for the Helm solution. It wasn't just technical requirements. It was mainly requirements that would be the best fit for our customers, which are the developers. And with that, I will say thank you. If you have any questions, if not, come say hi. I'm very friendly. Thank you.
Welcome, everyone. Hope you had a great lunch, that you're enjoying the conference so far. Thank you all for coming to this session about what's new in C#, what's happened with C# over the past decade or so. There's a lot of stuff that we're going to cover here today. Before we do that, could we, as loud as we can, give the organizers a round of applause? Thank you. Everyone else is going to be very confused and think I just finished in under a minute. There's nothing new in C#. I'm kidding. My name is Philip Ekberg. I'm super happy to be back here. After this, if you have any questions, feel free to send me an email. Over the past 10 or 15 years, I've told people to send me emails, never got any emails. I thought I was super crystal clear in everything I talked about. Turns out, I didn't have my email on the slide. Bad mistake. So now I'm going to get a handful of emails about everything in regards to C# and .NET. Oh, okay, so we're going to talk about everything that's happened to C# over the past, let's say, since C# 8, 9, 10, 11, 12, 13, and also what's going to come in 14. This language has changed quite a lot. There's additions to the language that let us build applications that perform better, applications that are more robust in terms of less exceptions, and also reduce the amount of code that we have to write, so it's easier to maintain as well. Some of these language changes, such as generics, async and await, and pattern matching, all kind of fundamentally change how we build our applications, how we describe our code to make it easier for anyone that's working on our applications to follow along and to participate. So let's go through a couple of these really interesting features across this talk here today. Now, if you haven't kept up, we're at .NET 9. This is the latest version of .NET. Who in here is waiting for an LTS version before they upgrade? Most of you don't dare to say. Half of you. All right, so there's really no reason whatsoever to wait for an LTS version. And I'm sorry, I'm not calling you out that you're not upgrading, but an LTS version simply means that it's the long-term support version of .NET. .NET 10 is going to be an LTS version, but you don't have to wait to upgrade. If you upgrade earlier, you're going to get access to all the language features of C#, every performance improvement in .NET, and by no means is an STS or a short-term support version in any way less performant, or it's not experimental feature or anything like that. It's just as robust as the long-term support version. The only difference is that Microsoft supports the other version a little bit longer. So if you haven't already, go ahead and upgrade to .NET 9, and you'll be able to use everything that we're going to talk about here today. One of the language features that have been quite drastically changed over the past few decades, or something that's really a mistake to introduce in the first place, is something that leads to a little bit of a problem like this here. Anyone in here that's ever seen this before? Like, most of you are liars because you don't raise your hands. Everyone has probably seen this problem. Nullable reference exceptions, or problems with objects not being set to an instance. Now, the alternative is, of course, to always ensure that we have an instance of an object, ensuring that we set something to a default value, which is tricky. So using nulls is sometimes just the easy way of solving this. But there's a little bit of a problem here, right? Because we don't want to end up having applications that crashes. So the solution is for the compiler to tell us that there could be a potential problem. And this has been made by introducing what's known as nullable reference types. This was introduced in C# 8, and the reason I talk about this now, when I promised to only talk about C# 9 and onwards, is because they continuously improve upon this feature. They add things in C# to complete this language feature to make it easier for us to avoid null reference exceptions. So let's jump over to Visual Studio, and I'll show you a couple of examples. Let's head over to a little bit of a project where I've turned on nullable reference types. And we do this by going to the csproj file, and we have nullable enable. And if we have this enabled, you'll see here that we get a couple of warnings. It's telling us that this here is not set to anything. This could potentially be null. And the reason the compiler is telling us this is because it now thinks that every reference type, like a string and an object, they should all be set to an instance. However, the compiler cannot determine that this has been made. So how do we fix this? Well, we can either ensure that we've set this to a value and the warning goes away. But I don't really like this approach. We could also introduce a constructor, which would then be in charge of setting this to an instance. But instead, I want to have this class to ensure me that I've set this to an instance when someone creates an instance of it. And the way that we do this is to introduce a feature called required. If I do this, it's going to move that error away to somewhere else. So the compiler now knows that whenever you create an instance of this details class, you're required to set this to an instance. Therefore, it will know that this is not going to cause a null reference exception. I can also use this together with another language feature called init-only. Now what I've said here is that I've said that you're required to set this to an instance, and you're only allowed to do this once. So effectively, it's an immutable type. Still have the problem with the last name here, and I could say that, well, I'm going to set the last name to be optional. And we do this the same way we've done forever in C# since they introduced nullable value types, by using a question mark. Now what happens here is that the warnings are disappeared from this class here. They're going to be apparent somewhere else. I'm going to do the same thing for this person class here, which is a reference to the details. I'm going to say that this here is required to be specified. So where is now the problem, right? Because the nullable reference exception would probably not have been happening inside that details class anyways. Instead, if I expand this here, we can see that this is where that potential exception would have occurred if someone didn't set this to an instance. So now the compiler is telling me that you should probably null check this property because it's optional. So with nullable reference types enabled and the compiler knowing that everything should be set to an instance, we can now find these places that could potentially cause issues when we run this. And of course, we can be very certain that we try to set this to an instance everywhere, but if we're deserializing data coming in from JSON, then we might not actually have this set to an instance. So what we do here is that we can say that I'm going to use the null conditional operator to say that, hey, there's a default value here. 9 is probably a very bad default value. Let's do 0. I can do that, which is quite nice. So now I added a check here to ensure that this is not null before I proceed to access a parameter. The compiler is super smart, though. It will use something called a null state static analysis to know that I've null checked this before accessing the variable. So I can do argument, null exception, throw if null or whitespace, person.details.last name. So now what happens is that it will ensure that we're not going to get to the next line, and the compiler will know that this method has appropriately null checked this property, which is quite nice. So if I do this with a normal if statement, if I pass it into a method that promises that it performs a null check, I don't have to add this myself. So this here will now tell us that we should do something about fixing this code. And we can use this in other places as well. So for example, I have a method here that returns an IEnumerable of person, and there's nothing wrong with this method signature. But if I expand the body here, we can see that, well, I'm returning null, which is probably a really bad idea. There's also this thing called a dammit operator, where I know better than the compiler. I'm going to say, damn it, this is set to an instance. We can clearly see that that's not really the case here. So this could, again, throw an exception if used incorrectly. But prior to the required keyword, using the dammit operator, or null forgiving operator, which is a more boring name for it, this was the way of avoiding that warning. So if you're stuck in an older version of C# and .NET and you want to bypass this warning, you just do an exclamation mark, and it sort of works. It would be better, though, if I just returned an actual value. Or if I really want to return null, I can say, like, hey, this is optional, but then the consumer of this method has to ensure that they do a null check and so forth. This is just a way to move that warning to somewhere else. So now, if we do this appropriately, we can say, well, I want to yield return, because I don't want to create a new temporary list. I want to create a new something. And then inside this something, I'm going to create a details, set that to another new something. And if we just do this first, there's a couple of cool things here. I'm using what's known as a target type new expression. I don't have to explicitly say that I'm creating a new person here. The yield keyword will create a temporary list. I don't have to create a new list and return that for me. This is just setting up an iterator. The target type new expression will check that I know that you're going to create a person, so therefore explicitly defining person here is kind of unnecessary. Same goes for details here, but I have a compiler error, even though I'm using this thing here. I'm going to set this to an instance. If we zoom in here a little bit, if that will work, let's see here, there we go. It's going to say that the required member first name must be set, otherwise we can't proceed. And this is a C# 10 feature, so I'm going to say here that first name is in fact set to a value, and now I've ensured that this has been set to an instance. Hopefully I don't get any null reference exceptions from this. And of course, if we write bad code and we trick the compiler into thinking things have been set to an instance, we'll still end up having problems. So we should probably try to avoid that. And going forward, there's going to be more improvement to this as well. C#14 is going to introduce null conditional assignment. So even though this language feature that works on avoiding null reference exceptions was introduced for quite a few versions ago, it's still being worked on, still being improved. All right. Let's see here. Come on, here we go. So that's a nullable reference types. Now, a really great thing to also enable when we do this is to turn on a flag called treat warnings as errors. So how many of you are actually looking at all your warnings, ensuring that they are all not there? Fixing all your warnings. Again, I see a bunch of liars. Actually, the audience that probably are the most truthful, because most of you didn't raise their hands, because no one looks at their warnings. But if we turn this on, I bet that people will fix the problems. So what happens here is that once we compile the application, all the warnings will be treated as errors. Doing this on an old application is probably not the best idea, because there's going to be a million warnings. Or you do it and you go on a holiday, and someone else fixes the problem. Probably not a good idea. But it's good to do in new applications. Like if you start a new project, turn this on. It's a very nice way to keep your application tidy, or the code base tidy. Now, C#9, if we're going to talk more specifically about what was introduced in C#9, that introduces the concept of a record type, a new way of creating a reference type. Really just a class behind the scenes. It introduces that concept of an init-only setter to allow us to do immutable properties. Top-level statements, it introduces pattern matching enhancements, there's target type new expressions that I just showed you, and a bunch of different things, all targeted towards lower-level stuff or more performance stuff or things that they need internally at Microsoft or in the .NET teams. So being the 9th iteration of the language, there's quite a few things here that they improved upon. One specific thing that I want to talk a little bit more about, we've looked at the init-only setter and the top-level statement. The top-level statement is this thing, which allows us to write a program file without doing the public static void main stuff. We can just do a very simple, slick program.cs and start writing our code in this. It implicitly it just introduces, it imports things like link and so forth automatically. We don't have to do that ourselves. So it's quite nice. This is used for minimal APIs if you're doing ASP.NET Core. So one thing I want to talk a little bit more about is the pattern matching. And come on. Let's try that again. All right. Buy a Mac, they said. Everything works great on a Mac. I'm just joking. It's never really been a problem. So pattern matching is a way for us to look at certain things. Like in this case here, I can determine what an object is, like what kind of shape or form or colors and so forth. It's a language feature that's been around for a long time in other programming languages. And basically, it allows us to match on an attribute or a type. Let's say that in C# 1 through 6, we were able to check if the type of the fruit is an apple, and we can check a different property. And then we have to typecast that into the appropriate type to use that inside. It works. Like most of us probably write code like this still. It's not the best way to do this, though. Like we have multiple different ways of achieving the same thing. Like if we were to do this with a switch statement instead, we can do something like this, pass the instance into the switch, and that would work as well. We can use a case here to check what the type is, and we can check property values. Don't have to do any typecasting. However, and also use the default case here as well if we wanted to. However, this can probably be improved upon, and in C# 8, 9, 10, 11, 12, 13, 14, this has been improved upon, again, like any of the other language features. They've introduced the switch expression, which allows us to look a little bit differently at how we can produce expressions for different types, to check what the content is, what the type is, certain different property values, and so forth. That's the object that I want to create a pattern for. So I want to produce a result. based on this object. And I'm going to fill this with expressions, basically, as well as patterns. An example of this would be to say, like, hey, what kind of fruit is this? I want to get the text representation of what this fruit is. If it's an apple, I'm going to return this thing here from it, this string here. This could be a method call that produces some complex type. You could do whatever you want, basically. This allows us to write a little bit more complex code that reads more easy. It's easier on the eyes. It's easier to maintain. But again, as with any other language feature, if we use this incorrectly, the code will end up being unreadable. I can probably show an example of that soon, as most of my code. So patterns in C#. There's quite a lot of different patterns that we can introduce. You just saw the type pattern. That's a very simple way of saying, hey, is this the type that I'm looking for? We can check positional patterns used when we deconstruct an object, probably a little bit less frequently used. We can check the property values. We can check values inside a tuple or tuple. We can check the value of a particular field or property on a type, and they create a relational pattern for that. We can create a conjunctive AND pattern, say like, hey, this value has to be more than 10 and less than 20, for example, which is very, very convenient. You can also exclude values by using the disjunctive OR pattern. There's a list pattern. Parenthesize pattern can negate things like saying, hey, if it's not null, don't worry, you don't have to remember all of this. I'm going to show you a couple of these examples as well. We also, if we use more than one pattern, it will first check the first pattern, of course. Like if it's a type, it will do that, and then recursively check the property value, and then recursively check whatever else you're checking, right? So let's jump over to Visual Studio again. I have a quite simple application that has a couple of records defined. So a record type, before we check the pattern matching stuff, this class or these classes are really just generated code, basically. So I'm going to do abstract record, which is really just a record class. A record is a new reference type, where it really just generates code for us. And the easiest way to show this is to compile the application and jumping over to something like ILSpy to show you that what happens here is that the class test result, abstract class test result, abstract record test result. This primary constructor defines a couple of backing fields, a couple of publicly exposed properties, and it also ensures that it implements IEquatable. So a record is a very concise way of producing a class that implements IEquatable and gives us value-based equality, gives us an immutable type. It's a quite nice way of producing types. And checking here, we can see that we have a backing field called number of attempts. If we check the class here, we have publicly exposed property, has a backing field. It's quite a lot of things generated in here. But if I scroll down, one of the interesting implementations here is that it overrides equals. It will first check the reference if they're the same. That's probably the most cheap way of checking if two objects are the same. But then it checks the backing fields. So it will compare number of attempts with the other number of attempts in this case here. So if I have two instances of this test result, if I compare them, it will compare the property values or the values of these different fields. And of course, since there are all classes behind the scenes here, I can do inheritance. So it inherits from that public, from that record. And at the top here, you also see a file scope namespace. So I don't have to wrap my entire class or records inside a namespace declaration. All right, so if I use this, I'm going to go into my program. I'm going to call a method called getTest, which simply returns a test result. Expanding this shows me that I'm going to create a new failed test. If I want to change a value, now I'm going to get rid of that for just a second. If I want to change the value of, let's say, number of attempts to 4, I'm not allowed to do that because this here is immutable. So I'm not allowed to change this value. And immutability is important in multi-threaded applications. And I do want to say, though, that because this is using value-based equality, you're not able to use this with Entity Framework. You can use it for anything else, like all your DTOs and your models and so forth. You can use records, but just not for Entity Framework, because it relies on reference-based equality checks. So if I want to create a new version of this test result with a changed number of tests, I have to use another approach here. I have to create a new instance. I could dereference this to say, hey, I'd like to get test is equal to test with a changed value. And this with expression here allows me to now get a new instance and dereference the first one with this newly created one. And again, in multi-threaded applications, this is really important because now I haven't changed anything. I'm not going to run into any race conditions. Still a million things that can go wrong in a multi-threaded application, but at least we're avoiding the race condition portions, hopefully. All right, so that's the record types and how we use them. Now, to apply some pattern matching here, I'm going to retrieve the abstract class here. Like, we know that this is going to create the failed test, but I don't know that here. So what I want to do now is do var result is equal to, based on the test result, I'm going to produce a switch expression and say that, hey, if this is failed, I'm going to return the text failed. If it's passed, and it has a number of attempts less than 10, you've passed. Okay? For everything else, you failed. So this here allows me to create quite complex patterns. Now, this doesn't look very complex, but what I can say here, like, well, it might be passed, but I've actually not performed the test yet. For some reason, there's a bug. So I can also say, like, well, it also has to be more than 0 and less than 10. Now, as I said earlier, like, we can write really complex patterns. And I can also negate this entire thing. I dare anyone in here to tell me what this is doing now. It's probably just checking if it's null or not, right? Because basically, when you have a type pattern, it's going to ensure that it's an instance of that, so it cannot be null. So it's going to say, well, if this is an instance, this passed. Super confusing. So let's not use not. Use that only for not null, basically. I can also capture this using a declaration pattern, say like, hey, I'd like to get the pass test. Now I've declared that as a local variable that I can use inside my expression. Let's see here. I could do pass dot number of attempts, for example. And this is actually, if we tidy this up a little bit here, this is the correct type. You don't have to do any casting yourself, like it's all captured as the appropriate type inside this expression, which is quite nice. We can also use this not only for switch expressions, but this is applicable to if statements as well. So for example, if we were to do if get test is passed, we're going to go into this little block of code here. Like, they don't have to be super complex, right? So this is checking that it's not null, checking that it's the appropriate type, but we can also, again, check that it has some specific property values. For example, number of attempts, more than 1. Super convenient language feature that's been around for a long time in other programming languages. And C# has picked up, and there's a lot more patterns that we can add as well. Again, I do want to say, don't apply the not pattern here, because that's going to make it all very confusing. And one thing more I want to show you here at the top, you see the global keyword in front of the using? That means that nowhere else in my entire project do I have to add using NDC, for example. It's going to be globally available inside that namespace. It's nice for Blazor applications and Maui applications and so forth, where you might have to do usings inside the eraser files. All right. And there's a couple of more patterns that we're going to talk a little bit more about. But before we do that, I want to talk a little bit more about C#. Specifically C#10. Here we go. So C#10 improves upon the records. They add record structs, a little bit different to record classes. They're not immutable by default. You'd have to say read-only record struct, which is super confusing. But basically, just different ways of storing the classes. It's value-based versus reference-based. It improves structure types. There's the global using directive that I just showed you. The file scope namespace is also from C#10. They extended property patterns so that if you, for example, if you were to, in my case, prior to this, if you were to say, hey, I'd like to get the number of attempts and the length to, let's see here, let's do not number of attempts. Let's do test date dot year has to be more than 2015, for example. Prior to C#10, if we did this, this could throw a null reference exception because it didn't ensure that it wasn't null. What it's actually doing now is to say it unwraps from this. Test date has to be a nested pattern where year is this. This is what you'd have to do in the past, which is not looking as nice. So in C#10, they improved upon this. So when you do a dot, this will perform a null check as well. And this kind of gives you a hint that the curly brackets is actually ensuring that we have an instance. So we could do if test, if I can type test result is an object. That's another way of doing a null check. Not sure I recommend anyone doing this, because again, like, I think this reads better as a comparison. All right, that's a tangent. Okay, and they improved the lambda expressions, constant interpreted strings, and there's a couple of more things in C#10 as well. Some of them less important than others. One of the most important ones is probably, or one of my favorite ones, is probably inferring the delegate types in lambdas. So this is in C#9, you'd have to say explicitly which type of delegate that you're expecting, even though we can clearly see that the lambda produces an input of a string and an output of an integer. With C#10, it simply infers that. Letting the compiler do most of the work for us is a good idea because it's going to do the smart decisions, and it can then also produce the appropriate types that's mostly performant. Like if they add something in .NET 15 that's much more convenient for it to use, but by just recompiling the application, it could potentially be a little bit more performant. This here is an example of a minimal API, which is something that's possible due to the top-level statements, the file scope namespaces, the global using directives, and all the Lambda improvements. And now also allowing attributes in Lambdas allows us to write really powerful APIs. This here is pretty much all there is in a program.cs file to produce an endpoint that listens for /ID on an HTTP call. But without being able to do from header or from body or whatever we'd like to add as an attribute, then the minimal APIs, they aren't really fully functional, like in comparison to a traditional MVC project. But nowadays, it's a little bit of a, like, I think most people would prefer writing code like this here because it's much easier to maintain smaller portions of APIs, especially if you're doing microservices. So if we head over to C#11, we got more patterns. They, again, build upon these language features that were introduced in earlier versions. They're adding a list pattern, a slice pattern, a span pattern, and of course, I'm going to show these as well. There's a name of operator, and performance-wise, they're caching delegates for static method groups, which was, for a long time, if you ran into this performance issue, it was a little bit annoying that it just didn't do this by default. Some of these compiler improvements are probably not super easy to implement, but once they've done it, and there's a huge performance boost by just recompiling the application, I think that's quite nice. The required keyword came out in C#11. I showed you this earlier when talking about the nullable reference types, and it took quite a few versions, right? So 3 versions after they introduced the nullable reference types, only then did we get the required keyword. It can be a little bit tricky to keep out with which version goes with which .NET, which is, again, why you should always keep to the latest version of .NET. But you can also, and I should probably show you this right away before I forget. If you go into your CS project file, let's assume that you're stuck in .NET 6, or anyone using .NET Framework? Oh, wow. There's like a handful. Amazing. What you should do, you should go into your CS prod file and do lang version preview. That will get, if you just have Visual Studio 2022 installed, and you have, let's say, the Visual Studio, the preview version installed or whatnot, this will give you access to all the current features of C#, as well as all the preview features of C#. And by just doing this, you'll be able to access all of those different language features. If you don't do it, like if you're not using the features, it won't have an impact. It will just use the latest version of the compiler, which is a lot better. Now, I said earlier that you can email me if you have any problems. Don't, if you don't have any problems with that. I'm just kidding. It's an unsupported feature. So if anyone from Microsoft, if you ask anyone from Microsoft, they probably don't support that. But there's a lot of source generators that you can use if there's missing things, if you're using .NET Framework and you turn on the latest version of C#. I showed you a couple of interesting features, such as the target type new expression, and there's a lot more that we can build upon as well. But if you don't want to access most of these different things, like pattern matching, that's just compiler magic that would compile down to compatible IL. So if you're working in older versions of .NET, try to just change the language version and see what you can use. One of those language features that is really amazing is the required keyword. And this is also something that's reflected inside system.text.json. If you use that, it will try to enforce that you're actually doing this and you're setting something in the JSON when deserializing the data. So it will look at what your classes are annotated with. There's this concept of a raw string literal. There's static abstract members and interfaces, UTF-8 string literals, so that I can say, for example, in this case, that I'm going to take my string Philip Ekberg, and then I'm going to look at this as a UTF-8 string in memory, which is basically just converted into a byte array. I'm using a read-only span because that is a more performant way of representing our arrays. It's not just in terms of performance when I'm just pointing to the array and accessing all the elements, but it's when I'm doing manipulations, slicing off portions. The spans are a really great way of representing any arbitrary type of memory. And the reason we want to enable UTF-8 support for strings is because they're UTF-16 by default. Data coming in from the web is traditionally UTF-8, so if you have to convert that UTF-16 data into UTF-8 all the time, again, you're going to get a performance hit. A lot of the language features coming into .NET and C# is all about performance, making applications more robust, and making it easier for us to develop. There's generic math support, there's generic attributes. For the longest time, I wondered why this wasn't available, especially when I did ASP.NET, traditional ASP.NET, with web APIs and so forth. But now that's available. What's interesting with C# is that it's open source. And if you've kept up, there's this language feature that was called parameter null checking. Due to community feedback, they actually withdrew this language feature, and I'm going to show you why I think that is. So imagine that I have to say, like, well, if this is null, I'm going to throw new exception, like that. Or it would be more appropriate to say argument null exception, probably. So instead of having to write this for all our different arguments, it would be better if there was a way for the compiler to do this for us. So the language team, they implemented this feature. You just do double bangs, like double dammit, and it did that by default. So it would just introduce the code for you, which is quite intrusive. Like it generates code that performs a null check and throws an exception. The problem is that eventually, with all the question marks and exclamation marks, C# will eventually look quite terrible. Like you'll end up having code that looks like this. Like, I don't really like this, which is also what the community, like, it's not going to end up looking that like. You get the idea, right? The community didn't like this, and being open source, like I'm saying this because if there's something that's coming in C# and you want to participate in the discussions around why that is, or it's like, I don't think this fits into the language, you can go ahead and you can give your comments and tell them that this is not a good idea. Funny thing is, also in relation to why you shouldn't use preview features of the compiler, when they introduced this, they built the feature in the compiler, they deploy them in their nightly builds. All the .NET teams and the language teams use this for all their projects, all the open source projects. Whole of GitHub was refactoring to using exclamation marks all over the place, and then they removed it. Imagine people were upset. Which is why you probably should stay away from preview things before they're actually released in the language. So as you see here, C#11 had quite a lot of interesting features added to it. I'd like to actually go back to Visual Studio again and talk a little bit more about the different patterns they introduced for lists, spans, and slicing, as well as the raw string literals. So let's do that. Let's go over here and check a little bit more patterns. So I have this span of a byte here, and I'm using hexadecimal numbers because it makes me look like a hacker. Doesn't matter. It could be strings, integers, whatnot. Now, what if I want to check if the first element is of a certain value? Well, of course, I could use a normal array accessor and check it. But why not use something like link? The problem here is that this isn't really performant, and it doesn't even work in this case here, because I've changed this to a span. If I change it back to a byte array, I could probably do that, right? But to avoid this, because I don't want that, because this isn't the most performant version, instead, I'm going to use one of the new patterns that's available in C#. I can now say that, well, if the list is an instance of a list, and the first element is 0x1, I don't care about the next one. The third one has to be this, and then it can be followed with whatever. Like, it doesn't matter if it's 0 elements after it. It doesn't matter if this is the last element. It just has to look like that. This discard worked with anything, to say, like, I don't care. It just has to be an element present. It could be null. It could be set to whatever value. We can also say, like, hey, I'd like to check the last element. The last element has to be 0xf2, and I don't care about what the list starts with. Super powerful when we're working with lists of data. Now, in relation to this, we might also say, like, hey, what if this here starts with 0x1, and I'd like to grab everything in the middle? I can do that. So I can now capture or slice off all the elements in the middle of that array. And this is interesting, because now I have a span of byte here, but if I were to change this to a byte array, this here would be less performant. It would have to create a new byte array with that representation, leading to copy of data. Changing this to a span means that I just get a pointer. So spans are basically just pointers to data. And in this case here, I'm just pointing to the middle section of all that data without having to create any extra allocations. So that's the slice pattern. Now, the last one is a span pattern where we have, for example, in this case here, I have my name as a string. This can be implicitly converted into a read-only span of a character. Again, a very memory-efficient way of working with collections of data. Prior to this version of C#, you weren't able to say, like, hey, if that content is the same as this constant string, you weren't able to do that. So now there's a span pattern so that it can implicitly convert back and forth between those supported types. There's also the addition of UTF-8 raw string literals, UTF-8 string literals. So in this case here, again, I've got my name here represented as a read-only span of a byte because I have U8 here at the end. I'm going to find the index of my first name. I'm going to slice off my first name using this syntax here. Slice everything up until the space. Jump over the space and slice the rest of it. Basically, producing a zero allocation way of slicing off data. So in this case here, I don't have to do any extra allocations. Someone is probably going to think now, well, you're actually allocating a couple of references. Sure, but I'm not copying any new data over. Doing this traditionally with link, for example, or copying the entire string contents is a much more expensive operation. Next, we have the raw string literals, which basically allows us to write XML or JSON inline by using these 3 exclamation marks. We can add our code inside that block here without having to do any escaping, which is quite nice. If you're producing any CSV or any XML or any JSON you're going to return, this is quite nice. All right, let's see here. Let's jump over to this just to reiterate here. Here's a different example of the list pattern. So I have a list of strings here. It's a couple of names. I'm going to use the switch expression to check if it starts with Philip, I'm going to capture all the middle ones as long as it ends with Elise. I can skip the first one and say if the second one is Sophie, I don't care about what follows after that. And then I have one that just checks that it's an instance of a list, but I don't care if it's empty or a lot of elements. And then the last one will check that if it's not an instance of a list. Same as doing null, basically. The raw string literals also work with string interpolation, if you want to do that. It's quite nice. When you've ever found the case of using something like this, it's a nice little language feature that you might not use it all the time, but when you run into the case of having to escape all of these different quote marks, it's quite annoying. So this is a nice addition. And again, I think this is probably one of the more important language features to take away from this. Not the UTF-8 string literals in particular, but the way that we can now use something like the read-only span to, in this case, locate that space using the UTF-8 string literal of a space, and I can slice off data to get a zero allocation piece of code. So this here all produces just new spans, which are basically pointers to different portions of that same data. It's great for scanning huge documents or grabbing portions of a document. And the only place where you would then do an allocation is when you do toString or when you need to write this to somewhere. But given that, for example, there's file extensions. If you need to write this to disk again, you only need to have one representation in memory because most of the types in .NET will now support working with spans and memory of T. So once you've sliced off some data, you can very simply pass that on to somewhere else and write it down to disk without having to perform any extra allocations. It's quite nice. Another improvement is static abstract members and interfaces. Prior to this version, if you had a static on an interface, or in this case on iSingleton, you were never required to actually implement this. But now when you have abstract after static, it will now give you this error saying that, hey, this is not implemented, so you should probably go ahead and do that. Now, the next language version that I want to talk about is C#12, which introduces the concept of a primary constructor, taken from that idea of record types, but it works a little bit differently. It introduces collection expressions and a spread element. I've actually had this in the code, but I haven't really talked about it yet. There's a concept called interceptors, optional parameters in lambdas. There's alias any type, inline arrays, ref read-only parameters, and an experimental attribute. So being the 12th iteration of the language, still there's quite a lot to add to it and take inspiration from other programming languages. So let's take a look at this. There's this concept called a collection expression, which will hopefully change the way that you create lists of data. So here, I'm going to create this payload of a span of a byte, and this is the collection expression, having the brackets and following that with elements, instead of having to do new span of byte with these different elements passed into the object initializer. It's not just that, though. Like, it will figure out the target type, and it will produce that without me having to change anything. So if you're passing something into a method, you can let the compiler use the most appropriate overload. By using the collection expressions like this here, it will produce that list for you. Now, I have two different types here. So I have a span of a byte, I have a byte array, like let's just say that this is a list, for example, and I'd like the result to be a span. What I want to do now is say, like, I'm going to take the payload, and I want to combine that with a checksum. Like, I know how to do this with LINQ very easily, but that would require quite a lot of potentially more CPU and memory. Instead, I can use a collection expression to say that I'd like to take everything from payload and spread that across the beginning of this list. So this is known as the spread element. I can then say I'm going to take the checksum, not HR, checksum. Come on. There we go. And spread that after the payload. I'm not limited to 2 here. I'm not limited to, I can do this. Don't know why you would do that. That would be totally confusing to the consumer of this. But you can do that. You can spread as much as you want across this using the collection expressions. And what it will do is that it will use the collection expression to create the target type you're expecting. So in this case, a span of a byte, which will then create the most appropriate version of that for you. Most memory efficient way, so to say. we also got the concept of a primary constructor. So if you're working in MVC or APIs or, or view models or whatever, probably have a bunch of different repositories and services injected into your classes. This here is a primary constructor. If I were to change this from a class to a record, what happens is that this is publicly exposed. It will then publicly expose the repository to anyone that has an instance of this object. If I change it to a class, the primary constructor will only set this to a private field. It will not be exposed publicly outside of this class. You can still use it inside of this class, like this here. I have a method here that returns a tuple or tuple, and I'm consuming that repository. So very much just like a private field that's set in the constructor, but you don't have to write that boilerplate code yourself. All right. So the collection expressions are a great addition. Very easily allows us to construct new lists of data and also use the spread element or spread operator, I think it's spread element, to spread that across. Primary constructor is probably great for things like a controller, but less so for things like this here. This is just a DTO, right? Adding the primary constructor here is probably not what you'd like. Because if I decompile this and take a look at the source code, we can see that this generates a backing field that is then just set inside the constructor. You'd probably be better off using a record in this case here. And they also added optional parameters in lambdas, again, allowing us to further embrace the idea of using minimal APIs and writing code that more represents what you would actually write for normal, traditional MVC controllers and actions as well. There's also this concept of alias any type. So at the top here, I'm saying like, hey, I'm going to use dimensions, and every time you refer to that, it's going to be a tuple or tuple, depending on how you want to pronounce that. And you can alias anything that you'd like to. In this case, I did a tuple. They also added a concept of interceptors. This is for source generation. So let's consider that we have this piece of code here. In my case here, I haven't implemented log internal, but I'd like to replace this. Let's say that I install a NuGet package that analyzes my code, and it's going to produce a very performant implementation of log internal. That's done by introducing this interceptor. So this method will intercept log internal, and that's a generated piece of code. The implementation looks a little bit different as of .NET 9, and its primary use case is for source generation. But basically, it allows anything to replace anything in your code. So if you install a NuGet package and you say like, hey, I'm allowing you to intercept any of my code, then basically it can intercept whatever we want. This is used a lot in ASP.NET Core, especially when doing ahead-of-time compilation. It's a good language feature if you're doing source generation. All right, so the current version of C#, which is C# 13, doesn't introduce as many groundbreaking features as the prior versions did. They introduced the field keyword, which is up until a couple of weeks before they released it publicly, or released the STS version of .NET. That was not preview. That was supposed to be a part of .NET. But for a couple of reasons, they withdrew that, and it's now a preview feature of C#. I'm going to show you that as well. They introduced params collections, a new lock object, implicit index access, overload resolution priority, and they've done some improvements to partial types. So let me show you a couple of these features. So first off, let's wait with a field. Here's a very simple one. If you're working in multi-threaded applications, you've probably used a sync root, a private static object in your class that you use with a lock keyword. If you simply change that to this lock object instead, this new type in .NET 9, the whole internal implementation of how the locking mechanism works, how this works, will be a lot better. It will no longer use a monitoring-based API internally. It will be better thread synchronization, which is in overall better and hopefully a little bit more performant as well in comparison to the older style. So try just to change your object, like you had this before, to a lock, and then it will just be better, and just recompile the application. Now, when it comes to field, here I have a professor that works in a particular field. I have a public field, I have a public property called field that's going to return this. But as you see here, this is blue, this is highlighted. if I were to go back here and not use a preview version of .NET, what happens here is that this references the backing field. But as I upgrade to, which is actually going to be C# 14, which is going to come in November, this is going to change. Because now, come on, I'm not doing that. Here we go. Now what happens is that field is now a contextual keyword that references the backing field of the auto property. So for example, I can say that I'd like to sanitize the field before I set the backing field to a specific value. Or probably better off doing that when you return it from this, so you always store the raw actual data, so you can recover if there's a problem. But that's beside the point. So this language feature is kind of a breaking change. If you want to access the backing field, you'd have to use the keyword escaping character like this here. Just like async and await, basically. They're contextual keywords. So if you have a backing field called field, you're going to run into problems, which is why they changed this to be a preview feature as of .NET 9. It's going to be not a preview feature in .NET 10. All right? And I would say that it's nice because you can now then sanitize data before you set the backing field or before you return the value. You don't have to introduce the backing field yourself if you don't want to. But I do believe that this is the first time that they've introduced a breaking change in the language like this here, unless someone would have named their variables await or async in the past, right? The problem here is, of course, or the solution is to use the keyword escaping character, if we'd like to. Now, they're also going to introduce something called params collections, which builds on this collection expressions implementation in C#. It works with spans, read-only spans, arrays. It's going to avoid implicit conversions. It will use the spans will take precedence over normal arrays. So it's quite a nice language feature, to be honest. But in this case here, if you are a human compiler, you're probably going to notice that these are ambiguous. Like, if anyone saw that, I'm very impressed. So it won't be able to figure out exactly which one of these it's going to use. And that's why they also introduced another type of language feature, or an attribute, called overload resolution priority. So in this case here, I can simply add a overload resolution priority attribute and say which one takes the highest priority. If you're building APIs or big internal libraries, this is a good addition. Because you won't know if that there's an ambiguity until someone actually uses the code. And again, the new lock object provides a better thread synchronization through a new API. They're also making changes to how partial types work. So in C# 13, you can now have partial properties. And going forward, they're going to do even more with partials. And this is, of course, for source generation. If you're not doing source generation, like, there's no reason why you would add a partial class yourself and also the partial implementation in the same project. The final feature of C# 13 is implicit index access. If you're creating an instance of an object and you want to reference the last element, use the hat symbol, and that's implicitly then referring to the last element of that list on that type. Kind of a small feature to add as well. All right, so with a couple of minutes left, what's next for C#? There's quite a lot in terms of what they're experimenting with, and a couple of the things I'm going to show you probably won't make it, so it's just a little bit of fun. And I do want to say that they're doing an experiment where they're changing how async and await works. They're introducing a feature called, I think it's called async 2 or runtime async, depends on which week you're asking them. Basically, instead of requiring the compiler to do an implementation of a state machine and produce all the code that it has to do when you're adding async and await, what if the runtime knew about async and await? What about if it knew about green threads or better reusability of threads? If it did, then the compiler could just stop generating all that code for you, and the implementation of async and await would probably be a lot more performant. Because honestly, there's a lot happening when you're adding the async and await keywords. So that's going to be an interesting evolution, but probably won't make it to C# 14. Maybe it'll make it to, I don't know, 16, 17, who knows. Gives me a reason to come back. So for C# 14, there's a field keyword that's no longer a preview feature. There's implicit span conversion, so it's easier for you to use spans everywhere. It will just do implicit conversions wherever possible. There's this thing called extension members or extension everything. There's simple lambda parameters with modifiers. Again, partial improvements, so you can now declare the constructor as being partial or events as being partial. And again, this is for source generation, to allow source generators to produce code that's more performant or do whatever it wants, basically. There's also the null conditional assignment, which is, again, building upon this feature that's now, with this version, has been around for 6 versions of C#. Nullable reference types has been around for a long time, and they still find ways to improve this language feature. All right, so extension everything was supposed to make it to C# 13. In fact, it was supposed to be added a long time ago, but it's a really difficult language feature to implement. This is a public static class, just like you do any extensions. But instead of creating that extension method that you've seen in the past, we simply say, hey, this is an extension for the class user. And it's actually an extension on the instance of that user. So I can add instance properties or instance methods on it. So it's not static anymore. A little bit of a different way of working with the extensions. So basically, you can add whatever you want to any type available. The null conditional assignment will now, what this does is that it will first perform the null check before it sets the name to Philip. So instead of wrapping this in an if block, we can now very easily write this piece of code instead. I have a hate-love relationship with this language feature because I think it looks nice, I like the idea, but it will also be a lot harder to analyze visually the code that we look at. Like, again, not just because it's a question mark, but it's very easy to miss that there's a question mark here. It performs a null check. So therefore, it might not be set to whatever I'm looking at. I'm just thinking that this here will give me a little bit of headache when I debug my applications because I was scanning my code visually so fast. But we'll see. I like the additions and improvements in terms of null reference exceptions and null reference types, basically. So with that being said, there's a lot happening with C# as a programming language. We're going to see a lot of additions to C# going forward. A lot of this is going to improve the way that we work with C# and how we write code that's more maintainable and easier to understand and, avoid problems. Hopefully, you found some of these language features interesting and found some inspiration as to what you can add to your projects. And if you haven't, there's a lot of stuff I have on Pluralsight that you can check out. I have a lot of courses on C#, on building an operating system, if you want to do that, and going in deeper on async and await and all of that. Again, it was really nice talking to all of you about all of the new things in C#. If you do have any questions, send me an email afterwards. I hope you're going to try to apply some of this in your applications. And on the way out, feel free to leave a green thing in the box. If you didn't like this, skip the line and get a coffee. All right? Thank you so much.
message coming down the line. It's Control Zero. Look at your ASCII chart. Every single one's got a story to tell. They're gonna play their part. From the start of header to the console bell. And if your alphabet has letters that they don't use in the USA, better check the code page or you'll find you're in disarray. And the message coming down the wires in KOI. Now on the internet, every single email and website they're built on Unicode with information packed into every byte. And I'm reading and I'm reading and I'm reading from the data stream. But I got my hands the wrong way round, now it's all in Chinese. And the messages in my DMs, I don't know what they mean.
Hello, NDC. How's everybody doing out there? How's everybody else doing out there? Eli's doing woo. Let's talk about algorithms. Because I love algorithms, and algorithms are they are the sort of the fundamental building blocks of computer science, and they are important, and they are scary. And, you know, a lot of folks working out there in tech, the word algorithm, depending how you found your way into this industry, either algorithms are like, oh, they're this thing that we did back in school, but we don't really think about them very much anymore, or they're a thing that you had to learn because you were trying to pass exams, or because you're trying to do job interviews or something, or they're just a thing that you don't even realize that's what you're doing, because that's not how you think about it. And then you decide to have a go at something like Advent of Code. And you're getting along great, and you've done day 1, and you've done day 2, and on day 3, the elves have to find their way from this corner of the maze to that corner of the maze, and you look at it like, this is kind of hard. And so you go and you look on Reddit, or you ask one of your friends for help, and they say, that's easy, just use Dijkstra's algorithm. And you're like, huh? So you type Dijkstra's algorithm, and you get this, and you get the Wikipedia page, which says, is an algorithm for finding the shortest path between nodes in a weighted graph. And you're like, oh, well, I don't have a weighted graph. I've got a little maze with elves in it, Now, I think the Wikipedia pages that are the top Google hit when you search for algorithms are the worst documentation that has ever been written. It is the online encyclopedia that anybody can edit and nobody can read. And that's not their fault, because to write well, You have to know who you are writing for. You have to understand your audience and their expectations, their background, the vocabulary they have. And so, of course, Wikipedia has to have a page about Dijkstra's algorithm because it's got to have a page about everything notable. But who's it for? Is this for mathematicians who want to study the time-space complexity? Is this for somebody who is, frantically cramming because they have an exam in the morning and they need to learn about it? Is this for me? Because I'm writing a talk about algorithms and I want to know what it says. And, the big challenge that I've always found with any kind of, algorithms thing is basically we're trying to take this wonderful, powerful, elegant thing that doesn't exist in space. It exists in information. And we're trying to communicate it from one human being to another human being so eventually they can tell a computer how to do it. And when humans talk to humans, we're like, well, we could use human language. So what you start with 1, and then you count to the limit, adding the square of the number to the sum, and you're like, oh, so, okay. Maybe we'll do it with pseudocode. Or maybe we'll do it with actual code. We'll do it in JavaScript, because what could possibly go wrong? Or maybe we'll do it in maths. Who can read maths? Who can't read maths? Who sees something like that and just goes, I don't belong here? There's been a horrible mistake. I should have been a shepherd. This is not for me. And I hate this kind of, people get to these wonderful, beautiful things, and the way we have to communicate them so often just creates this huge barrier to accessibility. And you persist, you kind of work it through. You're like, all right, so we'll do this and we'll do that. And eventually, the little brain light bulb goes, bing, and you're like, oh, I get it now. And then you go back and you look at it, and you're like, well, okay, I guess. But once you have that model in your head of how the algorithm works, you look at the line, well, that's not how I would have described it. And that's not how I'd code it. Those variable names are stupid. And I still don't know what the maths is for. Do you know what you call a mathematician with a job? Software developer. So if you don't know what Dijkstra's algorithm is, and you want a working definition that will kind of get you to the next step of your journey, it is a magic spell for solving mazes. That's as good a definition as anything. In fact, it's a better definition, because I'm assuming a lot of you folks out there have played like Dungeons and Dragons or, Baldur's Gate. You know that a spell is a thing you have to learn. And then once you've learned it, it just becomes part of how your character looks at the world and goes out and solves problems. So, rule 1, algorithms, I know I said demystified, and this makes them more mystified. Algorithms are magic spells for doing cool stuff with computers. Now, before we go any further, there is another very important thing I want you all to remember about algorithms. They are the nuts and bolts of software engineering. How many of you folks do, you work on your own car, or you build mechanical things for hobbies, or you've done some work on your house, any of that kind of things? How many of you make your own nuts and bolts? How many of you own these? Because, nuts and bolts they're vital. We take them for granted. We don't make our own, because it's stupid. It's fun, takes a lot of time, you learn a lot in the process, but if you're trying to do something like put up some shelves in your apartment and you start by making all of your own nuts and bolts, that is not a very efficient way to solve that problem. Almost everything I am going to show you today, there is already a really good version baked into whatever language or runtime you use to do your job that's probably better than the one you'd be able to come up with, even after this talk. So please do not go back to work and implement your own algorithms. Understand them, learn how they work, learn what they're for. Don't go back to work and roll your own. That's like making your own nuts and bolts. We have easier ways to do this stuff. Now, the word algorithm, actually, it comes from a person's name. This guy, Al-Khwarizmi, was a mathematician in Persia, I believe, in the 9th century, who wrote a book in Arabic about how to use mathematical techniques to solve certain kinds of problems. And it was translated into Latin as Al-Khwarizmi's method for, mathematical applications using the Hindu numbers. And Al-Khwarizmi eventually got anglicized, turned into English to the word algorithm, and it came to mean a mathematically rigorous set of steps for solving a specific problem. The problem is language, because language evolves, and people see a word, they think, ooh, I'm going to use that word, that makes it sound important, and you end up with things like the Facebook algorithm. The Facebook algorithm is not an algorithm. It's a statistical model for showing you 8 news stories you don't care about, and the fact that your friend was in town last week, and if you'd known about it, you'd have met them for dinner, but now they've already gone home. Now let me introduce you to the universal algorithm. This algorithm will solve any problem that can be solved using computation. And it's very, very simple. We start at the start, and we say, are we done yet? And if we're lucky, we're already done. Look at that. Woohoo, finished. If we're not, we got to do stuff. And after we do stuff, we go back and we check, are we done already? The two defining characteristics of a good algorithm, one is what is called an exit case. How do you know when you've solved the problem? Because if you don't know, you're just going to go round and round and round and round and round, and that's an infinite loop. Or the reason why the exit case is important is quite often, particularly if you're doing things like advent of code or leet code puzzles, you'll come up with a solution that you start it running, and after 10, 15, 20 seconds, it still hasn't done anything. And you're like, is that an infinite loop or is it just slow? And with, I don't know if anyone saw Matt Parker at the Developer Festival last year. Matt had a Python algorithm that ran for 31 days. And somebody on the internet got it down to 60 milliseconds. But he was like, I didn't care, I just left it running and went to Australia for a month, and when I came back, it had solved it. Some of these problems will take a long, long time to compute, and if you are confident that you don't have an infinite loop, you can just leave them cooking until they come up with an answer. Now, something that melts people's brains. I studied undergraduate computer science at the University of Southampton. I graduated in 2000, and the first year, we had quite a high dropout rate. Because a lot of people go to study computer science because they like computers, and then they try and teach you formal academic computer science, and a lot of people are like, I didn't sign up for this, I'm going to do something else with my life. And the week that we lost more students than any other was the week that we learned about recursion. And recursion is where do stuff means apply the universal algorithm. And this, like I said, it melts because they're like, now to me, the mental model of recursion, it's kind of like you're trying to build an arch. The problem is that there are no sort of intermediate steps. It doesn't work, and then 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 suddenly it works, and you're like, hang on. And so you try to backtrack one step, and it doesn't work. And once it works, once it clicks, you suddenly have this wonderful solution, which you're like, how does that work? It's sort of built on top of itself. Like, how does it stay up? But recursion is wonderful. Now, there's an example. The example that kind of made it click for me was how to recursively build a tower out of building blocks. And I've tried to avoid having any actual computer code in this talk. There is a little bit, you'll see in a minute, but we're going to use pseudocode and descriptions and examples. So to build a tower of height h blocks, first of all, if h is 0, you're done. Build me a 0-block tower, all of you. Well done, excellent, great work, you're all promoted. If h is not 0, what you want to do is you want to put down one block, and then you're going to build a tower on it. And that tower has a height of h minus 1. So if someone says, hey, build me a 4-block tower, well, we're going to put down a block, and then we're going to build a 3-block tower on it. So we're going to put down a block, and we're going to lay a 2-block tower on it. And we're going to put down a block, and we're going to build a 1-block tower on it. And we're going to put down another block, and then we're going to build a 0-block tower on it. And we know we're done, because 0-block tower is already done. So there we go, we're finished. So this is this idea of recursion. A lot of the algorithms we're going to look at, they are based on the idea that you can use recursion to go, right, I'm going to take off this little piece of the problem, I'm going to solve that, and then I'm going to take the rest and feed that back as the input to the next iteration of the algorithm that we're doing. Now, I love this cartoon, because sometimes this is a little bit what it feels like, because it does look like this thing just keeps calling itself and calling itself and calling itself and calling itself. But recursive algorithms, sometimes they're a really good way. You can crack a problem in half, and you solve the halves, and then you crack the halves in half, and you solve the halves of the halves. Other times, they're like, we'll take off one case and leave the rest, take off one case and leave the rest. Both cases, what it means is you just get the same set of rules, but you get to keep applying it over and over until the problem falls out the other end. So let's look at a problem. Let's look at a real and serious and important problem. We're playing a game of Scrabble. And we're playing a game of Scrabble with a junior developer, and they play the word yeet. And we're like, yeet is not a word. And they say, yeah, it is. It's like when you get the OG Riz, but they got no drip, so you yeet them before it gets a hi-oh, no sus, bruv. And you're like, no. None of those things are words. Let's look it up. Let's look it up in our Scrabble dictionary. Now, our Scrabble dictionary is, it's not the official Scrabble dictionary. It's this Scrabble dictionary. It's only got 4-letter words in it, and it's in random order. Is yeet in that list? It's going to take a while, right? I clocked myself. I could check about 5 words a second when I was looking at this list with reasonable accuracy. So for me to look up one word in this little Scrabble dictionary is going to take me between 2 and 3 minutes, and I might have made a mistake, and I might have missed it, and I might have to go back and check it again. Clearly, this is going to be a very tedious game of Scrabble if every time someone plays a word, we got to go and look it up in this dictionary. So let's skip on. We're going to say we'll allow yeet. Next turn, our opponent plays the word Riz. That's where the Scrabble players start twitching, because like, there aren't 2 Zs. You can't have 2 Zs in the same word. It's fine. We're using expanded millennial Scrabble edition here. But this time, our dictionary is in alphabetical order. So we bring up our Scrabble dictionary, and we can apply one of the most powerful ideas ever come up in software, which is something called a binary search. If we know something is in order, we're like, right, point to the middle. Where's the middle? There's the middle. The word lion. That's not Riz, so we haven't found it. Is Riz before or after lion? After. All right, so we're going to throw away lion and the first half of the dictionary, point to the middle, self. Is Riz before or after self? Cool, we're going to throw away the second half. Pick, before or after? Throw away the first half. You're getting this. This is beautiful. Pick the middle, rent. Yep, throw away the beginning. We've got one person doing all the implementation here. This is our comparison algorithm right down here in the front row. So we got down to roll, and we throw away half, and we got riot, and we throw away half, and we got road, and we throw away half, and we got one word left, and that word is rise, and rise is not Riz. And so one, we have determined you cannot play Riz in this game of Scrabble. Not allowed, it's not in the dictionary. But also, if we did have the word Riz, we'd know exactly where it was. If we wanted to insert it, that's the point in the dictionary where we are going to insert that word Riz there. Now, I have magically hand-waved over a bunch of stuff there, because I just said, oh yeah, we put our list of words in alphabetical order, and you all kind of came along for the ride. That's not how it works. Now, sorting algorithms are the powerhouses of information processing, because they're how we put nature in order. We take all this chaotic, messy stuff from out there in the real world, and we put it in order, because putting it in order makes it easy to process, makes it easy to find things, makes it easy to see if anything important is present in this list, or maybe it's missing. Now, when we start processing, when we start putting things into specific orders, there are 2 things that we need to anticipate. One, we need to know what order we're talking about. Now, Latin English alphabetical order is relatively well defined. If any of you folks have seen me talking about text encoding, alphabetical order is one of those things countries don't agree on. Because the English alphabet, or the Latin English alphabet, it's not the same as the Norwegian alphabet. And when English people are given Norwegian letters, we put them in the wrong place, because we don't know where they're supposed to go. And then Denmark comes along and goes, oh, hey. And then Sweden comes along, and then Spain comes along and goes, well, we got Scrabble ends with little tildes on the top of them that go somewhere else. So we have to agree. Now, it doesn't matter what alphabetical order you choose, as long as the one you use when you do your ordering is the same one that you use when you do your searching. Otherwise, you're going to have a bad time. And the other one is we need to think about something called space complexity. You folks ever reorganize your books? You know the best way to reorganize a library is you get another library, and you put it next door to the first library, and then you take a book off the shelf, you walk next door, and you put it where it's supposed to go. The biggest headache is that most of us don't have a spare library or a spare bookshelf or a spare study. And so when we want to reorganize the books, we're like, well, we could take everything off the shelves and pile it up and then have to put it all back. Maybe you don't even have the floor space to do that, because you have, 500 square meters of living space and 498 square meters of books and a cat. In which case, you need to be able to sort in place. You need a way of saying, I'm going to take one book off, and then I'm going to put that book where it goes, so that you're not using any additional storage. Now, we're going to look at a couple of sorting algorithms. And the first one we're going to look at is, it's the friendliest. It's not the fastest. It's not the most powerful. It's not the most optimal. But it's definitely the friendliest. It's an algorithm called bubble sort. And it's a game for 10 volunteers. So I need 10 volunteers from the audience. You'll get to keep your eyes open and your clothes on. It's absolutely fine. Nobody will have to write JavaScript. And it would really help if at least one of you was Dutch. Could I please get 10 volunteers here? Yes, so we got one down here. Come on up. 2. Come on, we can do that again. Nobody saw a thing. It's fine. So what I need is 8 people stood down along the front of the stage here. Hello, Chris. So 1, 2, Eli, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So you come down here. Now I need you folks to kind of just close it up a little bit from this corner. So 1, 2, 3, 4, 5, 6, 7, 8. All right, you 8, you are the elements. Now you 2, you are the flag officer. You get to come up on the stage here and stand behind the elements. Now this is the sorting helmet. And your job, you are the looper. Now, let me introduce you to the rules of bubble sort. So the elements, when somebody says go, check if you're wearing a helmet. If you are wearing a helmet, look at the person on your left. If you are taller than them, you swap places. Otherwise, you give them the helmet. All right? I realize the instructions are behind you, but I'm sure the audience will correct you if you get left and right wrong in this scenario. The flag officer, at the start of the game, you lower the flag. If you see 2 elements swap places, raise the flag and keep it raised. And the looper, your job is to watch the helmet, and if the person wearing the helmet sits down, now you're going to need to close up just a little so that you can all actually sit on the stage here. So we're going to need the elements just to defragment a little bit. Everyone move that way. If the person wearing the helmet sits down, you take the helmet off them and you take it back to the start of the list. So I'll start us off. So you got your eyes on the helmet. We haven't got to the exit condition yet. Holderness, you wait your turn. All right. We ready to play bubble sort? You watching? You watching? You two probably want to come over here. Okay, so when I say go, if you're wearing a helmet, look at the person on your left. If you're taller than them, you swap places. Otherwise, you give them the helmet. All right, go. Very good. The flag is up. We've witnessed a swap. Go. 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 Stop optimizing. Go. All right. We've hit an edge condition. There is nobody standing on your left. If nobody is standing on your left, you sit down. Go. If the person on your left is taller than you, give them the hat. Go. Go. Now, what we've demonstrated there, this is known as an unstable sorting algorithm. It doesn't guarantee that elements with the same value won't get swapped somewhere along the way. That's a real thing in actual computer science. All right, is there anyone standing on your left? Are you wearing a helmet? Sit down. All right. Go. 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 All right. Go. 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 Note for next year, buy better helmet. All right. Now, some of you folks might see what's going on. Keep going. So go, go, go. You might see what's going on here. All right. And now we have an infinite loop. We need to introduce two things. So first of all, what I'd like you to do now, so first of all, you're in order now. So you've all decided. So let's have a round of applause for the successful implementation of the first round of bubble sort. Now I want you all to stand up where you are. And we're going to run the algorithm again. All right, so you go. Now you can see what's going to happen here. Is that Helmut's going to get to the end. Chris is going to sit down. Helmut's going to go back to the beginning. This is suboptimal. So what we're going to do, flag officer, we're going to introduce an optimization for you. If somebody wearing a helmet sits down, look at the flag. And if the flag is up, you lower it. But if the flag's already down, you just shout the word sorted. So Chris, stand up. We'll run that one more time. Now we've got the optimization in place on the algorithm. Okay. So flag is down. You're watching the helmet. Go. 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 Somebody wearing a helmet sits down. Inspect the flag. Sorted. So we've optimized bubble sort there. So let's have a huge round of applause for all of our implementation details. You folks can all go and sit down. Thank you very much. Whoever has the best question at the end, they can have the hat and they can wear it on the boat cruise tonight and be a real Viking. We'll not give you the flag in case it starts an incident. The fallen heroes. So that is basically how bubble sort works. And if you watch the way it happens, you notice the way that the first pass through the list kind of until we get to a tall person, and then that tall person bubbles all the way to the end of the list, and then they sit down, and then we don't look at them anymore. Now, we're not going to visualize all of the algorithms by getting volunteers up here on the stage, because the chaos would be hilarious. And we haven't had enough to drink yet for that. Instead, we're going to visualize them using this tool. So this is it's kind of a rite of passage. There's a lot of folks out there that have gone on the internet and they've written little things for visualizing sorting algorithms with sound effects and animation, all kinds of stuff. Something that I have learned in the course of putting these demos together is quite a lot of these people got the visualization right and they got the algorithms wrong. Because there's a lot of visualizations on the internet of bubble sort and quick sort and shell sort and all the things that don't actually do the sort properly, but they do look very nice. But this is one that I found. The link is there. It's by somebody called Missoula on GitHub. They say they built it because they wanted to learn to use Svelte. Not entirely sure what that is, but whatever, you do you. But what I love about it is it has sound effects. So this is bubble sort. Purists will note I've done two things. One is I added the optimization at the end there that wasn't in the original. I've also tuned bubble sort into F# minor so it doesn't sound quite so happy. Now, this is probably a good time. Bubble sort is not fast. Like I said, bubble sort is friendly. Bubble sort is very, very easy to kind of understand. And to me, it always felt quite natural, this idea, of course the things are going to bubble to the top, because that's how bubbles work. But it is not a terribly efficient algorithm. And this is another thing where folks who kind of found their way into computer science just by building stuff and solving problems eventually come across somebody who starts talking about big O. And you can tell it's big because it's much bigger than the banana that we've got on the slide for scale. And big O is how computer scientists talk about how long it's going to take to solve a problem and how much memory you're going to need and all of these kinds of things. So let's do a couple of little, just to give you a sense of the complexity here. First of all, I'm going to show you some lists of words, and I want you all to shout out the first word in the list. Okay, you ready? Go. Yeah, all right. Next one. Next one. See? Easy. Doesn't matter how big the list is. Shouting out the first element in the list, that's always easy because the way we work with lists and computers is we normally know where the beginning is. Because if we don't know where the beginning is, we probably don't have a list, we have a mess. We know where the beginning is, we get the first element of the list. It doesn't matter how big the list is. It could be terabytes of list. The first one is easy. It always takes the same time. This is known as big O of 1. or order 1 or constant time, because it always takes the same amount of time to solve the problem, no matter how big the input is. All right, let's do another one. This time I want to know, does the list contain the word drip? Yes or no? You ready? No. It's more complicated, right? I don't think it does. I didn't actually check. Problem now is that to know whether drip is in the list or not, we need to check every single word. And because the words are not in any order, we need to look at every one of them. So as the input gets bigger, the time to process it gets bigger, but it scales linearly. If the input's twice as big, it takes twice as long. If the input's 10 times as big, it takes 10 times as long. It's what they call big O of n, or order n, or linear time. It's still way bigger than the banana. All right. Does the list contain any duplicate entries? Is there any word that appears in the list twice? You ready? Yes. Which word? Correct. There is a duplicate in this list. Somebody is very good at reading stuff. Now, the problem you got here is the list is not in any kind of order. So the only way to definitively know whether this list contains a duplicate or not is, all right, let's look at the first word. Let's look at byte. Let's compare byte to every other word in the list. There are 360 words on this slide. OK, none of them is byte. All right, so let's look at the next one. The next one's horn. Now, we don't need to compare byte to horn because we already compared. We don't need to compare horn to byte because we already compared byte to horn. So, OK, cross off horn. Now that we got to compare to all the rest of the things in the list. Byte, we need to compare 359 times. Horn, we've already done byte, so 358. That, 357. Flag is 356. Some of you folks might recognize this progression, 359 plus 358 plus 357, all the way down to 5 plus 4 plus 3 plus 2 plus 1. These are known as triangular numbers. And there's a fun little geometric thing you can do, is you can say, right, well, if we make the triangular numbers out of little blue circles, and then we take that shape and we copy it and we swing it around, we're always going to get a rectangle. And the rectangle is always going to be the same height as the number of steps we had to do. And the width will be that number plus 1 because shapes, because geometry. And so the number of blue dots on that slide there is going to be 5, or in this case n times n plus 1, and then divided by 2 because we want to throw away all the yellow ones. So this number, the number of blue dots here is this. It's n times n plus 1, and we divide the whole thing by 2. Now, the thing about the difference between kind of the big O order of complexity and actual maths is order of complexity doesn't give a crap about anything that is going to be insignificant when we get to the big numbers. Now, the 2 is always 2. It's 2 at the beginning, it's 2 at the end, so we can ignore it. It doesn't actually have any bearing on the way the algorithm is going to behave. The n, as we get to big numbers, n squared is going to be massive, and n is just going to be n. And even if n is quite chunky, n squared is going to be like absolutely huge, so we can ignore that as well. And so the order here, the complexity of this, is order n squared. Every time our input gets bigger, the size of the problem gets squared bigger. It gets huge. Now, this is a problem. We talk about quadratic time or quadratic complexity. If you have a bunch of unsorted data, say we've got customers in a database, and we want to compare, that database is not sorted, but we want to know if we've got the same customer in there twice. We want to know if we've got any duplicates. If our data is sorted, it stays relatively linear. If the data is unsorted, say today we got 100 customers, it takes us 100 milliseconds to find a duplicate. Tomorrow, we get another 100 customers. So now it's gone from 100 to 400 milliseconds. We double again, 800 customers. Now it's 6 seconds. Please hold, your call is important to us. We're just checking it on the computer. We double it again, we're going to get to 25 seconds. By the time we get to 10,000 customers, it's going to take 27 hours to find out if the same one is in there twice. And companies like to get to 10,000 customers because that means you've got customers, and customers have money, and money is nice. So we probably don't want quadratic complexity involved anywhere in our equations. Now, bubble sort has quadratic complexity. because we got to sort the first instant, and then the second one, and then the third one, and each element in the list has to compare itself to every other element in the list. So that's expensive. So you probably don't want to bubble sort anything at your job. Bubble sort is not the only sort algorithm in town. Let's imagine we got a deck of cards, and the deck of cards is cut in half, and then the two halves have been sorted. So if you've got two halves of a deck of cards and you want to put the whole deck in order, that is actually pretty easy, because all you do is you look at the top of each half, and you're like, okay, every time we do that, we're just going to take the next card in sequence from whichever deck of cards happens to have it. Now, this is known as a merge sort, and it's based on this idea that you split your problem in half, you sort the halves, and then you just merge the halves back together, because that's very fast. How do you sort the halves? Merge sort. How do you sort the halves of the halves? Merge sort. Merge sort all the way down until you just have two cards, at which point you just put the bigger one first, and then you merge sort that back into the next one and the next one. Merge sort, visualized, looks like this. Now, if you watch closely, you'll see a point just before the end where you've got the two halves of the deck of cards, and then it kind of weaves them all together. Isn't that a pleasing noise? Now, there's a bunch of other sorting algorithms that are out there. Now, all of these things, they have their strengths and their weaknesses. The mathematically ideal ones are the ones that work really well on uniformly sorted data. Real life normally doesn't have uniformly sorted data. Real life normally has the data you sorted yesterday plus the new stuff that happened overnight. Or real life has the data that you sorted in this company plus the data that you got when you bought this company, which is also sorted. So there are some really interesting optimizations. There's a thing called an insertion sort. Now, insertion sort is really, really good at sorting what you've got, and then if you get another record added to it, or another one, it will put the new record in the right place very, very quickly. That is the second coolest thing about insertion sort. The coolest thing is that it sounds like this. That's the Space Invaders pew, pew, pew algorithm. There's a thing called a cocktail sort. Cocktail sort is bubble sort, but it goes both ways, like a cocktail shaker. Now, there are two very popular algorithms which are named after the people who created them. The first one is shell sort. It was invented by Donald Shell in 1959. It doesn't have anything to do with shells, seashells or bash shells or any of those kinds of shells. Shell sort works like this. And then there's Tim sort. Tim sort was invented by Tim. And Tim was, who was Tim? Tim Peters in 2002. Now, Tim sort is the standard sort that's used in Python. If you're working in Python and you have any set of data and you just tell Python to put it in order, Python uses Tim sort, which is a combination. It's a hybrid algorithm that combines merge sort and insertion sort. So it merge sorts the thing in the first place, but then insertion sorts if you add new things to it. And it's actually very, very good. It looks like this. Now you can hear like the pew, pew, pew Space Invaders noise in the first part, and then it riffs them together like a deck of cards. Finally, there's quicksort, which is the one that most people will have to implement on a whiteboard when you go to a job interview at a terrible company. Quicksort is kind of the fastest one on most like average distributed cases. So hypothetical inputs that are always randomly distributed, quicksort tends to be the quickest. It can get stuck. It has degenerate cases, and the implementation, if any of you folks work in .NET, array sort in .NET, or any of the link sorting methods, what they do is they look at it to see whether quicksort is going to get stuck, and if it is, they do a different sort. And if quicksort's fine, they do it. So this is what I mean about the nuts and bolts, is not only are these things built in, but often the built-in version will choose the right one for the exact scenario you're looking at. Quicksort looks like this. Now, what's really interesting, let's make them race. So what I've done, this is the same input on all of these. We're going to start them all at the same time. We're going to see which one goes fastest. You ready? Anyone want to place bets? All right, so we're ready. We're ready. Quicksort, Tim sort's done. Shell sort's done. Heap sort's done. Insertion sort's done. Bubble sort is in the corner eating paste. Come on, bubble sort, you can do it. And gets there in the end. Now, I said at the beginning I didn't want to have any code in this talk. I wanted it all to be just about the behavior of these algorithms. But there's one sorting algorithm that Rendell sent me a link to that was just so good I couldn't possibly not include it in the talk. And implemented in JavaScript in the console, that algorithm works like this. So we're going to create a constant list, which is just an array of numbers. And then what we're going to do is we're going to say for each item in that list, window.setTimeout. You know what that does, right? It says wait. Wait this many milliseconds, and then print it. Now, that 10,073, that's the value of the timeout that got set, because timeouts in JavaScript all have an address, which is integer. But then the rest of them is, look at that, it's sorted it in order. And the brilliant thing about that is that it's relative to the biggest number in your array. Also, if you put negative numbers in your array, you've just invented time travel using JavaScript. Well done, please don't do that. All right, so we've worked out a way of searching a dictionary. We've got binary search, and we've worked out ways of sorting data so that we can put them in the right order so that binary search is going to work. And this is awesome, because now we can invent the spell checker. And a spell checker is really important because this is a slide from my talk about algorithms. I'm going to present it at a conference next week. And Microsoft PowerPoint goes, oh, look, red underlining. That's not a word. I know that. I binary searched my dictionary, and it's not even a word. But of course, spell check isn't just about what did you get wrong. Spell check got a lot more useful when it's like, well, what did you mean? What might you have meant to say? Now, this is in the days before language models just went, yeah, whatever, and we'll write the rest of your talk for you. We're talking about doing, analytical deterministic spell check here. And the secret to how spell checkers work is something called the Levenshtein distance. It's created by a Soviet mathematician guy called Victor Levenshtein in 1965. Now, Wikipedia says the Levenshtein distance between two strings A, B is determined by lev A equals... No. Levenshtein distance says how many edits do you have to make to get from the word you said to the word you meant. Fundamentally, that's what it is. That's why it's called a Levenshtein distance. So if we take the word conference, and we're going to riff through our dictionary of all the words in the English language, and we're going to say, hey, what's the distance from that word to that word? So let's say we get as far as the word coffee. So to turn a C into a C, well, we don't need to do anything. The cost of that is 0. O to O, cost of that is 0. F to F, the cost of that is 0. The E, well, we need to turn that into an F, so that costs us 1. We've made 1 edit. The R, well, we don't need that. We can keep the E, we can lose the N, we can lose the C, and then we keep the final E. So this gives us a distance here. To get from conference to coffee, we need 1 edit and 3 deletions. So the distance from conference to coffee, according to Levenshtein's distance measurement, is 4. Maybe we went to say coherence, because that's almost the same, right? If we change the F to an H, that's a distance of 1, and we get a dictionary word come out the other end. So the distance from conference to coherence is 1. If we want to do conference, well, now we've got to insert a letter because we missed one, but the rest of them stay where they are. So the distance from conference to conference is also 1. And just to demonstrate how this works if you do it really, really badly, the distance between conference and marmalade. Well, we can keep the E, right? Because we've already got an E in the right place. Distance is 8. So fundamentally, the way that a spell checker works is it takes the word you've got that's not in the dictionary, and it goes through all the words that might be the word you meant, and it measures the Levenshtein distance between the word you typed and the word in the dictionary, and then it sorts the suggestions based on that distance. So when you right-click that word in PowerPoint, this is exactly what you get. All right. I think we've done pretty well. We've invented binary search. We've looked at different kinds of sorting. We've implemented bubble sort using a helmet and a flag. We've used all of that to build a spell checker. I think that is a tremendously accomplished day's work. It is probably time to go to the pub. Now, we're not just going to go to the pub. We need to make sure we're going to the pub in an optimum way. So we are going to go to the pub in Aylesford, which is a wonderful historic market town somewhere in that little bit of England where the really good pubs come from. And Aylesford is remarkable. One, it doesn't have any roads in or out. I'm guessing they get stuff in by river. And 2, it has a pub on every street corner. And we've got a map of Aylesford that tells us how long it takes in minutes to walk between all of the different pubs in town. Now, the problem we've got here is generally when we go out for the evening, we're going to start off in the Anchor, and at some point we're going to get a text message from somebody going, hey, come and have a beer. I'm in the, and we're like, okay, oh, they're in the Hatchet. How do we get from the Anchor to the Hatchet? What's the shortest way of getting there? So what we're going to do is we are going to implement Dijkstra's pub crawl algorithm. Works like this. Go to the Anchor, find the nearest pub that still has beer. We're going to call that P. Then we're going to have a beer at every adjoining pub. Now, an adjoining pub means you don't walk past any other pubs. You walk down the road till you get to a pub, you go in, you have a beer, you make a note of how far it was. If you found a shortcut, you update the little distances we got written down. And then we're going to go back to P and we're going to drink all their beer. And we're going to keep doing that until there's no beer left in town. Please drink responsibly. So let's do it. Now, this is our distance table. We're going to start off at the beginning of the algorithm. The Anchor is 0 minutes away, and we don't have to go via any other pub to get there. So, first of all, find the nearest pub that still has beer. Well, step 1, go to the Anchor, all right? Come on. Boom, there we go. What's the nearest pub that still has beer? The Anchor, yeah, we're already there. All right, so have a beer at every adjoining pub to see how far it is. So we're going to go to the Beehive, so that's P. Pop down to the Beehive, yeah, all right, cool. 15, now 15 is shorter than infinity. We found a shortcut, so write that down. We found a shortcut. The Beehive is 15 minutes away if we start from the Anchor. Go back to the Anchor, we'll go to the Crown. How far's the Crown? 8 minutes, all right. Go back to the Anchor, go to the Duke. How far's the Duke? 18 minutes. What do we do now? Go back to the Anchor, drink all their beer. Yep, bang, Anchor's off the list. All right, so repeat. Go to the Anchor, find the nearest pub that still has beer, which is going to be what? Now, these are the distances we know, because we've verified these ones by walking. The nearest pub's the Crown. So we're going to go to the Crown, and then what do we do? Well, there's no point going back to the Anchor, because we know they've run out of beer. So we're going to go to every adjoining pub, which in this case is the Duke. So, we're going to go to the Eagle first. There's this lovely little road through the park. So we're going to go to the Eagle. How far's that? Well, we can update that. That's 28 minutes if we go via the Crown. Go to the Duke. How far is the Duke? Well, 18 minutes there. Now, at this point, if we go via the Crown, it's 8 plus 7. It's only 15. Found a shortcut. It's quicker to get there if we stop and have a beer along the way. So, update our distance chart. Go back to the Crown. What do? Drink all their beer. Let's go back to the Anchor. Nearest pub that still has beer now? Well, we got 2. The Beehive, the Duke, they're both 15 minutes. Let's go to the Beehive. That's P. Can I have a beer at the Griffin? There we go. Update our distance chart. Can I have a beer at the Eagle? There we go. Update our distance chart. Now, only update the distance if we found a shortcut. We haven't. We've already found a shorter route to get there, so we don't update the Eagle here because the route we just found is longer than the one we'd found in the first place. Go back to the Beehive. Drink all their beer. Go back to the Anchor. What's the nearest pub that still has beer? The Duke. All right, cool. That's P. We've already been to the Crown. No beer there. No point going there. Let's go to the Fox. Have a beer. Back to the Duke. Drink all their beer. Go back to the Anchor. What are we going to do now? Find the nearest pub that still has beer, which is going to be the Fox. Go to the Eagle. Adjacent pub. Yep, that's done. Go to the Inkwell. Oh, I missed a step on my algorithm. No, I didn't. Yeah, we're fine. Go to the Fox, drink all their beer, back to the Anchor. What's the nearest pub that still has beer left? Eagle. That's P. Go to the Griffin, have a pint. Go to the Hatchet, have a pint. Go to the Inkwell, have a pint. Back to the Eagle, drink all their beer. Go to the Griffin, closest one that still has beer left. Go to the Hatchet, have a pint, update our distance chart. Back to the Anchor, go to the Inkwell, go to the Hatchet, have a beer, back to the Inkwell, drink all their beer, go back to the Anchor, and finally there's only one pub left in town that has any beer in it, so we're going to go there. There's no adjoining pubs to go and visit, so we're going to update our distance chart if we have to. We're going to update the Hatchet, and then we're going to go back to the Anchor. Now, at this point, we've drunk all the beer in town. We've reached the exit condition for our algorithm, but we have also now got an accurate distance table of how long it takes in minutes to walk from the anchor to every other pub in Aylesford, and we know which pubs we need to go to along the way. Now, this looks a little bit kind of counterintuitive. What we need to do, say we're at the anchor, and we get a message from someone going, hey, we're in the Hatchet. Come and have a drink. So we're like, all right, how do we get to the Hatchet? Now, one, we know that the Hatchet is 45 minutes away. Two, we know that to get to the Hatchet, we need to go via the Inkwell. So how do we get to the Inkwell? Well, we know that to get to the Inkwell, we have to go via the Eagle. How do we get to the Eagle? Well, we know that to get to the Eagle, we go via the Fox. How do we get to the Fox? Well, the Fox, we get there by going via the Duke. How do we get to the Duke? We get there going via the Crown. How do we get to the Crown? Well, we can get to the Crown straight from the anchor. Now, this is, and there it is, that's our 45-minute walking time. This is how SatNav works. This is Dijkstra's shortest path algorithm. It is used for all kinds of things. It's used in networking to calculate the shortest route or the shortest number of hops between two nodes in a computer network. It's used in navigation systems. It's used in games. It's used in advent of code to get your little elves to go from the one corner to the other corner in the shortest possible number of steps. And if we really wanted to go from the anchor to the Hatchet, Aylesford unfortunately does not exist, which is a shame because it looks like a lovely place. The anchor, some of you folks might know it, the anchor is in Stockholm. And it is an awesome rock and metal pub. And the Hatchet is in Bristol in the UK. And it is also an awesome rock and metal pub. And to get from the one to the other, we can apply Dijkstra's shortest path algorithm, which says, yeah, it's easy. It's only 24 hours of driving. But this is literally what happens. When you go onto Google or Apple Maps or OpenStreetMap and you're like, find me the route from here to here, it's not doing it in terms of pubs, it's just doing it in terms of the distance in kilometers between road intersections, and it's using that algorithm to build that up and calculate all the distances. Now, folks, I said at the beginning of this talk that algorithms are nuts and bolts. They are the bits of software engineering that hold everything together, and most of the time, you don't want to invent your own. You don't want to build your own. But there is a wonderful book. Any of you folks ever read this? Zen and the Art of Motorcycle Maintenance by Robert Pirsig. It's it's one of those books, I think you were issued with a copy of it in the 1960s. Like everyone I grew up with, their parents had a copy on the shelf, and eventually I picked one down and I read it. And it's about a guy and his son taking a road trip across the United States on motorcycles. And yes, it is about Zen, and it is about motorcycle maintenance. It does exactly what it says on the cover. But there is a passage in this book that resonated with me possibly more than anything else I've ever read. Because I've spent my whole life messing around with machines, radio-controlled cars and bits of computer equipment and mountain bikes and all these kinds of things. And when you're working on those kinds of things, you don't think about screws and nuts and bolts. Most of the time, you take them off, you do the thing, you put them back together. It's absolutely fine. Until something gets stuck. Because at that point, you're like, oh, this was going to be easy. I unscrew that, I put the thing in there, I change the grease, I put the screw back in, screw won't come out. And there's a passage in this book where Pirsig is talking about this idea of stuckness. And I love this bit. He says, normally screws are so cheap and small and simple, you think of them as unimportant. He's talking about trying to change a valve cap on a motorcycle and he can't get the engine cover off because one of the screws is broken. He says, but now you realize that this one individual particular screw is neither cheap nor small nor unimportant. Right now, this screw is worth exactly the selling price of the whole motorcycle because the motorcycle is valueless until you get the screw out. With this reevaluation of the screw comes a willingness to expand your knowledge of it. Now, I think about algorithms like that. Most of the time, they don't matter. Most of the time, they're screws. But just once in a while, you're like, this is weird. Like, whenever we try to insert this one row into our database, everything stops for like 28 seconds and then starts again. If you've ever come across these kinds of things in your career where something, it can't go wrong, it's just dot sort, it's just insert, it's just select where, these kinds of things, once in a while they're going to go wrong. And when they do, to me, that's the motorcycle screw getting stuck. Because you can either throw the whole thing off a bridge and give up and rage quit and start again, or you might like, hang on. Something I thought was really simple has found an edge case. It's time to reevaluate how important that is, to dig into it, to understand how the nuts and bolts actually work. And if you've done that in advance, then that's the day everyone else in the office is going to be like, oh, but sort's supposed to work. And you're like, hang on, let me show you a thing or two here. Folks, thank you very much for listening. Are there any questions? The silence of enlightenment. I love it. Eli? My favorite algorithm? My favorite algorithm is BT's algorithm for choosing wine, which is, so sometimes somebody will hand you a wine list in a restaurant, and they don't really care about wine. They want to see how you choose wine, to see if you're posh enough to be dining with them. So what you do is you order the South African white with the longest name, because the process of finding it makes you look like you know about wine. Because you flick through the whole list, and then you go, okay, so, and also the longest ones tend to be the blends, and most blended South African white wine is pretty good. It won't be the cheapest, it won't be the most expensive, it makes you look like you know what you're doing. Did you want a real answer, or will that do? No, I mean, there are cool algorithms out there for solving all sorts of things. Dijkstra's is the one that, for doing things, particularly Advent of Code, it's one of those ones. I try to do Advent of Code every year, and I normally give up around day 15 because it just takes too much time. But that's one of those ones, once you understand it, all you got to do is, right, how do I translate this problem into a set of data that I can run that algorithm across? And so the challenge isn't how do you solve the problem, it's just about how you manipulate the data. And so that's one that I particularly like. There is another one which didn't make the cut for the talk, which is called the Hungarian algorithm, which wasn't invented by Hungarians. It was named after Hungarians by an American. And that one's interesting because it's like if you got, like, somebody's got to feed the cat, somebody's got to wash the car, somebody's got to take the bins out, and you've got 5 people, and they'll all do one job each. And like one person, like, well, I charge $3 to feed the cat and $8 to take the bins out. How do you come up with the cheapest way of doing it? And I once had to implement, I mashed up the Levenstein and Hungarian algorithm to come up with a spell checker that worked on actors if you don't know their middle name, which was kind of fun, and that's a real thing I actually did. But the Hungarian algorithm doesn't fit in this talk because you can't do it without matrices or matrices. So, but yeah, there's a lot of fun ones out there. Right, any other questions, folks? I'm going to plug something. I just published my first course on DomeTrain, and you should all go and buy it because it's absolutely awesome, and it's about sending email in .NET. And apparently there's a birthday sale on DomeTrain, which they said was going to end at the end of May, but I think it's still going. So please, everybody, go and check that out. And thank you so much for coming, and enjoy the rest of the conference.
Welcome, everyone. Thank you for coming. My name is Jimmy Bogard, and today I will be sharing some of my experiences of introducing OpenTelemetry into existing systems that either had some kind of observability stuff going on, or maybe none at all, but definitely nothing in terms of anything OpenTelemetry. So we'll be covering a few things. First is just an overview of what observability is, what OpenTelemetry is, and finally we'll look at why you should care about OpenTelemetry if you have existing systems that are today not doing anything OpenTelemetry related. Now, OpenTelemetry is a standardization effort, and with any kind of standardization effort, you get like the classic XKCD situation, where you have n competing standards. And so someone says, right, we need to standardize the standards. And so now you have n+1 competing standards. When I first got started with OpenTelemetry back in 2019, 2020, it was definitely in this sort of arena where we didn't know if OpenTelemetry was going to, quote, like win out against other competing standards. But 5 or 6 or so years later, it's become evident that OpenTelemetry has basically won, and it's safe enough for us to use, definitely for new systems, but today's talk, I want to focus mainly on existing systems that don't have any of this stuff in place. So how did I first get introduced into OpenTelemetry? OpenTelemetry started out in 2019 or so, and this is also the same time frame that I was dealing with a client in which we were building out, you guessed it, microservices, and we were needing to have some kind of visibility into what was going on into the system. This system, as it existed back then, was microservices, and every single service had its own individual MongoDB database that it was storing all of its information into. So of course we started out simple. There was just like 1 or 2 services, but eventually grew to like, I don't know, I think at the end they had like 16 or so different microservices. Probably could have just gotten away with like 3, but you know, microservices, more is better, allegedly. So here we were. On top of all of these services, we had an Angular front end. So the Angular front end would call into APIs that the different services would expose. And for most things, this was good enough for the different screens to be able to get the information and perform actions on each of these services. But there were also occasions which services needed to coordinate with each other. And so for that, we used RabbitMQ to facilitate messaging and async communication between each of these different services. This is all hosted on a cloud platform, which I'd never heard of, and I hope I never see ever again, called Pivotal Cloud Foundry. Does anyone here how to deal with this thing? Oh, a few unlucky people out here. So yeah, I'd never seen this before, but it is it is supposed to be a cloud agnostic cloud, which is just like another cloud that you're coupled to, and this is where all of our services were then deployed to. Finally, of course, we had the end user that was using some browser, and that browser was really kind of coordinating all the operations between each of these different services. So they'd kind of start in the first step of the process, they click some buttons, and that would kind of shuttle them to the next service and the next step of the process, and on and on and on. Now, when I came on, we were building these services out, and I just sort of relied on this cloud provider thingy, Cloud Foundry, to give us the observability to be able to peer into what was going behind these services. But it turns out that really didn't have much to speak of in terms of observability at the time. So really what was happening was everything was then actually being funneled out to Splunk. And that was the only observability tool that this team had at the time. So for a lot of things, like in a single monolithic application, this is probably good enough. You just like output logs to Splunk and sort of call it a day. But when we started to get to more complex distributed systems where we're using both synchronous API communication and these asynchronous messages, this becomes a huge challenge for us to figure out what the heck is going inside of this. So when we deploy the system out into any environment, we no longer had any visibility into the individual services. We basically just had like the browser talks to like the stuff, and then the only thing we could really see out the other side was the stuff being pumped out via the logs into Splunk. So at that point in time, the team's like, okay, everything works great locally. It always does with microservices. But when we push it out into a deployed environment, we can't tell when something goes wrong. We don't know what went wrong, what service it was, or the specific sequence of operations that led to some sort of specific failure. And so the issue we had was in this system, there was a lack of observability. So observability is simply the ability to observe a system from the outside without knowing about the inside. So you don't have access to all the little things going on underneath the covers. You can only observe the system from the sort of outside interactions or signals that exist in that system as it is today. Now, in order for us to be able to get information from the inside and be able to see it in the outside, then the inside needs to emit information about what's going on. And this information is also known as telemetry. Telemetry will tell you, okay, this thing happened at this point in time, or it took this amount of time. This is the thing that called me. This is the thing that I called to other people. It gives us all that level of detail, but it needs to be able to be emitted from inside that system, inside that application via instrumentation. This Cloud Foundry thing had something known as auto instrumentation, which I wouldn't wish upon my worst enemies because it works great for the very simplest of scenarios. But anytime you try to get more information past what is just automatically stock out of that system, you're left wanting more. It's just not going to give you that extra information. So we realized that what we were given today was just sort of pure logs being pushed out to Splunk. And if the only thing you have is log information pushed out to Splunk, then you're actually spending most of your time spelunking, which I guess is why they call it Splunk. You're spending most of your time just trying to dig through logs, trying to figure out, okay, what actually went wrong here? And we'll do things like, okay, what specific time of day did you click that button, right? And so then you go to the logs and try to constrain yourself to a minute of time. Hopefully that minute of time, the time zones match up and the clocks match up to give you that set of information. But if your system is under any sort of regular use or heavy use, then even that sort of time frame window is nowhere near enough. So we realized that we were missing a lot of information here, and we needed to have our system emit more information, more telemetry than it was doing today to something. Maybe that's Splunk, maybe it's something else. So these telemetry signals, these are the sources of instrumentation data that we want to turn on in our system, or if they don't exist, then start to add them and include them. The telemetry signals, these are known as signals now. They used to be called the pillars of OpenTelemetry or pillars of observability, but that metaphor doesn't mean the same thing to everyone. So they're really just signals. They're data signals spitting out telemetry data to be listened to by some kind of UI or some system that can gather that data and then present it to you in a nice user interface. The first one typically we see in systems for telemetry signals is logs. Now logs is what most people have today, right? Most users today, most systems today have logs as a source of telemetry data. And this gives you some information, it gives you when this thing happened, when this specific telemetry log event happened. It gives you some data, some message about what the thing that happened, and maybe there's some metadata associated with that log entry, but usually not, right? Usually it's just timestamp message, and that's kind of all you get there. When we're looking at distributed systems, though, a straight log message is not enough to understand if I have some kind of causal relationship between different systems, that this system calls this system calls this system. I would love to be able to connect those different pieces together and see that these different kind of actions are all related to each other. Now, logs can kind of do that in some specific cases, but really what you would rather have is a telemetry signal that is more specific to that kind of use case, and this is known as a trace. Traces are differed in logs, and that traces also contain an identity, that you know that this specific distributed trace of all these different connected actions that have happened is different than some other thing that has happened, not by something like a timestamp, because those things could have happened at exactly the same time, but also there's some identity associated with this specific connected set of operations versus some other connected set of operations. Something that's also different in traces, which are a connected set of spans, they're known as. Spans also include a duration with a start and end date. So I know when the thing started, and I also know how long this specific operation took to perform whatever this thing is. There's a lot more that can happen inside of these spans, which I won't cover in detail, but this is now a thing that people are starting to attach more and more data to because it is this nice, like, identifiable thing with an ID. They can say, hey, this other thing is related to this thing with this specific ID. We also have metrics. Metrics, you can again kind of put together metrics based on the other two pieces of telemetry information, and some people try to do this. But honestly, it's a lot easier if you emit these metric signals as their own individual measurements, rather than trying to piece like the Humpty Dumpty picture together based on like, oh, I saw this log entry and this log entry, and I saw those this many times, so that means I had this many open connections to the database. It's a little bit easier just to capture that sort of signal like as a top-level concern. But there are also other signals. There's one called baggage, which I won't cover today, but it is a thing that exists. And I guess like vibes could be another signal, like how many vibes do your application give off? I don't know. But the three main ones, though, are logs, traces, metrics, and those are the big ones that I see on a kind of a project-by-project basis. Those are the ones that I use all the time. All right, so we're back over here, where I realized that just the logs being pumped out to Splunk were not enough. I couldn't piece together the history of this thing calling this thing calling this thing. And so what I like to do is have my brownfield legacy, or really just existing system, emit signals to the various different kinds of telemetry, I guess, consumers and visualizers. So of course for logs, we had Splunk, but we also introduced a couple new ones. One was traces to Zipkin at the time. There's a few others out there, like Jaeger's another popular open source one. Another one, like I've used App Insights or Azure Monitor, or what is that what it's called today? I don't know if like the AI folks have decided to name it something else at Microsoft. But those also have built-in capabilities for viewing distributed traces. And for metrics, this client was also using an APM tool, which, again, I feel like I've gotten in the wrong space because those tools are so insanely expensive. Like I really should have gotten to that sort of thing. But they were already using Datadog for their application performance monitoring. And so we said, hey, this thing can also do any other metrics we pump at it. So let's then use Datadog to do this. So this was, again, like 2019. I said, okay, we know we got a deficiency in the tooling, so let's add these other two tools. But the problem I quickly ran into is that for all the different kinds of sources of telemetry signals, they didn't have necessarily all the support for these third-party tools. So what I was looking for was like, okay, I have this sort of signal. What telemetry tool is that sort of signal source supported on? So something like HTTP client, right? Every time I call out to a third-party API or another API internally, I would want to make sure that it supported each of these different tools. But that also got multiplied by all the different potential sources of telemetry data. Like whenever I talk to a database, I want to get telemetry data out of that. If I just have logs randomly in my application, then I want to make sure that those make it out to these different sources as well. So what I quickly saw is that this is going to turn into this terrible matrix madness, where for each different kind of thing I was looking at measuring, each component of observability, I had to go then check to see, is this supported in my telemetry tool of choice? And what was inevitable was like some of them supported all of them. Actually, none of them supported all the signals. They would have like different varying levels of support overlapping in some specific areas, but usually what I saw was that there was going to be some pretty big lift on my part to try to fill in the gaps of the different sources of telemetry data and then plug it into the different telemetry UIs and providers here. Now, this is something that back in those days was such a huge pain because we would also see like SDKs of these different telemetry providers. They would like have a new version of something and that would break all the existing stuff that we had going on because they changed something with the API. So it was kind of a constant churn we would see when we were having to support all these different things. And I also saw that if I moved on to the next project that has some other telemetry provider, like this one used Zipkin, the next used Azure Monitor, I couldn't use any of the previous extension code. It had to be all thrown away and started from scratch of like, well, what is Azure Monitor's way of doing logs, traces, and metrics? And then we build a whole bunch of other custom plugins for those specific things. So the goal of OpenTelemetry is to try to standardize all of those sort of things. Now, this is ambitious. And so what we'll talk about in this talk as well is what are the different what are the things we can adopt from OpenTelemetry where we don't have to necessarily do like this entire matrix of everything OpenTelemetry, but still provide a win for our clients, our customer, your employer, whatever. So OpenTelemetry is an observability framework designed to facilitate the generation, exporting, and collection of telemetry data. It's open source, it's vendor and tool agnostic, and it's not meant to be a replacement for the backend itself. So it is not a collector of all the telemetry data and giving you a nice user interface. That will still be your Zipkin, your Jaeger, your Azure monitors of the world. What it's intending to do is to let you stop like directly targeting those SDKs of those specifically telemetry tools and instead use a more standards-based approach. So this is 2019, and this has only happened like 2 or 3 times in my career where I'm presented with a very complex problem that could have a very challenging implementation, only to do a Google search, because thankfully ChatGPT was not there to lie to me about what actually existed. And I saw this blog post from Microsoft that said, hey, we're going to improve troubleshooting and monitoring distributed apps by embracing OpenTelemetry. I thought, oh, thank God, because I did not want to have to develop all these sort of custom plugins myself that are going to be thrown away and have to maintain over the years, that instead Microsoft is committing to this. So when I talk about a brownfield war, this is really what I'm talking about, is a system that does not have any kind, it may have have some level of existing observability, almost certainly is not directly using OpenTelemetry, and probably has all sorts of customizations and stuff going on behind the scenes. What I also typically find is that there's usually a very low cardinality of telemetry. If I'm looking at just the Splunk example, usually what it is you have a timestamp, and hopefully you can kind of like get that timestamp window small enough to like catch your log entry between all the others. So it's very difficult to find your information amongst all the other set of data that's going on there. It's usually only logging, right? You've only got logs being pumped out somewhere, and then maybe Splunk is like, yeah, we can do traces too, but it's a lie. They're trying to like infer the tracing information from logs, and that's just a really difficult thing to do. The actual log output itself can often be in a hard to reach place. Is anyone here still like logging to files on a bespoke server somewhere that you have to log into the server to see those files? There's some like very hesitant hands, like, oh, I don't want to raise my hand. But I'd say that's definitely still the case as well. It's like you have to remote desktop SSH into the production server to go view the log files over there, because there's so much difficulty in changing that to anything else. But what is most often the case is there's tons of vendor-specific extensions that either you or someone else has developed and pushed out on a package somewhere that was updated maybe last like 3 years ago and does not support the current SDK. And you're probably often seeing a lot of like custom user abstractions over those telemetry APIs, right? Because you don't want to couple yourself directly to Splunk. So instead, you're going to have an abstraction over the logging to Splunk, and then you're actually using that abstraction instead. Or you don't want to couple yourself directly to Azure Monitor, or whatever it might is. You don't want to have that vendor-specific code littered throughout your application code. You have your own special individual abstraction over that telemetry data. But really what you're getting to is when something goes wrong, you're trying to find a needle in a stack of needles, and you're only going to get it hurt, right? You're going to put your finger in there and get poked 10 times. That's the wrong one, and you have to dig through it again. Now, we could continue down this path of, okay, I'm going to go Zipkin. I got to adopt its model, its SDK, and just extend that instead. But there are some specific reasons why I think you should be picking OpenTelemetry for brownfield. Obviously, the big one's like get off that old vendor jank into the new hotel, making that bank sort of thing. But a big one I saw was that everyone's doing it. What I mean by everyone is the tool vendors, the people, the Splunks of the world, the Zipkins of the world, the Azure monitors of the world, they are adopting OpenTelemetry. And a big reason why is because it's actually cheaper for them to do so, because they only have to implement an extension once, as opposed to, okay, this this random client has its own specific abstraction of telemetry data. So I needed to write a plugin for their telemetry generation SDK, for my collection SDK, and these vendors have to maintain this matrix. It's much easier for vendors to maintain just a single collector for OpenTelemetry versus, or exporter for OpenTelemetry, versus having to support everyone's kind of custom sort of thing behind the scenes. And it's not just Microsoft either. A lot of the standards we're looking at and OpenTelemetry itself, if you look at who the sort of backers of those are, it's all the big backers. It's the Googles of the world, it's the Microsofts of the world, of course, it's the Amazons of the world. They're all buying into this model. In 2019, 2020, back then, it was a risky bet. But at this point in time, the Microsoft, like all the SDKs that you're using today, almost certainly are directly targeting the OpenSDK APIs. But it can be a challenging decision if I have an existing system that has a bunch of customizations for a specific vendor tool, and I have to ask myself, I've got 8 extensions to this vendor tool. What's wrong with just adding one more extension to that vendor tool because I've already invested in those previous extensions I made? So I kind of look at this as a trade-off of I can just sort of continue to extend the vendor-specific SDKs and APIs, but at some point you're maintaining all this infrastructure code that someone has already solved for you in this other target of OpenTelemetry, and so you have to make the decision of, can I throw away all this code that I don't really want to maintain to begin with and adopt this? So it's a decision of either like sort of extending what you've already been doing or investing in the future that could potentially open up a lot more possibilities. But it also could be that we just don't have a choice for adopting OpenTelemetry, that we have a specific hole in that matrix, and what fits that hole is the existing OpenTelemetry extensions for that specific vendor. And so it's much easier for us to adopt that versus looking inside of what that code is doing and realizing, oh my gosh, I don't want to have to maintain this 2,000 or 3,000 lines of code that is so specific to this vendor. I don't want to have to maintain that. So it could be just an easy choice to say, let's just use what's already there. The final big one, though, I found is by embracing this OpenTelemetry standard, there's a lot more extensions to that standard than what almost certainly exists to the vendor-specific APIs that you would be having to use today. So what this would do is enable more choices for options and architectures of our observability solution that we would not even consider if we're still just doing more one-off extensions to the vendor's APIs. So what might this look like in terms of an existing solution with no integration with OpenTelemetry and to incrementally migrate that over to an OpenTelemetry full stack solution? So I break it down first between your application code that is generating the telemetry signals and exporting them with the observability server, the vendors that you're depending on. Because there are basically two things that I can control. I can control my application code and the dependencies that I'm dealing with. And then I also have then all the observability server APIs and UIs. And apologies that the O11Y is a numeronym for observability. It was the only way I could fit observability in that space there, but I freaking hate numeronyms. They're like the inside joke of a group of friends that no one understands. Like, Ollie? Who's Ollie? No, it's observability. So looking at these different, this client and server, we have the things that are application controls versus the things that are at the server side. On our application side, we have 2 components. We have generation of telemetry data. This generation of telemetry data could be in infrastructure code that you don't even see, like deep inside of ASP.NET Core, deep inside of ASP.NET Classic as well, deep inside of Entity Framework. Inside of these SDKs, the telemetry data is actually being generated. You just may not know that it exists. So that is still part of our user application code, though. We also have code that you write. You have your logging statements that you're writing out and your actions that you're performing. You may have custom traces, but that's much less frequent. Usually, what you have is custom log messages that you're spitting out. So we have our logs that are being generated by application code. These are being exported inside of our application to something. And that something is then some kind of plugin to the logging framework and to then the third-party telemetry server here. So if you're using like Log4net, Serolog, Nlog, whatever, then there's probably some plugin to that logging provider to the telemetry provider, hopefully. Same thing with traces, right? We have our generation of our tracing data, the exporting of the tracing data out to some kind of third-party server, which exposes an API to collect, store, and then visualize that information, and of course, metrics as well. So in order to migrate my application code, the things on the left, over to OpenTelemetry, I need to understand, well, what am I migrating to? Now, this part is the one part that is pretty specific to Microsoft and .NET. Because every single kind of language platform, Java, Node, Ruby, Python, whatever, they had an existing starting point of where they were with observability in that platform's framework. Some platforms didn't ever have any sort of standard of any of these telemetry signals. So in .NET, for example, what was the standard logger before ASP.NET Core came around? There wasn't one, right? Every system you built, you had to decide what is going to be my logging provider of choice. Is it going to be Nlog or Serolog, hopefully Serolog, or like if it's a really old janky application, Log4net, right? So there was no standard of the logging provider. So .NET's a little unique in that some of the pieces were already existing inside the framework that did some of these kinds of signals, but some were not. So I break it down in terms of looking at what is the right tool of choice to pick from here, based on first the different OpenTelemetry components at the top. And then on the left side, we have the different telemetry signals. The components being generation of telemetry signals, exporting to some other provider, and then finally collecting and visualizing over there on the right. And the signals then being logs, traces, and metrics. Now, OpenTelemetry does define a standard SDK API surface area that says if you want to be like OpenTelemetry targeting the OpenTelemetry standard for generation of this, here's the defined standard. And here's the methods, here's what the parameters should be, all that sort of stuff. So at Microsoft, though, this was ASP.NET Core 3.0. They had already introduced a standard logger, which is Microsoft Extensions Logging. This is the standard logger that you probably use today in your newer applications to generate logs. You say, I'm going to depend on an iLogger of T, and then I will log different levels, and that gets spit out through there. So what Microsoft has done is shape that API to help to better match the SDK standard of OpenTelemetry. It does not match exactly, but that's okay because, again, Microsoft said, rather than us throwing out our whole SDK and just straight up adopting OpenTelemetry, which then all this user application code would have to be rewritten to this new standard, instead we'll just kind of massage this library to be moving towards that standards approach. On the export side, this is when there's not really a standard here. There's just like extensions to say, I want to export this signal to this other thing. And so for logging, there's usually some NuGet package, right? We're like, I want to export my logs to this thing. And there's almost certainly some NuGet package that says, I know how to export the standard iLogger of T thing. These are known as what, logging providers? Yes. They know how to export those logs to something. By default, of course, you get like what, console? Console, yes, is like the one that kind of comes out of the box. But if you're going to export to something else, then you can find that package that will do that exporting for you. Tracing is a little bit different because the tracing API in .NET predates .NET Core altogether. So the tracing API was put in place to help show traces in Azure App Insights, which again predates .NET Core. So instead of having, again, a completely new SDK, what they said is, right, what we'll do is we'll again massage our existing API, which is in this package, the system.diagnostics.diagnostic source, and says instead of having to rewrite all this infrastructure code, instead we'll just move this API towards the OpenTelemetry standard. But one of the downsides is like none of the names match of this API. So you just kind of have to translate in your head. When they say span in .NET, it's called an activity. But it's the same concept, same idea. And basically from 3.0 on out, they were heavily focusing on targeting the API surface area, but without like renaming stuff, because that'd be such a pain. On the exporting side, this is where you see a shift, where the OpenTelemetry folks have a contrib repo that has now the exporting of this standard tracing data to then third-party telemetry servers. So you'll have some kind of exporter extension that knows how to translate from activities in .NET to whatever thing we have on the other side. So for whatever thing you have to go for, like if you want to go to Zipkin, there's an OpenTelemetry.exporters.zipkin package to export these traces to Zipkin. But it's still like, that's one like kind of minor annoyance here that, okay, well, I do have one vendor specific library, but it's not in your application code. You're not writing custom Zipkin span logic in your application code. It's all standard diagnostic source activities. Instead, there's something then takes those activities and pushes them out as whatever Zipkin needs on the other side. Now, metrics is one that actually does sort of directly target the OpenTelemetry standard because it did not exist when OpenTelemetry was first formed in 2019. So this package, the system diagnostics.metrics, already right, better name. System diagnostics.diagnostic source, I don't know what that means, but it's not a very user-friendly name. Metrics, though, was designed from the ground up to match the OpenTelemetry standard. And it just so happens that Microsoft folks are on the standards team, so if they don't like what they're seeing, they can tweak the standard, I guess. Similarly, though, to export that out, we have OpenTelemetry.exporter.something. You find what you want to export to, and that's what you're going to export. Finally, on the collection side, this one's a little bit different because the collectors are the APIs those telemetry servers expose to receive telemetry data. And so this is one that I find is like a little bit less of a win or value added to an OpenTelemetry solution, but there is a standard for the wire protocol of telemetry signals, and it's known as the OpenTelemetry Protocol, or OTLP. I will show an example of this, OTLP, but again, to me, that's a little bit less valuable than the code that I'm actually dealing with on a daily basis, which is more the things on the left here. Now, one of the other really great things about this is these libraries support, especially the generation libraries, support every supported version of .NET Framework and every currently supported version of .NET Core, whatever they're calling it, like .NET 6, .NET 7, .NET 8, 9. It supports every currently supported version except for the really, really old one, .NET 3.5. It's still supported for like, I don't know, another 3 or 4 years or something. But I don't know, if you're still in a .NET 3.5 application, you probably have other problems you're dealing with than just like observability. So this migration process in practice really would start at the biggest wins, which for me are typically the signals at the top. Like once I get logs now going from like some custom API to something else, now I can do a lot more interesting things with that. So it basically starts out with migrating the generation logic over to OpenTelemetry, and then migrating the exporting logic over to OpenTelemetry, and then doing the same with traces, migrating the generation logic, which is probably a lot less in your application, and then migrating the tracing exporting, and then finally the metrics as well. So I kind of see this as a sort of a progression where I started with sort of the easy wins with logs and start moving up to the less frequent but still valuable telemetry data here. So let's break this down then to each telemetry signal, and then I'll show an example of what it actually looks like to migrate old jank to the new bank based on these different signals. So first is logging. Now logging you probably have in your application today. Otherwise, I don't know why you'd be here if you have zero telemetry data, but maybe that's the case. It's doubtful that you have no telemetry data whatsoever. You probably have some kind of logging going on there. But almost certainly you're using some sort of third-party library to do so, and a log4net, an nlog, a serial log, some third-party library. You may have a custom abstraction who is using one of these third-party tools and has a custom abstraction on top of it. Your own internal logger class thingy that you're using to, just in case we ever change our logger, we have this custom abstraction. Maybe you're using Microsoft Extensions logging, but I tend to find that that's not the case for existing legacy systems. It's usually there's some third-party library and some bespoke custom abstraction. The exporting, it's usually an extension to that third-party library and is going to be some sort of custom abstraction because it's so specific to the logging generation library and the logging the target you're trying to push the logs to. That is that kind of intersection of the matrix that says, do I have Splunk exporting for log4net? Hopefully. If I don't, then I have to build that myself. On the collection side, I do see this occasionally in some places through things like log aggregators. So that's, what is it called? Cloud Foundry tool has a log aggregator. Your system actually can't export logs itself. You're supposed to spit everything out to console out, and then they take your console out, pump it through a log aggregator out, and then to something else. So you may have something there, but usually it's not. You're not going through a separate aggregator in the middle. Usually you're exporting directly from your client application straight out to the logging sink, whatever that is. All right, let's look at an example here. And I wanted to show a .NET 4.8 example, so I have to go to my Windows VM running on a Mac ARM laptop. So everybody cross your fingers. We'll see how this works. Okay, so yes, this is a .NET 4.7.2, sure, why not? Console application, which just does something very stupid, right? It creates a service object, tells that service object to do awesome things, which is just to say everything is awesome. That's all it's doing here. And so when I go ahead and run this, it is spitting out log messages, but how is it doing that? Let's go take a peek at this logger class, and we can see that it is using log4net. Yes. So in this application in which we're using log4net, it is doing our class is doing generation, but we're pushing out to this custom abstraction, this logger abstraction class. So we have our own methods of like log.info, and all that does is just call log.info. Like, wow, such value here that all we do is just call log.info. And so yeah, it just turning around and calling out into log4net. Log4net, I had to Google this and find like a 10-year-old Stack Overflow post about how to actually initialize log4net because I totally forgot how to do this. So it's doing XML configuration that has appenders, and so, oh, there's our console appender that is then how it spits onto the screen. So log4net has its own set of abstractions to do so. Okay, now to get this over onto Microsoft Extensions logging, one thing I have to be careful of is I don't want to replace everything all at once. So I could look at this and say, okay, well, let's just delete log4net altogether. But this config file is probably where a lot of your intelligence is like the configuration of your logging, third-party logging provider. So whether you're using log4net, nlog, or serial log, whatever, you probably have a lot of setup code in here about exactly what the format needs to be. And I don't necessarily want to throw all of that away just to get over to OpenTelemetry for generating log messages. So what I do is I search, is there a shim for this logging provider to Microsoft Extensions logging? And it turns out that there is. There's a shim called, where are you? Microsoft.extensions.logging.log4net. .ASP.NET Core, even though there's no dependency on ASP.NET Core. I don't know why the name of ASP.NET Core is out there at all, but it is a shim between log4net and Microsoft Extensions logging in the generation of log messages. So what that means is that I can still use log4net for the exporting of my log messages out to whatever, but now I can start to migrate my internal application to using the traditional or the Microsoft Extensions logging SDK instead. All right, so I'm not going to remember how to do this. I'm just going to uncomment code and explain it as we go. So first step is initializing this, this shim between the Microsoft Extensions logging framework and log4net. So that happens here. I create this logger factory. This is Microsoft Extensions logging definition of loggers. And then I had the shim here that says add log4net, and I pass it the name of the config file, which is what you see over here as well. And then finally, I can then from there create an ilogger of t. So that's what I'm doing here is creating an ilogger of logger, yo dog, where I've got a logger here. And now instead of using log4net's generation of log messages, instead what I'll use is this ilogger of t. So right here. Now, what is really helpful here is that if you're depending on other components that are also using Microsoft Extensions logging, now those logs will be showing up into this common exporting logic of log4net. So you got now that one pinch point that either it can come from log4net or it can come from Microsoft Extensions logging, the generation of those log messages. But now, I mean, the name's a little different because I give it logger.logger, but whatever. The same log message can be now either generated from this log4net logging generation, or it could be pumped out via the ilogger of t. Both of these work from here on out. Now from here, what I'd probably do is then move towards getting rid of log4net altogether, like migrating to loggerfactory.add. Oh, I don't have add console logging, add Splunk logging. I'm more likely to find the exporter there than I am for log4net. Okay, so logging, we can incrementally migrate over from the whatever custom stuff you have going on, even looking at, if you're still using this static API, I can first migrate over to using Microsoft Extensions logging, and then over time, remove the usage of that custom wrapper class altogether to directly use ilogger of t, because then everything's set up there ready to go. Tracing's a different story though. You probably don't have any code in your system, in your user code, that is generating custom traces. It's almost certainly happening though underneath the covers in your infrastructure code. So ASP.NET, back to like ASP.NET 3.5, I think, like 15 years ago, has tracing generation inside of it. You just may not have known because it is only ever lighting up if you deploy to Azure and enabled App Insights. Then there's some like line of code somewhere deep inside ASP.NET that's like, if I see this environment variable called App Insights connection string, then I will then export the telemetry automatically to Azure App Insights. So that's all there, just kind of waiting for us to tap into it. So our current state is a little bit different here, that there's probably no user code. Maybe there are some custom extensions that you've written on top of App Insights or whatever tracing provider you're using. Almost certainly the dependencies that you're using have tracing inside of it, targeting the diagnostic source API, the activity API. But it might be using some alternate custom standard for propagating the distributed tracing information. Because I'm now in distributed land with traces, service A calls service B calls service C, I need to connect those dots together, put Humpty Dumpty back together again. And so there will be some kind of extra metadata information I need to take advantage of to connect these different actions and operations separated both in distance and time. On the exporting and the collecting side, these are going to be extensions specific to your dependency server. So there's somewhere that's like, here's my app insights SDK.initialize. Here's my telemetry GUID or whatever they have today. So it's something in there that says, here's how to export out to those third parties. Now on the distributed tracing side, what I was mentioning around the alternate custom standards is really around the tracing headers we're using to connect these different systems together. One common one out there is known as B3 propagation. This came from Zipkin. So Zipkin, when I have some server calling another server, as part of that call, it will append additional headers in the HTTP calls so that the receiver of that receives the incoming headers, and when it pumps out telemetry data, it says, hey, I am now process 2, and I'm related to process ID 1. So I have this sort of linked list or directed acyclical graph of these different services using these headers to have IDs to be able to have pointers basically to point to all these different operations that are happening. Well, that's just one standard, okay? As part of this effort for OpenTelemetry, the team at Microsoft and others said, okay, we need a standard that's yet another standard to standardize the header information to connect these distributed traces together. And this is actually now W3C accepted, final, good to go, status, known as the trace context standard. I did put the full trace context header because it's like really long and would just like stretch across the screen. But it's now the accepted W3C standard to be able to connect these different things together. But that's not certainly the only one. Anytime I have systems calling other systems or systems initiating something in different systems, there's probably a need for observability, and someone's come up with their own sort of header standard as part of this. In an example, I will show you a different standard for messaging that's out there as well. All right, so let's look at an example for tracing. I'm going to switch off of .NET 4.7.1, and now I'm going to be looking at, this is now a .NET new applications, .NET. Thank you. Got it, on it. There we go. So this is a more complex example of a complex distributed system where I have an initial API application that then leverages messaging via RabbitMQ to initiate other actions and operations. And those other actions and operations are also doing other stuff like calling MongoDB or calling SQL, calling something. So right now, the other thing this application is using is Aspire. Now, the reason I chose Aspire is because Aspire is an exemplar of an OpenTelemetry collector. This is, Aspire has API endpoints that know how to speak the OpenTelemetry protocol to be able to collect, organize, and visualize logs, traces, and metrics in one like the best observability UI you'll probably ever see. But don't put it into production, please. It's not production ready. Okay, so let's run this and see what we see. Okay, so here's our application. It's just an API with two stupid API endpoints, say something and say something else. But what these do is these kick off messaging interactions behind the scenes. But right now, if I run this, this is my Aspire dashboard that shows all the different services and resources for this application. So I have RabbitMQ. Let me bump up the fonts. There we go. And full screen, why not? So I've got RabbitMQ here. I've got MongoDB. I've got Jaeger that does distributed tracing. I've got Zipkin that does distributed tracing, because why not? And then I've got my actual applications here at the bottom, the child web and worker. But if I go look at logs and traces, oh, there is something there. Forgot to turn that one off. And metrics, there's really nothing going on here. So right now I don't have, like, it's not, there's user code that is generating telemetry data, but it's not hooked up to any kind of exporter or collector here. So let's do that. So one of the first things I will mention here is that Aspire is not just for, like, what is their tagline? Like, build cloud-ready applications, blah, 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 blah. It's also really good at, if you have distributed systems, to be able to orchestrate them together and provide a really awesome local development experience here. One of the things that Aspire provides is this service defaults. And service defaults are out of the box, like, provide like sort of resiliency and observability defaults that you want to put into every application. but you don't have to even use Aspire to do that. I have a blank solution here. If I just say right-click, add new project, and I say I want to add an Aspire service defaults package or project, this also gives me a great understanding of like, what is the right way to register OpenTelemetry in my application? So very often I'll just like download the newest template of this thing, create a service defaults, and just look at the code and be like, what's the right way to do this right now? And this tells me how to do so, because inside of here, it's got extensions that are like services.add service defaults. It's got, oh, configure OpenTelemetry. How do I do that? Oh, you got to do this thing for logging. You got to do this thing for metrics. Oh, look, there's instrumentation for specific metrics. And then finally, there's tracing that has, okay, I've got the source and whatever. And then finally, you have exporters down here. They've got an OTLP exporter, which is what the Aspire dashboard speaks. It's an OTLP collector, the standard API format, which also means you can use the Aspire dashboard for anything that generates, they can export OTLP format. So if you have a Node app, they can export OTLP. You can use Aspire dashboard for that as well. Okay, or I can have other ones, like here's Azure Monitor for exporting out to Azure Monitor. This line of code here is probably the most expensive line of code you'll see in this demo, because now I have to turn on Azure Monitor. Okay. Okay, so first thing I'm going to do is in my service defaults, I'm going to uncomment some things to start to light things up. And child worker, whatever. Okay, service defaults over here. So we saw that there was something in here to add logging. So I'm going to do that first here. Add logging. Yep. So let's just turn this on and see what happens. I'm going to run this again. It's going to launch my Chrome thingy and Swagger. And let's see if anything shows up in our structure. Oh, okay, so I'm starting to see stuff here. Things are starting to show up in my structured logs, because over in my extensions here where I have add logging, I've also included as part of the exporters, it knows that if there's a OTLP endpoints environment variable, basically, then it will add the exporters for logging, for metrics, and for traces. That's this bit of code right here. So by now adding the logging generators, the exporters now light up, and those get pushed out immediately. But if I go to execute something here, let's go try it out. Hello, NDC, execute. We'll see logs show up. Oh, here we go, more logs show up. But on the traces side, it's still lacking. There's, I guess Mongo is showing up for whatever reason, but we don't see that full trace of that API operation there. So we now need to turn that part on as well. Now, tracing is an opt-in collection. So there are things that are generating spans, but that can be expensive to kind of keep track of. So you have to opt in to listen to these different tracing sources. So that's what we see right here. I'm going to uncomment this here. Yep. And the important bits here, as I say, services that add OpenTelemetry with tracing. And now I'm adding all the instrumentation. And these are just listeners. They're listening for those activity sources with well-known names. And when I have those sources listened to, that's going to then export those spans out into our UI. I'm going to uncomment one just to, okay, actually we'll leave it there. So this says add ASP.NET Core instrumentation. That's the server part. Add gRPC client instrumentation. We don't have gRPC, so we could probably safely comment that out. HTTP client. We do have API calls between these different systems. We are using EF Core. We're doing messaging via in service bus, so that's this source here. And notice this is picking up all of the activities as part of that. You can name specific sources If your third-party telemetry source has like multiple different things that it's publishing out, you can say, I'm only interested in this specific event versus those other specific events. That can be done here as well. And I'm doing Mongo, so this is the Mongo source as well. The packages that publishes out will tell you what to put in these strings here. Sometimes they actually do have them as a published like property or constant you can reference, or it's just a name that never changes. It's whatever. All right, so now let's see what happens here. Starting up again, and we'll try it out, add some other message here, execute, and what do our traces see show now? Well, this one kind of has some stuff, but if I look at the console logs, there's much more stuff going on. I could see like way more things that are getting executed than what's showing up in my traces. So something's still missing here. So this is the case where sometimes the source of the telemetry data needs to be turned on. In ASP.NET Core, starting with ASP.NET Core 5, the OpenTelemetry generation is turned on by default. You don't have to do anything to turn that on. But that's not always the case. Sometimes you have to go explicitly turn it on. And in Service Bus is one of those things where I have to go in here and say, hey, you have to turn on OpenTelemetry. And this is very specific to in Service Bus. But the MongoDB extension has that as well. What did I hosted service? We don't need that. Similarly, in the web application, there was a, where did you go? There we go. Enable OpenTelemetry. And finally, in the worker service, we have enable OpenTelemetry. Okay, now, when we execute this operation, now we'll see a much richer trace that shows a ton of things going on with this one operation. I intentionally made this like crazy, lot of stuff going on here, just to show like a very deep distributed trace. But just by sort of lighting the activities on and then enabling it for these specific components, without any sort of user code that's targeting Zipkin in this case. Actually, let's open up Zipkin here. If I open up Zipkin, oh, nothing in Zipkin. So if I want to now export these out to different things or have different things based on different situations or different environments, this is now the last part of the demo that I'll show here. So let's go back to the presentation. There we go. The last part I want to show is the collector. Now, I didn't show metrics because it's just like another thing on there. You just like enable metrics, export the metrics, and now they show up. Huzzah. The last one I want to show is collectors. So in this picture where I've migrated to OpenTelemetry, if I want to target these specific providers over here on the left, like Splunk, Zipkin, or Datadog, I have to extend my exporting logic to make sure I can export from OpenTelemetry to that third-party provider. But there's also this component known as the OpenTelemetry collector. The OpenTelemetry collector is a centralized collector of telemetry data that instead of your application code directly talking to those different telemetry servers, I instead funnel all those through a centralized collector. So what this allows us to do is to remove any dependencies from application code to observability tools. So I won't have to reference Zipkin in that service defaults or in any of my user code application code. It also lets us centralize all the policies for sampling, filtering, and redacting. And also lets us offload processing from our applications. So instead of my applications now directly talking to Splunk, Zipkin, and Datadog, or whatever telemetry servers you have out there, instead I have an OpenTelemetry collector application in the middle that all of these communicate via OTLP to the collector that will receive, process, and exports, then out to these different providers. And I'll show you just a quick example of what that looks like here. Come on, Parallels, you can do it. Oh no, not Parallels. This is going to be here in our Aspire application. In our app host, I'm going to enable the OpenTelemetry collector with forwarding. And so this is an extra container that's running that will collect the information, but also forward that, also take over. Right now, all the OpenTelemetry data goes to the Aspire dashboard. I'm going to put this collector between the Aspire dashboard and my application. And finally, configure it to this. All this isn't that important, except for saying that I'm going to have an exporter for Zipkin with this endpoint. And then when I pump out traces, I'm going to pump out to Aspire and Zipkin and Jaeger. So with this in place, now in my Aspire dashboard, I can look at traces here. Traces show up. I can go execute the UI, executes. There it shows up here. Here's that lovely trace. But now I can go over to Zipkin. And now that exact same trace shows up here as well, without me having to add any reference in any of my applications to Zipkin whatsoever. It is strictly now through this collector that is able to then accept this information through the OTLP API. All right, so let's wrap this up. So one of the things I like about this kind of architectural approach is it gives me what I like to call exit ramps. So I don't have to finish the entire migration of the entire process for me to get any value. Instead, I could look this as a component by component and signal by signal process where I can get an exit ramp that says, okay, if I just make it this far, I've actually improved my situation. So I can just migrate my generation logic from custom whatever code over to OpenTelemetry, and I'm in a better spot than I was before. Or I can then go, now let's go to exporting. Let's migrate the exporting logic off of like custom log4net or serial log configuration over to like the stock sort of thing there. Or finally, the collector, I can say, okay, now that we've done the first two, I have another exit ramp that'll still provide me value. I can get off of any of these stops and still have added value to my observability solution. So thank you all very much. If you want to see this full working code in practice, my GitHub repository, there's a presentations repository on my GitHub right there. So all this code and the slides will be on there, like a fully working example. Otherwise, I'll be hanging out afterwards for any questions. But otherwise, I hope you'll have a great rest of the conference. Thank you so much.
Hello, everybody. Thank you for joining us today. Really happy to be back here. This is my second time speaking at NDC Oslo. Been here previously also speaking at NDC Security for a different topic. But I always love visiting Norway. Me and my wife actually went into Bergen and took the train and fjord cruise into Oslo, just seeing how beautiful everything is. This talk I really like to give. It's really covers a wide range of topics from my work as well as from helping customers. But it's also just an excuse to get out of the States for a little while, visit this wonderful country and not think about home for a little while. No reason at all. But let's go ahead and talk today about resilient by design, Azure resiliency. My name is Chris Ayers. I was a customer engineer helping customers build reliable applications on Azure. I did resiliency reviews for Fortune 50 and 100 customers. I helped with like healthcare platforms and media platforms and retailers, and so like I looked at the patterns and the things that they didn't consider or they did consider or maybe missed. And that team got disbanded, so I'm no longer helping customers directly. They actually moved me into Azure reliability. So now I'm actually part of Azure engineering, analyzing Azure services, trying to find ways to reduce our outages and incidents to make systems better that provide services to everybody that builds on Azure. You can find me on all the socials except the bottom one and my website. Now, if you want to get these slides, they're on the web. So if you just go out to my GitHub, pretty much all my talks are out here. And this one's actually the first one. And pretty much everything just lives in my slides folder as Markdown, and they're all hosted on GitHub pages. So you can go and review and consume these at your leisure whenever you would like, out at Code Bytes. So we're going to talk about reliability. We're going to define some terms, why it matters, go over some fundamentals. There's a lot of concepts that when you just say, I want uptime and reliability, maybe you don't consider them. We're going to talk about design principles for reliability and some trade-offs, and we'll do some failure mode analysis and talk about SPOFs, single points of failure. And we'll go over Azure regions and load testing, all sorts of fun stuff. So let's get into reliability. Reliability really matters, and I'm not going to fully drain this slide, but you need to be reliable so that you can deliver services and response times. So that might mean you want consistent performance of a certain level. That might mean that you gracefully degrade. That might mean that you can come back rapidly. For a lot of times when I'm talking to retailers, like in the United States, Black Friday is a big thing where there's a huge spike in traffic. And so most of the year, they might have a ton of systems that are going, recommending things, doing marketing, doing like trying to sell you something else. But when you're getting a ton of traffic, you probably don't need those. And maybe those type of systems turn off so that you can keep delivering traffic. So we just need to really understand that failures are going to happen. It's inevitable in large distributed systems. And you need your workloads to be able to detect and withstand these type of issues, maybe a spike in traffic or a DDoS. You need to be able to recover from them. And if a system goes down, you don't want it to be down for weeks or months. You need it to come back in minutes, if not hours. So that is what we talk about when we talk about reliability. And so anytime there's a gap, there's a failure, there's an outage, it's not only a monetary impact, it's a reputation impact, it's a trust problem. And this is something we deal with a lot. You know, how can you continue to use services that go down constantly? You wouldn't. Failure is always an option. And so the thing that we need to talk about today is how you mitigate that or architect around it in the infrastructure and in the software. Now, like I said, it might just be revenue loss. If you're a retailer and your site's down, you're not selling. That's a direct impact. Maybe it's increased expenses. So if something's down and you have to send workers into a data center to do stuff, there's extra cost. If you have somebody on call that has to go do things, restore services, restore backups, do overtime, those are extra costs that people don't always think about. If you have SLAs, you have legal obligations to provide services to customers, and you're not providing that service, refunds. That's another cost. You might get sued. Maybe your insurance rates go up if you're affecting something and it's not there. And then there's costs, just costs of doing stuff, costs of data recovery, cost of restoring, cost of extra compute, cost of shipping network traffic. So there's a lot of financial impact to an outage and downtime. There was a study by New Relic in their observability forecast that the median annual downtime for high impact outages is 77 hours. Like 2 to 3 days. 146 million annual cost of outages, average annual cost of outage. And 30% of engineering time is spent addressing these. So it is impactful. In a 40-hour week, that's 12 hours a week that you're spending time dealing with outages potentially. So I was told there would be reliability, and there is. Like a lot of times, we deal with 5 nines. Who wants to provide 5 nines of service to their customers? Yeah, it's expensive. You're going to be down 26 seconds this month? 26 seconds. So a lot of times you'll hear about 3 nines. That's 40 minutes of monthly downtime, 8 hours a year. It gets exponential. Now you can come out here and play with this. This is a great little website, Uptime is. You can play around with, 4 nines gives you, let's see here, 8 seconds a day, I think it was. 8.6 seconds a day with 4 nines. And you can do reverse. Let's say you have an outage or an incident or something happens. So you could come out here and say, hey, we were down for 2 hours. So our daily is only 99.1. Our yearly has now dropped to 3 nines, 99.7, or 99.97. So when we think about 3 nines, 4 nines, 5 nines, getting to that is difficult. It's hard. I think I closed the slide tab, so we'll just do this. And I'll just go back to it, whatever. No big deal. So one simply does not achieve 100% uptime. We just don't. So how do we measure this uptime? Well, there's 3 levels that we build on. SLIs are service level indicators. What are the things we're measuring? Are we measuring error rate, calls, success calls, error calls, throughput? Like, what is the thing that you're measuring? Like, that's your SLI. That is the things that you should have monitoring and metrics for. Next, we have SLO. These are targets. This is an SLI over time. So, what's our uptime per month? Our error rate every hour, something like that. And then SLAs are the things where lawyers get involved, where now you have contracts, and maybe you owe refunds. So these are different levels, and these are things we play with. And so we're going to have a lot of SLIs, we're going to have fewer SLOs, and hopefully you have less SLAs as you think about this process. The other thing that we measure a lot of time is RPO and RTO. And these are very common, recovery time objectives and recovery point objectives. And you can easily see like, hey, we had a disaster of some kind. So our recovery point objective is how much data can we lose? Can it be 15 minutes? Can it be an hour? How much data can we lose? And then how long does it take to get back? How much time can we afford to be down? So we got a couple ideas on how to measure. Let's start looking at how we implement it in Azure. So there's actually some really good guidance. But like with every cloud provider, and this doesn't just apply to Azure, this applies to If you're in a colo or a data center or some other cloud, there's probably some sort of shared responsibility. You're going to have some things that are given to you that the provider will manage, and then there's going to be some things that are yours. And depending upon what you use, that might have a different level of responsibility. For like the data center, you probably don't have a lot of control in that unless you have a colo or you have your own data center, if you're using a public cloud like Azure. You get to a point where none of the physical stuff you have access to or that is your responsibility. What is your responsibility is when you start looking at IaaS and PaaS. So when we're doing VMs and we're doing infrastructure as code and we're doing infrastructure as a service, we're dealing with stuff that is more lower level. I need some storage, I need a virtual machine, I need a network. And so you have a lot more control and responsibility for maintaining those things. If you want multiple VMs to be highly available, you're probably going to have to spin up multiple VMs, and you control the application and the OS and all sorts of stuff. As you start shifting to PaaS, the platform as a service model, maybe you're running Kubernetes or an app service or something in the cloud, you really just care about your application and your data and your accounts. So, there's areas where you can play more with reliability, and there's areas where you just accept it from the provider. And it's your choice on where you want to be in that spectrum. Now, Microsoft put out the Azure Well-Architected Framework. There's other well-architected frameworks, but this is their guidance on how we build high-quality applications. And there's a number of pillars that we're going to go through the reliability pillar some. There's trade-offs, there's design decisions and recommendations. And this is, affects all the different people in your org. So there's 5 pillars: cost, operational excellence, security, reliability, and performance. And reliability, of course, is about resiliency, availability, and recovery. These are 3 different things. Like, can we withstand load and traffic? Are we going to be available? And can we get back? Security is about not only data, it's about identity, and it's also about mitigating risks, maybe from our supply chain, if we have vulnerable packages. Cost is always a big one. I want to keep my costs down. I want to have a budget. Operational excellence is those patterns and practices that we want to exhibit all the time. Observability, monitoring, safe deployment, zero downtime deployment, potentially. So these are things that you get out of operational excellence. And then performance. Is it scalable? Can you do load testing? Is it meeting the performance metrics that you're looking for? Completes operations in a certain amount of time, things like that. And so there's some design principles that I think really resonate when you think about resiliency if you haven't gone through these exercises before. The first one is, what are your business requirements? So we talked about those 5 nines are really hard to get to. And I know if you talk to an engineer, that's a non-functional requirement for a lot of us in some cases. Like, what exactly is the performance metrics we're shooting for? PMs and managers are going to see, we want uptime all the time. We just want to always be up. It's like, okay, what is our business requirement for our customers? Do we have customers that are only going to use our application 8 to 5? They're all local. Do we need a full global deployment with 24/7 uptime and multiple redundancy? Does that make sense for our requirements for our customers in our town that we're serving? And that's it. Maybe not. So what are your business requirements? Like, what is the actual use case of your workload? Like, the requirements for a mom and pop shop are not the same as the requirements for Walmart or Tesco. They have different needs. Do you have, like I said, traffic patterns that like they sign on at 8 and they sign off at 5, and so you have defined traffic patterns that you're going to identify in use cases? Does it shift to a global thing? Maybe you can change your access patterns across the globe. Do you need the same level of resiliency? Is it for a government and there might be a regulatory or a compliance need? What are those requirements that you have to target? So set success. And the requirements might be different for different components in your system. Every piece of your system might not have the same uptime or requirement. Like your logging and your authentication system might be very different than like a marketing system. They might have different requirements. So understand each one, understand the compliance needs of each component, check out your dependencies. We are going to talk a little bit about composite SLAs because that's a fun one. You know, if you're building a reliable system, it is built upon all of the components you're using. You know, we've got to think about resilience. So how do we fail gracefully? Like, how can we architect our system to continue to operate even though we have a failure? Can we circuit break part of our system? Can we understand scaling limitations and maybe put rate limiting and throttling in place if we're getting a load of traffic? So how do we, degrade gracefully? What are our critical and non-critical components? What are some places we can fail? And we'll talk about failure mode analysis in a little bit here. So there's a lot of different things that you need to think about rather than just, I want to be up. We talked a little bit about RPO and RTO, but this is definitely part of recovery. So assume a failure happens. Assume something goes down. How do you get back? Are you using persistent messaging? Are you doing, backups and offsites and multiple regions for data? Like, how do you deal with those type of issues? Maybe you don't need to, but maybe you do. What about operations? Do you have an observability platform in place? So Jimmy was just up here. He was discussing adding OpenTelemetry to brownfield applications. What is your monitoring and observability solution right now? Are you having a central place where you can start detecting failures? Do you test and validate that? Like, are you doing regular load testing or performance testing or chaos testing? Do you have metrics on that? The biggest thing is keep it simple. Like, it's very easy to over-engineer. So if you're an engineer on one team and you're like, we know our load, but we should probably have 2 or 3 instances or bump it up 20% to assume for traffic and growth. And then the PM or the next layer up goes, hey, we should have 20 or 30% more just to make sure we account for growth. And if you keep doing this layer by layer, you start having a way over scaled system. So keep it simple, but then do testing and validation and plan for that. If you over-engineer extra layers and things in place early, then you have this extra complication where you're coordinating lots of pieces, and that becomes a very, very big problem. So let's get into some specific trade-offs, and we'll get down into some implementations. So there's a lot of trade-offs between resiliency and cost, security or performance. And so this is where you really need to understand what the goal is. What is the thing you're trying to do for your customer? What is the thing that's most important? Like, if it's a healthcare application, resiliency might be more important than anything else because maybe their heart monitor goes out. And if you're not monitoring that and the platform is down, someone could die. If it's pizza delivery and then your pizza order doesn't go through, that might be a different level of resiliency. So understand the trade-offs. This is the one I always get. Every single time I bring up resiliency with a customer, if they've never had an outage, they go, that might be too expensive. Can we turn it down? But if they have had an outage, if they've been impacted, if something has gone down and they've lost revenue and they've lost trust from their customers, this doesn't matter anymore. They don't care about the cost because they understand the pain of losing customers, losing reputation, and having an outage. But sweet summer children. When they don't have an outage, this is always the look. It's always like, but cost. My manager won't approve it. You sure we need 3 instances? Maybe we can get away with 1 or 2. So, cost. So, if we want to prioritize reliability, we need probably multiple regions. If you have an application and it's all in East US, maybe you need one in West. So you now have twice the hardware or twice the scale that you have in order to support some sort of redundancy. Something can go down, the other stuff can still be running. That's double your costs. Boom. How important is uptime to you? Maybe you don't want to monitor everything. Logging is expensive. Logging is hard. We'll just sample every 5-10 minutes. What's the worst that can happen? Keep the cost down, right? Well, then observability, we probably want something really, really robust and thorough. We also probably want to have additional traffic to handle spikes. But it's hard to justify unused capacity when you're focused on cost optimization. That's where auto-scaling comes in, but then you might have to understand auto-scaling has a lag time. There's like sliding windows and algorithms, you can tweak them, but a lot of times, I've even seen it inside Azure. Sometimes the auto-scaling takes a while, and they manually crank it up because it takes too long for the algorithm to work its way through the scaling. What about security? We probably want lots of backups of our data. Oh, that's a larger attack surface. People can go find backups, get access to things. Trade-offs. So we can have quicker recovery, but now we have more data with more access to it. We want something to be stable and reliable and not updated instantly, but we want to update it instantly because it's vulnerable. Who's ever delayed upgrading a library, a version of something, a NuGet package, an NPM, because they don't want it to break when you deploy it, right? Yeah. Trade-offs. Operational excellence. So as we start scaling things out, now we have multi-region. Maybe we have hot or hot-warm or log shipping. It starts to be a little bit more complex. So that means our deployment pipelines are more difficult. Our monitoring is more difficult. How it all works is more difficult, which means our documentation, our training adds overhead. It's harder to onboard teams into the environment because it's more complex. It's real easy when it's in one region and you right-click deploy. Don't do that. Don't do that. Don't do that. Anyways, and then performance. So instead of just writing to your database, now you put it on a message bus. You're using distributed, eventually consistent databases. Things start slowing down because you have global data stores now instead of a single database. So maybe you have a little bit slower reading and writing. Maybe you have to do some new systems to handle, has that message been processed or not processed? So it adds some layers of slowness, potentially, into the process. So there's lots of different trade-offs here that you need to think about. And that brings me to failure mode analysis. So this is where you not only need to think like a hacker, you need to think like Murphy's Law. You need to think like, what's the worst that could happen to our system? What if the power goes out at that data center? How do we keep operating? Are we in another data center? What if the router goes out? Do we have global networking in place? So you need to look for weaknesses in your architecture, in your infrastructure, in your software even, before they happen. So this is where it can be fun or challenging, depending upon how you want to look at the puzzle or the problem. When you've had outages, do you do root cause analysis? Do you go and look at what happened and identify the systems, the components? That way you can kind of prioritize these. And obviously, not everything happens. Like the odds of a meteor hitting your data center are low. The odds of screwing up a deployment and removing the permission are probably higher. So prioritize things based on the chance it could happen also. Like this is what we do in risk where I work. We talk about this stuff. We identify those single points of failure where if we're only running one of it, if everything's been routed through it, that's the area we target first. We want to remove our SPOFs. We want to identify those places where we can add redundancy in. And again, this can be in code, in data, in infrastructure. There's actually a great article, and I'll go to it because I want to talk through some of this with us. So I mentioned that the well-architected framework, there we go, has a bunch of things here. It has design principles, checklists, trade-offs, but it has all these recommendations. And I highly recommend you dive into these and like take a look at them. But I think that this table is a really great example of what a failure mode analysis looks like. You know, like what are the odds that Entra ID is going to go down? The likelihood of it. I mean, right after an outage, it probably feels like it's higher. And when I look at the outages and incidents that go through Microsoft from times, it feels like it's not low, but the odds are low. But what happens to your workload if your identity provider goes out? You're probably dead in the water. Like, oh, nobody can sign in. So understanding, oh, we have a full workload outages. We are dependent on Microsoft to go resolve this, and this is just going to knock us out if we have a problem. But we documented it. We know about it. What if we misconfigured it? What if we screwed up an identity or a scope or a permission? I mean, that's us. Like users might not be able to sign in. Like a lot of the services are going to be running, but just people who are trying to sign in won't be able to now. So now we're going to have help desk tickets, and it's going to be isolated potentially to some groups of people. So you start gaming through different scenarios in your head and looking at your configuration and looking at your architecture and looking at your code base and go, where are the places where we can fall down and break? Front door, like if front door has a problem, you know, it's a regional problem. Maybe we have an instance in another organization or another region. And we can look through a lot of these, like they've done it component by component. We depend on front door. Let's analyze our front door configuration. Here's SQL. What are some problems if we have an availability zone outage in SQL? Nothing. It doesn't affect us. So I highly recommend that you look through some of these examples. They're very helpful. All right. So regions. I mentioned that availability zones might not affect us if we're using the right services. So there's over 60 Azure regions. There's a number in Europe, a number in the States, and most continents and countries in the world. Each data center has a connection through the Microsoft backbone. So low latency, high capacity networks. There's even some sovereign clouds. So there's some for different governments. Don't get me started. And there's a great application out there, the region map. So these are all of the regions that are out there. So if we come over here, I think there's a few in this region, just a couple. And you can see some of the connections between them. So thinking about performance, reliability, regions are geographically dispersed. So usually something affecting one region does not affect another region. So if you're just worried about your hometown, pick a region near you. You'll have low latency, good connectivity. But if you want something global, maybe pick more than one. And that's where the idea of region pairs came in. So this was one of the first concepts that they had in Azure. So they had paired regions, like East and West US. And so like East would get some updates and then West would get some updates. So if you were in paired regions and they screwed up something in one region, the other region would be fine because it wouldn't be getting those updates yet. And it also has better recovery between them. So like if your East went down, maybe you were able to restore much quicker for your databases or files in West. It doesn't guarantee automatic failover, but it like had good high-speed connections. Now the problem is everybody was using paired regions, or a lot of people were using paired regions. So when something went down, everybody on those paired regions would flood to the other side. And you start seeing some traffic or capacity issues. And so there's also non-paired regions, and this is where you can make your own reliability choices. Like I might have load balancers in front of two non-paired regions, but I'll do my own geo read or recovery across whatever. But And this is where we were doing, I want active-active. So for really large organizations I've worked with, we do active-active. We have data in both regions, compute in both regions, maybe with regionally isolated identity or compute. That way, they didn't really need to share, or it would route to the appropriate place. And we would have something like front door or traffic manager in front of it to load balance. Active passive is you would just write to one region, and the other region would be getting data backups or eventually consistent access to a database. So read and read write on the primary and maybe read only on the secondary until it fails over, and then read write on the secondary. Like this works. This has worked for years. This has worked for tons of people in data centers for a long, long time. But we've been doing something a little different for the past couple of years with availability zones. And this has really been a big push where you might not need multiple regions if you don't need that sort of scale. And there's a lot of services that just work with availability zones, and you just get extra redundancy without really having to think about it. So availability zones are data centers inside the same region. So in East US, there's at least 3 data centers, zone 1, 2, and 3. They're geographically dispersed. So even though they're all east, they're quite a distance apart. They have independent power, independent network, independent cooling. And so, like for normal things, they have extremely low latency connections between them. And most services support availability zones. Most regions do. There's actually documentation. So if I go look at my regions list, you can see there's a region coming, or it's restricted, if they have a paired region, if it has availability zone support. So you can actually go through and find a nice selection of availability zone support near you, or a region near you that you want to leverage. Okay, stop doing that. Thank you. But there's also different types of zone support. So let's say you have availability zones. Not all services support availability zones. Some do, some don't. And this is like, if you take nothing else from this talk, I think understanding what zone redundant and zonal mean and how to leverage those in your solution. So you're going to see there's checkboxes for zone redundant and zonal based between different services. And it is going to keep shifting towards zone redundant kind of across the board, but there are some services where I don't think that will ever be possible. So, zonal. Zonal means it's pinned to a data center. So when you have a VM, it's going to run in a data center. It's not going to run in 3 data centers. It's going to run in 1 data center, probably with the same network and storage. So if you use a zonal service, you get 1. If you want to make that redundant, you got to have more than 1 and have a load balancer. That's on you. If you use zonal and you want it redundant, you have to do it. So you have to deploy the resource in each zone. You have to configure it. You have to replicate it potentially. You have to have a load balancer. And now guess what? That load balancer kind of looks like a single point of failure. Maybe, depending upon the one you choose. So you can have some issues here. Like, where's that load balancer run? Does it run in zone 1 or 2 or 3, or is it outside your zones? Are you doing front door to load balance? Like, if you have one box, that's where you think about, is that a single point of failure? But this is where you choose. Like, you have the most control. If it's zonal, you can choose. Do you want active-active? Do you want active-passive? Do you want a load balance between them? How do you want to handle redundancy? It's on you. If I go zone redundant, let's say I use a VM scale set, and I say, use availability zones. It's going to run them in multiple zones. It's going to load balance between them. Like, it'll handle it. Like, if I say I want 3, and one region goes down, it'll spin up a second one in one of the other regions that's still up. That's the idea behind zone redundant. We handle the routing of traffic between them. We handle the maintaining multiple instances. So, zone resistant resources are ones where You've deployed multiple zonal things and made it resistant, or you use our zone redundant stuff. It can survive a single zone going out. So it can survive a data center. So if there's a cable cut at a data center and it's no longer on the network, things in that data center will go out, but hopefully the traffic will bounce over to the other availability zones. It just minimizes downtime, and the non-zonal stuff, you can put it anywhere, and it really is up to you if something happens. If something goes down, it might affect you. So if I just say I want a LRS storage account, I want local storage, there's like 9 copies of the data, but they might all be in the same data center. So if a rack goes out, it'll survive, but if the data center goes out and I have a VM attached to it, the VM is probably going to reboot and go down because it depends on something. Now, when we use multiple availability zones, Microsoft updates them one at a time. That way, if something does go bad, it's isolated to a single availability zone and it's not everywhere. I mentioned LRS. So Azure Storage has a couple of different choices. So LRS is you actually have 11 nines of durability. So durability is an important aspect to resiliency. Like just because you have data doesn't mean the data is valid or good. You can have bit rot, you can have corruption. So having durability means that your data is reliable. Like it's the data you expect to get back. It's not corrupted. When you have LRS, it's just multiple copies in the same data center. When you start doing the ZRS, which is the next step up, there's like 3 copies of the data, I think, in each data center. So you pretty much have data in all of your regions. Then you can do GRS, so you can have multiple replicas in 2 different regions. So if your main region goes down, you can still get to your data because it's going to come from some other region in Azure. And then there's RAGS, which is GRS with read access. So, like, again, you can choose, remember that shared responsibility model, you can choose by choosing the right SKU and choosing the right architecture how reliable you want your stuff to be, how reliable you want your data access to be. And there's different patterns that you do for different scenarios. Like I said, it depends on your business requirements. Not everyone is Walmart, not everybody is a mom and pop local shop that has their geo pages set up for their small business or uses Square or Shop. Like there's a spectrum of choices. So maybe a line of business app just needs to be reliable with minimal downtime. You might choose zone redundant. But maybe it's an internal app that you're just POCing and trying something out that might have different requirements. Or if it's healthcare or banking or SaaS, you might have different SLAs and contractual obligations. So you choose from this toolbox of things on how you want to use it. Now we can really enhance our reliability by architecture. You know, we're trying to isolate failures, we're trying to distribute workloads, and we're trying to use availability zones where they are. And there's a lot of good design patterns and reference architectures that we can use. But what I always tell people is if you're just architecting solutions and you're just drawing boxes and arrows, you don't know if it survives. You don't know if you're reliable until you start load testing. So, and there's different types of load tests. Like there's a soak test where, you know, if you want to be able to handle 100 requests per second, send it 100 requests per second and just hold it. If you're supposed to be able to do that load for hours, then nothing bad should happen. You shouldn't have a bottleneck where it starts to build pressure in parts of the system, and then your response times start to tank after 30 minutes, and then now you can't meet the definition. You've identified a problem that you didn't see because you were just holding traffic. Maybe you do a spike test where you do like 2 or 3 times your expected traffic, and you've got a big rush of customers, and then you drop it back down to below your minimum. And just to see, does the system recover from that spike? Does the flood get mitigated over time? Maybe you want to just do a stress test and just keep building traffic until the whole thing crashes so you can identify the weak points and single points of failure and bottlenecks. There's different types, but understanding how your system behaves at load, at scale, is important. You can't just design it on paper. You have to test the living thing. Does your auto-scaling work? Does your monitoring work? Did you see why it failed and where the traffic and where the pressure went? Like, it tests all parts of your system. What's great is you can put this in your pipeline. So you can run these things on a schedule. Every time you check in, you can do a load test and check for performance. There's Azure Load Testing Service. You can use Playwright. You can use Selenium. There's all sorts of options, but most of these can be defined in code and run on a schedule or run on a pipeline. And yeah, people might complain, oh, we sent a lot of traffic to our system. We maxed it out once a month. Still cheaper than an outage. The other thing is chaos engineering, so chaos testing. And this is another fun one. I highly recommend doing it as well. What happens when you simulate a zone failure? What happens if you simulate, I can't access my key vault? Does the system break down? Does it fail over properly? What happens if we just turn off a cluster? Does it hop to the other cluster, send the traffic there? So there's different ways to do this. You can validate these things. You can validate networking issues and low latency problems. There's an Azure Chaos Testing or Azure Chaos Studio, but there's a ton of open source tools that you can leverage on Kubernetes and AKS to simulate a lot of these things. CPU pressure, memory pressure, network traffic, killing off random pods, killing off nodes. All of these things you can validate and test, and you can do it in a pipeline. I have some links to a bunch of samples, and I'll point you guys at a couple of them as we go. But these are things you do during business hours when people are on call. Because you want it to happen when people are ready. You don't want it to happen at 2 in the morning when you're not planning on it. Again, test your boxes and arrows. Make sure they actually work and scale. So find these issues early. You have more confidence because you've done it. You've tested it. You validated it. It's going to reduce your time to recovery and time to detection. Some of the numbers that we look at every week on reports at Microsoft, we call them TTX. Time to detect, time to respond, time to mitigate. These are the numbers we're trying to drive down constantly. And so if you're not looking at these and simulating these, they might not work if you haven't tested them. Start very simple, and you can build from there. Have, like they said, game days, schedule it, and build it in your pipelines. Practice this. We get better at stuff because we practice this. This is where operational excellence comes into play. When I talk a lot around DevOps and people do a deployment and they have a failure, then I hear well, maybe we should move to 3-week sprints and we should do a hardening week. Has anyone ever heard that one? We screwed up, let's do a hardening week? Okay, what happens when you screw up in the hardening week? Do you let's just deploy every other sprint? Let's deploy once a quarter, once a year? Now you're not really good at deploying. You're bad at it. You get better at it by doing it more often. So if you're not testing your logging and your recovery and all that, you get bad at it. So practice this stuff. So there's a lot of resources and architectures and references out there that we can point at that show us, like Jimmy was saying, how does Aspire do it? How do Microsoft implement these things? And what are the tools I can use to check these things for myself? So I'm sure you've heard them before, landing zones. A lot of times landing zones have a good foundation. They have isolation and identity and networking and application subscriptions. I usually recommend pointing at them, maybe not something super complex like the enterprise one, but I recommend landing zones. The Architecture Center itself has some really good, interesting solutions that you can play with there, and you can actually come in here and browse them and look for specific architectures and things. The well-architected workloads. Now, this is one that I actually really enjoy. So I'm gonna, there we go, open it in a tab. So as we've started to build things, they have some specific requirements we have to look at. There is an AI workload where there's a recommended guidance and sample solutions that we can dive into for a baseline OpenAI architecture, where we want it to be resilient, following the best practices. Maybe we put an application gateway or AI gateway in front of our ChatGPT instances. Maybe we have redundancy built in. So it's not just the generic recommendation on how to build a solution, it's one that is well architected and aligns to our pillars, like VMware, SaaS, SAP, and then there's mission critical. So we actually have a mission critical workload as well that you can go look at and dive into, and there's some sample infrastructure as code, there's sample pipelines, there's sample code. One of these is the enterprise app patterns. Like that's something that we've also started to build out, the enterprise web app patterns, and they have a .NET implementation and a Java implementation. And this really aligns with kind of what I was talking about before. Let me go to, I'll just pick the .NET one for now. They're going to go through not just, here's a pattern. They go through all of the logic and thinking and why we chose this component. What is the guidance we have? What is the SLOs that we can reach? And maybe we start with a stamp in one region. We have our application, and we have configuration, and we have caching to help with scale. We have private endpoints to help with security, and we have performance monitoring in place. But maybe as we start scaling out, we add other stamps. We start expanding it. So we think about the components in isolation, and then we start looking at how we can remove the single points of failure, start adding additional components to scale our workloads. And this is all documented. They even have, like, you can use hub-spoke technology. They talk about why they're picking each different component with the SLAs, with the management overhead, because like we said earlier, it's not just about the technology. Sometimes it's about the hours you have to put in maintaining it, restoring it, configuring it, caching. So these patterns are available for you to use and build with. Another thing that I leverage a lot, does anyone do Terraform or Bicep or ARM? Okay, a lot of hands. Who goes out to the Azure Resource Learn page and looks at the documentation specifically for your resource, and then like copies that Bicep or that Terraform sample, and then like wraps it in your own code to make it plug into your internal libraries? Anyone make their own like Bicep libraries? Yeah. You don't need to do that. I wouldn't do that as much. But so Azure Verified Modules, I've actually helped make a couple of these. We had like 2 or 3 different initiatives inside Microsoft a couple of different times, and they all kind of failed at some point. We had the Bicep like standard library. We had Terraform modules. So Azure Verified Modules is actually every component is supposed to have a Microsoft full-time engineer assigned to it so that we can respond to issues, make sure it builds, update it when the resources get updated. We also have wrappers for each resource that align to WAF. So they're secure, they're reliable, they have samples on how to leverage them. And then we have patterns on top of that. So let's say we look at Bicep. So you can see we have a ton of published modules. We have owners for each one. We have status of our build. We got AVM. There's over 100. Let's just look at, there's one I was looking for. App Insight, whatever. If I come here, I'm going to see information about everything. It's going to document the types and API versions it uses. And then we have these uses examples. I just want to reference it from a module. And so I don't have to have it in my code. I don't have to have it checked in. I can actually just register it from the Bicep public registry and say, just go use this version of the official AVM published module. I'm just going to consume that straight off the internet, and here's some parameters I need. But maybe I want a more complex parameter, or I want to use a large parameter set and like really customize it. Like they've already taken and aligned and exposed all of the properties of the resource in an easy way for you to tweak and consume. And it's all documented quite well. Like the type, what it is, how to use it, and the outputs. So stop wrapping the documentation with your own classes. Like leverage these. These are supported. I want to recommend that. Like I really do. And then, like, let's say we look at Terraform, and we have some Terraform patterns. Well, I can come down here and look at some of these. So we've got a like hub networking Terraform module. Landing zone firewall. And there's all the Terraform documentation for it and how to configure it. So all of the hard work's been done on both Terraform and Bicep, and they are wrapped with resilient stuff. Like it has a default recommendation for maybe multiple instances or a configuration with the right SKU that will help you, or availability zones turned on out of the box. Like these are simple things that are easy to forget. And there's actually a lot of services out there that if you, let me just go here and go Azure availability zones. If you create a service without availability zones, not all of them let you migrate. So like for some of these, you can. Like if I have a container registry, I can go enable it. But for some of them, it's like you can't do this after creation time. Like you have to delete it and make a new one if you want availability zone support. So if you're doing it through infrastructure as code and you're doing it with the modules, you're going to get that stuff turned on by default. There's also April. I don't know if any of you guys have heard of this. Let's say you have already deployed your solution and you want to test it. You want to see how resilient you are. Are there things that you missed? Are there configurations that you should do? So April is a series of PowerShell scripts and that call out to the Azure CLI. All right, there's the GitHub pages site. So it queries your active deployments. It actually looks at what you've deployed and how you've configured it, and it checks, did we configure it right? So if I look at like my Key Vault should have soft delete. They should have purge protection. This is actually going to check all of your Key Vaults and see if they match. A lot of these recommendations you might see also in Advisor. Azure Advisor will have some resiliency recommendations, but these go far beyond it in some cases. And these will like dig into like your container services, your compute services, your like Kubernetes clusters. Did you isolate your system and app pools? Do you have monitoring? Do you have a SKU for highly available configured? So you can just run this on your subscription, your resource group, your individual components, and get a report back on areas you can adjust today. Like there's also Azure review checklists. So I've contributed to AVM, I've contributed to April, and my team before, when we were in Fast Track, we wrote these review checklists. These review checklists were, again, built by Fast Track for Azure. And so you will pick a workload and be like, hey, I want to go check for security, for reliability, for a landing zone. And these are just questions that you can go ask yourself and go check out in the portal and see, have I configured things properly? So, focus on your design principles, understand your requirements, understand your components, understand what the business is trying to do, and get the right level of reliability, recovery. Understand those trade-offs, make sure you're not just looking at the cost cutting, and understand that there's going to be impact. Test these things continuously, like try a load test, try a chaos test, play with this stuff. All the resources are available out at GitHub on my site. Please go check out April, AVM, the checklists, and the enterprise web apps. And with that, questions. I want to make sure, I've helped a lot of customers do a lot of things, and I'm sure that there are some specific questions about reliability or resiliency. So if anyone has questions, I'm more than welcome to take them now, or afterwards I'll be around. But thank you guys.